Vitamins are essential nutrients that our bodies need to function properly. They are organic compounds that we usually obtain from our food and are required in small amounts for various biological processes. There are 13 recognized vitamins, and they can be divided into two main categories: fat-soluble vitamins and water-soluble vitamins. 1. Fat-soluble vitamins. These vitamins are absorbed with the help of dietary fat and can be stored in the liver and fat tissues for future use. The 4 fat-soluble vitamins are vitamin A, retinol, important for vision, immune function, and skin health. Found in liver, fish oils, and colorful fruits and vegetables. Vitamin D helps the body absorb calcium. Promoting bone health. It is produced by the skin when exposed to sunlight and can also be found in fortified foods. And fatty fish. Vitamin E acts as an antioxidant, protecting cells from damage. Found in nuts, seeds, and vegetable oils. Vitamin K, essential for blood clotting and bone health. Found in leafy green vegetables, broccoli, and Brussels sprouts. 2. Water-soluble vitamins. These vitamins dissolve in water and are not stored in the body, so they must be replenished regularly through diet. They are excreted in urine when excess amounts are consumed. The water-soluble vitamins are vitamin C, ascorbic acid, supports the immune system, aids in collagen production for skin, and acts as an antioxidant. Found in citrus fruits, strawberries, and bell peppers. B vitamins, a group of 8 vitamins that help convert food into energy and support brain function. They include B1, thiamine, helps convert carbohydrates into energy and supports nerve function. B2, riboflavin, important for energy production and skin health. B3, niacin, supports metabolism, skin health, and nervous system function. B5, pantothenic acid, important for the synthesis of coenzyme A, involved in energy production. B6, pyridoxine, essential for amino acid metabolism, neurotransmitter synthesis, and red blood cell production. B7, biotin, supports metabolism and the health of hair, skin, and nails. B9, folate or folic acid, crucial for cell division and the formation of DNA, especially important during pregnancy. B12, cobalamin, important for nerve function, red blood cell formation, and DNA synthesis. Found primarily in animal products. Importance of vitamins. Support metabolic processes. Vitamins are involved in converting food into energy and helping the body produce important molecules like neurotransmitters and hormones. Immune health. Many vitamins, especially vitamin C and vitamin D, are critical for maintaining a healthy immune system. Bone and skin health. Vitamin D, vitamin A, and vitamin K play key roles in keeping bones and skin strong. Prevention of deficiencies. Insufficient intake of vitamins can lead to various health issues, such as scurvy, vitamin C deficiency, rickets, vitamin D deficiency, or anemia, vitamin B12 deficiency. Since vitamins must come from the diet, it is important to eat a balanced and varied diet that includes fruits, vegetables, whole grains, proteins, and healthy fats to ensure adequate intake of these vital nutrients. Fat-soluble vitamins. Vitamin A. It plays a critical role in maintaining healthy vision, particularly in low light conditions. It is also crucial for maintaining the health of the skin and mucous membranes, which act as barriers to infection. Additionally, it supports the immune system and cell growth. There are 2 main types of vitamin A. Preformed vitamin A, found in animal products like liver, eggs, and dairy, and provitamin A, found in plant foods like carrots, spinach, and sweet potatoes. Vitamin D. It helps maintain proper levels of calcium and phosphorus in the blood, which are essential for bone formation. Inadequate vitamin D levels can lead to weakened bones in conditions like osteomalacia, softening of the bones, or osteoporosis. Additionally, vitamin D plays a role in reducing inflammation and boosting the immune system. Vitamin D can be synthesized by the body when exposed to sunlight, but many people may still need to supplement it, especially in areas with limited sunlight or during the winter months. Vitamin E. This vitamin is a powerful antioxidant, protecting cells from oxidative damage caused by free radicals. It is also important for immune function and skin health. Since vitamin E is fat-soluble, it's important to consume it with dietary fats to help absorption. It can be found in nuts, especially almonds, seeds, vegetable oils, and green leafy vegetables. Vitamin K. There are two main forms of vitamin K, K1, phylloquinone, found in green leafy vegetables, and K2, menaquinone, found in fermented foods and animal products. Vitamin K is essential for blood clotting, helps prevent excessive bleeding, and also plays a role in bone health by supporting the regulation of calcium in the bones and tissues. Water-soluble vitamins. Vitamin C. Besides being a powerful antioxidant, vitamin C is essential for the synthesis of collagen, a protein that helps in the maintenance of skin, blood vessels, and bones. It also helps in the absorption of iron from plant-based sources. A deficiency in vitamin C can lead to scurvy, characterized by fatigue, gum disease, and skin issues. Good sources of vitamin C include citrus fruits, oranges, lemons, strawberries, bell peppers, broccoli, and tomatoes. B vitamins. Vitamin B1, thiamine. Thiamine is vital for converting carbohydrates into energy, and it plays an important role in nerve function. A deficiency can lead to a condition known as beriberi, which affects the cardiovascular and nervous systems. Vitamin B2, riboflavin, it is important for energy production and the metabolism of fats, proteins, and carbohydrates. Riboflavin also helps maintain healthy skin, eyes, and nerve functions. Dairy products, eggs, lean meats, and leafy greens are good sources. Vitamin B3, niacin. Niacin helps convert food into energy and supports the nervous system and digestive system. Severe niacin deficiency can lead to pellagra, which results in symptoms like dermatitis, diarrhea, and dementia. Good sources include poultry, fish, whole grains, and legumes. Vitamin B5, pantothenic acid, essential for the synthesis of coenzyme A, which is involved in the breakdown of carbohydrates and fats for energy production. It also helps synthesize steroid hormones. It's widely available in many foods, including eggs, avocados, and sweet potatoes. Vitamin B6, pyridoxine, important for the metabolism of proteins, the production of neurotransmitters like serotonin, and red blood cell formation. Vitamin B6 is also involved in immune system support. It can be found in fish, poultry, bananas, and potatoes. Vitamin B7, biotin, often associated with the health of hair, skin, and nails. Biotin also plays a role in the metabolism of fatty acids, amino acids, and glucose. Biotin is found in foods such as eggs, nuts, seeds, and some vegetables like sweet potatoes. Vitamin B9, folate. Folate is essential for DNA synthesis, which makes it especially important for pregnant women to support fetal development and prevent neural tube defects. Foods rich in folate include leafy greens, legumes, nuts, and fortified cereals. Vitamin B12, cobalamin. This vitamin is key to nerve function, the production of red blood cells, and the synthesis of DNA. Vitamin B12 is found primarily in animal products like meat, dairy, and eggs, which is why vegetarians and vegans may need to consider supplementation. Vitamin deficiencies and health effects. Each vitamin plays a vital role in the body, and deficiencies in these nutrients can lead to a wide range of health problems. Some common vitamin deficiency conditions include vitamin A deficiency, can cause night blindness, weakened immune function, and skin issues. Vitamin D deficiency can lead to rickets in children, softening of the bones, and osteomalacia or osteoporosis in adults. Vitamin C deficiency leads to scurvy, characterized by bleeding gums, joint pain, and skin bruising. Vitamin B12 deficiency can lead to pernicious anemia, neurological issues, and fatigue. Vitamin K deficiency results in easy bruising and excessive bleeding. How to ensure adequate vitamin intake. Balanced diet. Eating a wide variety of foods from all food groups ensures that you get enough vitamins. Focus on fresh, whole foods like fruits, vegetables, whole grains, lean proteins, and healthy fats. Fortified foods. Some foods are fortified with vitamins, such as milk fortified with vitamin D. cereals fortified with B vitamins, or plant-based milks fortified with vitamin B12. Supplements. If you are unable to get enough vitamins from your diet due to health conditions, dietary restrictions, or other reasons, supplements can help fill the gap. However, it is always best to consult with a healthcare professional before starting any supplementation. Toxicity and overconsumption. While vitamins are essential for health, it is also important not to overconsume them. Especially fat-soluble vitamins, A, D, E, and K, as they can accumulate in the body and lead to toxicity. Water-soluble vitamins are generally excreted in urine if consumed in excess, but they can still cause issues if taken in large amounts. In conclusion, vitamins are essential nutrients that play numerous roles in keeping the body functioning properly. Ensuring you have a well-rounded, nutrient-rich diet is the best way to meet your vitamin needs and maintain good health. Vitamin interactions. Vitamins often work together with other nutrients in the body to perform their functions. For example, vitamin D and calcium. Vitamin D is essential for calcium absorption in the intestines, helping to build and maintain strong bones. Without enough vitamin D, calcium absorption is compromised, which can lead to bone diseases like osteoporosis or rickets. Vitamin C and iron. Vitamin C enhances the absorption of non-heme iron, the type of iron found in plant-based foods, like legumes, spinach, and fortified cereals. Consuming vitamin C-rich foods with iron-rich plant foods can help prevent iron deficiency anemia. Folic acid, B9, and vitamin B12. These two B vitamins work together to ensure proper red blood cell formation and DNA synthesis. A deficiency in one can often mask the symptoms of the other, particularly in cases of vitamin B12 deficiency, leading to potential complications. Vitamin A and zinc. Zinc is needed for the conversion of beta-carotene, a form of vitamin A, into the active form of vitamin A in the body. Zinc deficiency can impair this process, leading to reduced vitamin A activity. Fat-soluble versus water-soluble vitamins. Storage and absorption. Fat-soluble vitamins, because they are stored in the body, mainly in the liver and fat tissues, fat-soluble vitamins can accumulate to toxic levels if taken in excess over time. They require dietary fat for absorption and can stay in the body for a longer period, so they don't need to be replenished as frequently as water-soluble vitamins. Water-soluble vitamins. These vitamins are not stored in the body, so they need to be consumed more regularly to maintain adequate levels. Since they are excreted through urine, there's a lower risk of toxicity compared to fat-soluble vitamins. However, high doses of water-soluble vitamins, especially B6, niacin, and vitamin C, can still cause adverse effects. Sources of vitamins in food. Here is a more detailed list of food sources for each vitamin. Vitamin A. Animal sources, like liver, fish, eggs, and dairy. Plant sources include carrots, sweet potatoes, spinach, kale, and other dark leafy greens. Beta-carotene, found in plant foods, is converted into vitamin A in the body. Vitamin D. Fatty fish, salmon, mackerel, sardines, fortified dairy products, fortified cereals, egg yolks, and mushrooms. The body also produces vitamin D when the skin is exposed to sunlight. Vitamin E. Nuts, especially almonds and hazelnuts, seeds, vegetable oils, sunflower, wheat germ, safflower, spinach, and broccoli. Vitamin K. Leafy green vegetables, such as kale, spinach, and broccoli, Brussels sprouts, cabbage, and fermented foods like natto, fermented soybeans. Vitamin C. Citrus fruits, oranges, lemons, grapefruits, strawberries, bell peppers, broccoli, kiwi, and tomatoes. B vitamins. B1, thiamine, whole grains, pork, legumes, and seeds. B2, riboflavin, dairy products, eggs, meat, leafy vegetables, and enriched cereals. B3, niacin, poultry, fish, lean meats, whole grains, and peanuts. B5, pantothenic acid, eggs, avocado, sweet potatoes, and whole grains. B6, pyridoxine, poultry, fish, potatoes, bananas, and chickpeas. B7, biotin, eggs, nuts, seeds, and sweet potatoes. B9, folate, leafy greens, legumes, citrus fruits, and fortified cereals. B12, cobalamin, found primarily in animal products like meat, fish, eggs, and dairy. It is not found in plant-based foods, so vegans may need supplements or fortified foods. Vitamin deficiency symptoms. Here are some common deficiency symptoms associated with various vitamins. Vitamin A. Night blindness, dry skin, increased susceptibility to infections. Vitamin D. Bone pain, muscle weakness. Increased risk of fractures, fatigue, and in severe cases, rickets in children or osteomalacia in adults. Vitamin E. Muscle weakness, vision problems, and impaired immune function. Vitamin K. Easy bruising. Excessive bleeding, and difficulty clotting. Vitamin C. Fatigue, easy bruising, bleeding gums, joint pain, and scurvy. Vitamin B1. Thiamine, fatigue, irritability, nerve damage, and in severe cases. Beriberi, affecting the cardiovascular or nervous system. Vitamin B2. Riboflavin, sore throat. Cracks or sores on the lips and mouth, chylosis, red, inflamed tongue. Vitamin B3. Niacin, pellagra. Characterized by dermatitis, diarrhea, and dementia. Vitamin B6. Pyridoxine, irritability, depression, confusion, and nerve damage. Vitamin B9. Folate, fatigue, weakness, irritability, and in pregnant women. Increased risk of neural tube defects in the baby. Vitamin B12. Cobalamin, fatigue, weakness, pale skin, numbness, tingling in the hands and feet, and cognitive decline. Excessive vitamin intake and toxicity. While it's important to get enough vitamins, excessive intake can sometimes lead to toxicity, particularly with fat-soluble vitamins that accumulate in the body. Here are some examples. Vitamin A toxicity can lead to nausea, headache, dizziness, liver damage, and bone pain. Chronic overconsumption can lead to birth defects if taken in excess during pregnancy. Vitamin D toxicity can cause elevated calcium levels in the blood, hypercalcemia, leading to nausea, vomiting, weakness, kidney stones, and calcification of soft tissues. Vitamin E toxicity, while rare, excessive vitamin E can interfere with blood clotting, leading to an increased risk of bleeding. Vitamin K toxicity. Although rare, excessive intake of vitamin K can interfere with anticoagulant medications, blood thinners, and affect their effectiveness. Managing vitamin intake. Personalized diet. The optimal intake of vitamins varies based on age, gender, health status, and lifestyle. For instance, pregnant women, young children, older adults, and vegetarians, vegans may need higher amounts of specific vitamins like folic acid, vitamin D, and B12. Supplements. While food should be the primary source of vitamins, supplements may be needed in certain cases, e.g., for people with restricted diets, older adults, or those with certain health conditions. However, excessive use of supplements can be harmful, so it's best to follow the guidance of a healthcare provider. Conclusion. Why vitamins matter. Vitamins are indispensable for maintaining health, supporting metabolic processes, ensuring proper immune function, promoting growth and repair, and preventing chronic diseases. A balanced, nutrient-rich diet is the key to providing the body with all the essential vitamins it needs. Ensuring a variety of foods in your daily meals, from fruits and vegetables to lean proteins, whole grains, and healthy fats, will ensure that your vitamin requirements are met and promote optimal health. If you suspect a deficiency or are unsure about your vitamin needs, it's always a good idea to consult with a healthcare provider or nutritionist to address any concerns. Vitamins and disease prevention. Vitamins play an essential role in preventing chronic diseases and conditions. Many health experts believe that proper vitamin intake can help reduce the risk of serious illnesses like heart disease, cancer, and age-related conditions. Below are examples of how vitamins can contribute to disease prevention. Heart disease. Vitamin B6 and B12 help regulate homocysteine levels in the blood. High homocysteine is associated with an increased risk of heart disease and stroke. Adequate intake of these vitamins, especially B6 and B12, may help lower homocysteine levels. Vitamin E acts as an antioxidant and has been studied for its role in protecting the heart by preventing oxidative stress that can damage blood vessels and promote atherosclerosis, hardening of the arteries. Cancer prevention. Vitamin C is a powerful antioxidant that helps protect cells from oxidative damage, which is one of the mechanisms through which cancer can develop. It also plays a role in immune defense and the repair of DNA. Vitamin D has been extensively studied for its role in reducing the risk of several types of cancer, including breast, prostate, and colorectal cancers. It helps regulate cell growth and promotes apoptosis, cell death, in abnormal cells, which is essential in cancer prevention. Folate, vitamin B9, is involved in DNA synthesis and repair. Adequate folate intake can reduce the risk of certain cancers by preventing DNA mutations that can lead to cancer. Bone health. Vitamin D and calcium are well known for their role in maintaining strong bones. Vitamin D enhances calcium absorption in the gut, ensuring that the body gets enough calcium to build and maintain bone density. Insufficient intake of either vitamin D or calcium can lead to osteoporosis and fractures, particularly in older adults. Vitamin K is also essential for bone health because it helps in the synthesis of osteocalcin, a protein that binds calcium to the bone matrix. This ensures that calcium stays in the bones and isn't deposited in soft tissues. Eye health. Vitamin A is crucial for maintaining good vision, especially in low-light conditions. It is a key component of the pigment in the retina called rhodopsin, which helps the eye detect light. Vitamin C also plays a role in eye health by protecting against oxidative stress, which can contribute to the development of cataracts and age-related macular degeneration, AMD. How lifestyle factors impact vitamin levels. Our lifestyle choices can significantly affect how our bodies absorb, use, and store vitamins. Here are some key factors that influence vitamin levels. 1. Diet. Poor dietary choices. Diets that are high in processed foods, sugars, and fats but low in fruits, vegetables, and whole grains may lead to vitamin deficiencies. For instance, a diet lacking in fruits and vegetables can result in insufficient vitamin C and other antioxidants. Vegetarian or vegan diets. People who follow vegetarian or vegan diets may have difficulty obtaining certain vitamins, like B12, since it's primarily found in animal products, and D, which is mainly synthesized from sunlight or obtained from fortified foods. Vitamin A can also be challenging to get, as it's found in its active form only in animal-based foods, though beta-carotene in plant foods can help convert into vitamin A. Fortified foods. In many countries, foods are often fortified with essential vitamins and minerals to help fill gaps in the diet. For example, vitamin D is commonly added to milk and cereals, and folate is added to grain products to reduce the risk of neural tube defects in babies. 2. Sunlight exposure. For vitamin D and sunlight, one of the key factors that affect vitamin D levels is sunlight exposure. The skin synthesizes vitamin D when exposed to ultraviolet, UV, rays from the sun. People who live in regions with long winters or limited sunlight may have lower levels of vitamin D and might need to obtain it from food or supplements. Similarly, individuals with darker skin tones may need more sunlight exposure to produce adequate vitamin D. Sunscreen. While sunscreen is important to protect skin from UV damage, it can reduce the body's ability to produce vitamin D from sunlight. People who use sunscreen frequently or avoid sun exposure may need to consider getting vitamin D from dietary sources or supplements. 3. Age and gender. Aging. As we age, the body's ability to absorb and process vitamins can decline. For example, older adults often produce less stomach acid, which impairs the absorption of vitamin B12. Older adults may also have a lower ability to synthesize vitamin D in the skin due to less sun exposure or reduced skin function. Pregnancy and lactation. During pregnancy and breastfeeding, women have increased vitamin needs. For example, folate is especially important during pregnancy for fetal development, while vitamin D supports bone health for both mother and child. Pregnant women are also at higher risk of iron and calcium deficiencies. 4. Medical conditions and medications. Certain medical conditions and medications can interfere with vitamin absorption or increase the need for specific vitamins. Celiac disease and Crohn's disease. These gastrointestinal disorders can impair nutrient absorption, including vitamins A, D, E, and K. Type 2 diabetes. People with diabetes may be at risk for deficiencies in vitamin D, which plays a role in insulin sensitivity and glucose metabolism. Medications. Some medications, such as certain diuretics, antacids, and antibiotics, can interfere with vitamin absorption or metabolism. For example, antacids may reduce the absorption of vitamin B12, while antibiotics can affect the balance of gut bacteria, potentially lowering the availability of certain vitamins produced by these bacteria, like biotin. 5. Alcohol and smoking. Alcohol. Excessive alcohol consumption can impair the liver's ability to store and process vitamins. Chronic alcohol use is associated with deficiencies in B vitamins, especially B1, B6, and B12, folate, and vitamin A. Smoking. Smoking increases oxidative stress and depletes vitamin C levels in the body, as vitamin C acts as an antioxidant that helps protect cells from damage caused by free radicals. Smokers may require higher vitamin C intake to counteract the effects of smoking-related damage. The role of supplements. While it's always best to get vitamins from food, supplements can be helpful in certain situations. Dietary restrictions. People with specific dietary restrictions, such as vegans or people with food allergies, may need to take supplements for nutrients like vitamin B12 or vitamin D. Health conditions. People with certain medical conditions, like osteoporosis or iron deficiency anemia, may need additional vitamins or minerals to support their health. Age and life stage. Pregnant women, older adults, and individuals with specific health concerns may benefit from supplements to meet their higher nutritional needs. However, it's important to use supplements wisely. Overuse of certain vitamins, especially fat-soluble ones, like A, D, E, and K, can lead to toxicity. It's always advisable to consult a healthcare professional before beginning any supplement regimen. Conclusion. The big picture on vitamins. Vitamins are essential for maintaining various physiological functions in the body, from supporting immune health to maintaining healthy bones, skin, and eyes. They also play a role in disease prevention, including reducing the risk of chronic conditions such as heart disease, cancer, and osteoporosis. To get the most out of vitamins, it's important to maintain a balanced diet that includes a variety of nutrient-rich foods and to consider lifestyle factors that can affect vitamin levels, such as age, sun exposure, and medical conditions. Supplements can be a helpful tool in some cases, but they should complement, not replace, a healthy diet. By staying informed and making conscious dietary choices, you can ensure your body receives the vitamins it needs for optimal health and well-being. Vitamins in metabolic processes. Vitamins play a critical role in various metabolic processes, which are the chemical reactions that occur in the body to maintain life. These processes include energy production, the synthesis of proteins and hormones, and the regulation of body functions. Energy production. Many B vitamins are involved in converting carbohydrates, fats, and proteins into usable energy for the body. B1, thiamine, B2, riboflavin, B3, niacin, and B5, pantothenic acid, are all essential for energy metabolism. They help convert food into glucose, which the body uses for energy. Vitamin B6 is involved in amino acid metabolism and the production of neurotransmitters that influence brain function, while B12 is important for red blood cell production and for maintaining healthy nerve function. Fat and protein metabolism. Vitamin A contributes to the metabolism of fats and proteins, and it is essential for cell growth and differentiation. This is particularly important for skin health and vision, but it also supports the metabolism of other nutrients. Vitamin E, being a potent antioxidant, helps prevent oxidative damage that can occur during fat metabolism, especially in tissues like the liver. Cellular metabolism and DNA repair. Vitamin C is involved in collagen synthesis and helps in wound healing. Collagen is a vital protein that is essential for skin, blood vessels, tendons, and ligaments, and it also plays a role in cellular metabolism. Folate, vitamin B9, is involved in the synthesis of DNA and RNA. Adequate folate intake is essential for cell division and growth, which is crucial during pregnancy and for proper fetal development. It also helps in the metabolism of homocysteine, an amino acid that can cause damage to blood vessels when present in high levels. Vitamins and mental health. Vitamins not only support physical health but are also key players in mental health and cognitive function. Deficiencies or imbalances in certain vitamins can influence mood, cognition, and mental well-being. Vitamin D and mood regulation. Vitamin D has been linked to mood regulation, and a deficiency in this vitamin is often associated with depression, especially during the winter months when sunlight exposure is limited. Low vitamin D levels have been linked to conditions like seasonal affective disorder, SAD, and depression. Serotonin, the feel-good neurotransmitter production in the brain, is also influenced by vitamin D levels. Adequate vitamin D intake has been shown to increase serotonin receptors in the brain, which can help improve mood. Vitamin B12 and cognitive function. Vitamin B12 is crucial for cognitive health because it helps in the synthesis of neurotransmitters such as dopamine and serotonin, which regulate mood and cognitive function. A deficiency in vitamin B12 can lead to cognitive impairment, memory loss, and even mood disturbances like depression and anxiety. Older adults are especially at risk for B12 deficiency, which may result in confusion, memory problems, and other cognitive issues. Folate and depression. Folate, vitamin B9, is another vitamin that has been linked to mood regulation and mental health. Folate plays a role in the synthesis of serotonin and other neurotransmitters. Low levels of folate have been associated with depression, and supplementing with folate has been shown to improve mood in some people. Research also suggests that women with low folate levels during pregnancy may be at higher risk for postpartum depression. Vitamin C and stress. Vitamin C is known for its ability to reduce oxidative stress in the body. When the body is under stress, the levels of cortisol, a stress hormone, increase, and this can lead to an increased need for vitamin C. Vitamin C helps regulate cortisol levels and also supports the adrenal glands in producing hormones that manage stress. A deficiency in vitamin C can lead to increased stress and anxiety. Vitamins and immune system support. The immune system requires various vitamins to function optimally. Some vitamins are directly involved in immune cell function and the body's ability to defend against infections. Vitamin A and immune function. Vitamin A is critical for the health of epithelial tissues, such as skin, lungs, and gut lining, which serve as the first line of defense against infections. It helps to maintain the mucous membranes, which trap pathogens and prevent them from entering the body. Vitamin A also regulates the production of white blood cells, which are essential for fighting infections. Adequate vitamin A intake has been shown to improve immune responses and reduce the risk of infection. Vitamin C and immunity. Vitamin C enhances the immune system by supporting the function of white blood cells that protect the body from infections. It also helps maintain the skin, which is an important barrier to pathogens, and supports the healing process if the body becomes injured. Vitamin C is also known to boost the production of antibodies and plays a role in the healing of wounds. Some studies suggest that vitamin C supplementation can shorten the duration and severity of the common cold. Vitamin D and immune regulation. Vitamin D is essential for immune function, especially in the regulation of both the innate and adaptive immune responses. It helps activate T cells, which play a central role in identifying and attacking infections. Low levels of vitamin D are associated with an increased susceptibility to infections such as the flu, respiratory infections, and even autoimmune diseases. Vitamins and skin health. The health of your skin is closely tied to your vitamin intake. Several vitamins support skin regeneration, repair, and protection from environmental damage. Vitamin A for skin health. Vitamin A is essential for skin cell production and repair. It helps maintain the skin's structure, supports the production of collagen, and promotes cell turnover. Retinoids, which are derived from vitamin A, are commonly used in skincare products for treating acne and signs of aging. Vitamin C for skin health. Vitamin C is crucial for collagen synthesis, which is the protein that gives the skin its strength and elasticity. It also acts as an antioxidant, protecting the skin from damage caused by free radicals, unstable molecules produced by UV rays, and pollution. Regular vitamin C intake may help reduce the appearance of wrinkles and fine lines, and it can promote the healing of wounds and cuts. Vitamin E for skin protection. Vitamin E acts as an antioxidant, protecting the skin from damage caused by oxidative stress, UV radiation, and environmental pollutants. It is often used in topical creams and lotions to reduce the appearance of scars and improve skin hydration. Vitamin E also plays a role in reducing inflammation and supporting the skin's ability to repair itself after sun damage or injury, deficiency and toxicity. While it's important to get adequate amounts of vitamins, too much or too little can cause problems. Deficiency, as discussed earlier. Vitamin deficiencies can lead to a wide range of health problems, from cognitive impairment to immune dysfunction and skin issues. For example, a lack of vitamin A can cause vision problems, while a deficiency in vitamin D can lead to weak bones and a weakened immune system. Toxicity. Excessive intake of certain vitamins, particularly fat-soluble vitamins, can lead to toxicity. For example, vitamin A toxicity can cause liver damage, headaches, and dizziness. Vitamin D toxicity can result in hypercalcemia, too much calcium in the blood, which can damage bones, kidneys, and the heart. Vitamin E toxicity can interfere with blood clotting and increase the risk of bleeding. To avoid toxicity, it's important to stick to recommended daily intake levels and consult with a healthcare provider before taking high-dose vitamin supplements. Conclusion: vitamins are vital for overall well-being. Vitamins are not only crucial for basic bodily functions like energy production and immune defense, but they also influence mental health, cognitive function, skin health, and disease prevention. Maintaining a balanced diet rich in a variety of vitamins is key to supporting all of these processes and ensuring that your body functions optimally. While vitamin deficiencies can lead to specific health issues, excess intake can also have adverse effects. A well-balanced, nutrient-rich diet, combined with a healthy lifestyle that includes regular physical activity, good sleep, and stress management, is the best way to ensure you're getting the vitamins you need for lifelong health. If you're unsure whether you're getting enough vitamins or considering supplementation, it's always a good idea to consult with a healthcare professional for personalized advice based on your individual needs. Vitamins and their interactions with other nutrients. Vitamins do not work in isolation. They often interact with other vitamins, minerals, and nutrients to optimize their effects and support various physiological processes. Here's how vitamins work together with other essential nutrients. Vitamins and minerals. Vitamin D and calcium. Vitamin D enhances the absorption of calcium from the digestive tract. Without enough vitamin D, calcium cannot be efficiently absorbed into the bloodstream, potentially leading to weaker bones. For this reason, vitamin D and calcium often work together to prevent conditions like osteoporosis and rickets in children. Vitamin C and iron. Vitamin C enhances the absorption of non-heme iron, the type of iron found in plant-based foods, by converting it into a more absorbable form. This is especially important for individuals who do not consume meat, which contains heme iron, a more easily absorbed form of iron. A deficiency in vitamin C can lead to iron deficiency anemia, particularly in populations with limited access to animal products. Vitamin A and zinc. Zinc is necessary for the conversion of beta-carotene, a form of vitamin A found in plant foods, into active vitamin A. Zinc deficiency can impair the body's ability to convert beta-carotene into vitamin A, leading to potential vision issues, immune dysfunction, and skin problems. Vitamin A is also important for the proper functioning of the immune system, and zinc helps regulate this function. Vitamin K and calcium. Vitamin K plays a critical role in bone health by helping to regulate osteocalcin, a protein that binds calcium to the bone matrix. Adequate levels of vitamin K, along with calcium and vitamin D, are important for maintaining bone density and reducing the risk of fractures. B vitamins and folate. Vitamin B12 and folate work closely together, as folate, B9, is necessary for the synthesis of DNA, and vitamin B12 is required for the proper functioning of folate. A deficiency in one can affect the other, leading to conditions such as megaloblastic anemia and neurological issues. Genetics and vitamin requirements. Genetics plays a role in how efficiently our bodies absorb, metabolize, and utilize vitamins. Recent studies have shown that certain genetic factors can impact an individual's vitamin requirements or the ability to convert nutrients into their active forms. Vitamin D and genetics. Some people may have genetic variations that affect their ability to produce vitamin D from sunlight, potentially leading to higher needs for vitamin D intake from food or supplements. CYP2R1 is a gene that encodes an enzyme involved in converting vitamin D into its active form in the liver. Genetic variations in this gene can result in lower vitamin D levels in the body despite adequate sun exposure. Vitamin A and genetic variations. Certain genetic variants can affect how well individuals process carotenoids, the plant-based precursors to vitamin A. These genetic differences can make it more challenging for some individuals to convert beta-carotene into active vitamin A, resulting in potential deficiencies. Beta-carotene metabolism may also differ between people, influencing how they benefit from carotenoid-rich foods like carrots and sweet potatoes. Folate and genetics. The MTHFR gene plays a key role in processing folate and converting it into its active form, L-methylfolate. Genetic mutations in this gene may impair folate metabolism, increasing the need for folate-rich foods or supplements, especially for pregnant women. As adequate folate is crucial for fetal development. Vitamin supplementation. What does the research say? While vitamins are essential to health, the effectiveness of supplementation has been debated, especially for people who already consume adequate amounts of these nutrients from their diet. Here are some insights from the latest research. Vitamin D supplementation. Vitamin D supplementation has become increasingly popular due to the growing awareness of its role in bone health, immune function, and even mental health. Studies have shown that many people, particularly those who live in regions with limited sunlight or have darker skin, may benefit from vitamin D supplementation to maintain optimal health. Research suggests that vitamin D supplementation can be effective in reducing the risk of respiratory infections, improving mood in people with depression, and supporting bone health in older adults. B vitamins and cognitive health. There is emerging evidence suggesting that B vitamins, particularly B12, B6, and folate, may help slow cognitive decline in older adults and reduce the risk of Alzheimer's disease and other forms of dementia. These vitamins play a crucial role in maintaining brain health by supporting neurotransmitter function and reducing homocysteine levels, which are linked to neurodegeneration. Some studies indicate that supplementation with B vitamins could improve cognitive function in individuals with a deficiency, but the long-term effectiveness in preventing cognitive decline remains uncertain. Vitamin C and immune function. Vitamin C supplementation has been shown to boost immune function, reduce the severity and duration of colds, and help with the healing of wounds. Some research has also suggested that higher doses of vitamin C might have a role in reducing inflammation and oxidative stress in the body. However, while vitamin C is essential for immune health, research shows that supplementation beyond the recommended daily intake may not significantly improve health outcomes. For individuals who are already getting sufficient amounts from their diet. Multivitamins. Some people take multivitamin supplements to ensure they meet their daily nutrient requirements, but the benefits of multivitamins have been questioned. Recent studies have shown mixed results. While multivitamins can be helpful for those with dietary restrictions or deficiencies, they do not necessarily lead to better overall health or a reduced risk of chronic diseases for people who already consume a balanced diet. It's important to note that excessive supplementation of some vitamins, such as vitamin A or vitamin E, can lead to toxicity, making it essential to follow the recommended dosage. Vitamin recommendations for different life stages. Vitamin needs vary based on age, lifestyle, and health conditions. Here are some key considerations for vitamin intake at different stages of life. Infants and children. Vitamin D. Babies who are exclusively breastfed may need vitamin D supplements, as breast milk typically doesn't contain enough vitamin D to meet the baby's needs. Vitamin A. Infants and young children need adequate vitamin A to support growth and immune health. A deficiency in vitamin A during childhood can lead to vision problems and increased susceptibility to infections. Pregnant and lactating women. Folate. Pregnant women need higher amounts of folate, vitamin B9, to support fetal development and prevent neural tube defects. Prenatal vitamins often include folate in higher doses to meet this need. Vitamin B12. Vegans and vegetarians, in particular, may need vitamin B12 supplements during pregnancy, as vitamin B12 is found primarily in animal products. Iron and calcium. Pregnant women also require more iron to prevent anemia and sufficient calcium to support bone health for both mother and baby. Older adults. Vitamin B12. As people age, they may have a reduced ability to absorb vitamin B12 from food, which can lead to deficiency. B12 supplementation or fortified foods may be necessary for older adults. Vitamin D. Older adults may have lower levels of vitamin D due to decreased sun exposure and reduced ability to synthesize the vitamin in the skin. Supplementation is often recommended to support bone health and immune function. Calcium. Calcium intake becomes particularly important in older adults, especially women, to prevent osteoporosis and maintain bone health. Athletes and active individuals. Vitamin E. Athletes, particularly those who engage in intense physical activity, may have increased oxidative stress, which can deplete levels of vitamin E. Vitamin E acts as an antioxidant to help protect cells from damage. B vitamins. Active individuals, especially those involved in endurance sports, may require higher levels of B vitamins to support energy production and muscle repair. Vitamin D. Athletes who train indoors or in areas with limited sunlight may need vitamin D supplementation to maintain bone density and muscle function. Conclusion. The importance of balance. Vitamins are vital for overall health, and understanding their interactions, how genetics influence vitamin needs, and the latest research on supplementation can help optimize health. While obtaining vitamins through food is the best approach, supplementation may be necessary in some cases, especially for specific age groups, health conditions, or dietary restrictions. When considering supplementation, it's important to remember that balance is key. Both deficiencies and excesses of vitamins can lead to health issues. A personalized approach, based on individual needs and lifestyle, is the most effective way to ensure optimal health. By paying attention to dietary sources, sun exposure, and genetics, as well as seeking medical advice when necessary, you can support your body's vitamin requirements and promote long-term wellness. Vitamins and chronic diseases. Vitamins have significant roles in the prevention and management of chronic diseases. While they don't cure diseases, adequate vitamin intake can support the body's resilience against various conditions, potentially slowing their progression or reducing symptoms. Here's how certain vitamins are linked to chronic diseases. Cardiovascular disease. Vitamin D. Adequate levels of vitamin D are associated with a lower risk of cardiovascular diseases, including hypertension, high blood pressure, heart disease, and stroke. It helps regulate blood pressure, reduces inflammation, and supports the function of blood vessels. Research shows that low vitamin D levels are often linked to higher cardiovascular disease rates, particularly in populations with limited sunlight exposure or who are at risk of deficiency. Vitamin E. As an antioxidant, vitamin E helps prevent oxidative damage to lipids, fats, in the bloodstream, potentially reducing the risk of atherosclerosis, hardening of the arteries. This vitamin also plays a role in preventing blood clot formation, which could reduce the risk of heart attacks and strokes. B vitamins, B6, B12, and folate. These vitamins help reduce homocysteine levels in the blood. Elevated homocysteine is a risk factor for cardiovascular diseases, as it can damage blood vessels and increase the risk of clots. A deficiency in B vitamins can increase homocysteine levels and contribute to cardiovascular issues. Cancer prevention. Some vitamins play roles in reducing the risk of certain cancers by promoting healthy cell growth, supporting immune function, and reducing oxidative stress. Vitamin D. Research suggests that vitamin D can help prevent certain types of cancer, including colorectal cancer. Vitamin D inhibits the growth of cancer cells and regulates cell differentiation. It also enhances the immune system's ability to detect and eliminate abnormal cells. Vitamin A, beta-carotene. As an antioxidant, vitamin A plays a critical role in preventing cancer by neutralizing free radicals, which can damage cells and DNA, potentially leading to cancer development. It is particularly important in protecting against lung, prostate, and skin cancers. Vitamin C. As a potent antioxidant, vitamin C helps neutralize free radicals and support the immune system. which plays a role in the prevention of cancer. Adequate vitamin C levels may lower the risk of certain cancers, including breast and stomach cancers. Folate. Folate helps maintain DNA integrity and repair damaged cells, which may prevent the mutations that lead to cancer. It has been suggested that folate plays a protective role against colon and breast cancer. Diabetes management. Vitamin D. Vitamin D is involved in insulin sensitivity, the body's ability to use insulin effectively. Low vitamin D levels have been associated with an increased risk of developing type 2 diabetes, and studies suggest that vitamin D supplementation may help regulate blood sugar levels in those with diabetes. Vitamin C. High blood sugar in diabetics leads to oxidative stress, which can damage blood vessels and organs. Vitamin C, being an antioxidant, helps reduce oxidative damage and inflammation, improving overall health in diabetics. Vitamin B1. Thiamine. People with diabetes are often deficient in thiamine, which plays a key role in glucose metabolism. Supplementation with thiamine can help improve glucose control and protect against complications of diabetes, such as neuropathy, osteoporosis, and bone health. Vitamin D and calcium. Together, vitamin D and calcium are crucial for bone health. Vitamin D helps the body absorb calcium, while calcium supports bone strength. Without adequate vitamin D, calcium cannot be absorbed effectively, leading to weakened bones. Supplementation with both can help prevent bone-related conditions such as osteoporosis, particularly in older adults. Vitamin K. Vitamin K is essential for bone health because it helps activate osteocalcin, a protein that binds calcium in bones. Studies suggest that vitamin K2, in particular, may help prevent bone loss and reduce the risk of fractures. Vitamins and cellular function. Vitamins are vital for maintaining cellular function, which underpins all bodily processes. Cellular health is essential for aging, tissue repair, immune function, and even the prevention of diseases. Here's how vitamins contribute to cellular function. Cell division and DNA synthesis. Folate, vitamin B9, and vitamin B12. These vitamins are crucial for DNA synthesis and cell division. Folate is especially important in the early stages of pregnancy to prevent neural tube defects, while B12 ensures proper red blood cell production and nerve function. Both vitamins work together in the synthesis and repair of DNA, which is fundamental for cell division and maintaining genetic stability. Antioxidant protection. Vitamin C and vitamin E. Both vitamin C and vitamin E are antioxidants that help protect cells from oxidative stress and free radical damage. Free radicals can damage cell membranes, proteins, and DNA, leading to inflammation and disease. These antioxidants neutralize free radicals, helping to prevent premature aging, cancer, and other chronic diseases. Vitamin A, beta-carotene, as a fat-soluble antioxidant. Vitamin A, and its precursor beta-carotene, protects the skin and mucous membranes from oxidative damage. It also plays a role in gene expression and cell differentiation, supporting the body's repair and regeneration processes. Cellular energy production. B vitamins, B1, B2, B3, B5, B6. These vitamins are crucial for energy production at the cellular level. B vitamins help convert carbohydrates, fats, and proteins from the food we eat into usable energy, ATP, for cells. This is vital for maintaining the body's overall energy levels, particularly in cells that are constantly working, such as muscle cells, neurons, and immune cells. Mitochondrial function and aging. Vitamin B5, pantothenic acid. Vitamin B5 plays an important role in energy metabolism by being part of the coenzyme CoA, coenzyme A. CoA is involved in the citric acid cycle, Krebs cycle, which occurs in the mitochondria, the powerhouses of cells. Mitochondrial function is critical for cellular energy production, and maintaining healthy mitochondria is key to reducing the effects of aging and preventing age-related diseases. Longevity and anti-aging. Research into vitamins and longevity suggests that certain vitamins may have anti-aging properties by reducing oxidative stress, supporting cellular repair, and promoting healthy cell turnover. Here's how certain vitamins may contribute to a longer, healthier life. Vitamin E and aging. Vitamin E, due to its antioxidant properties, helps protect cells from damage caused by free radicals, which are implicated in aging and age-related diseases. Studies have shown that vitamin E supplementation may help reduce the appearance of wrinkles, improve skin elasticity, and protect against age-related eye conditions like cataracts and macular degeneration. Vitamin C and skin aging. Vitamin C plays a key role in collagen synthesis, which is essential for maintaining skin structure and elasticity. Collagen production naturally decreases with age, leading to wrinkles and sagging skin. Adequate vitamin C intake can help promote healthy, youthful-looking skin by stimulating collagen production and protecting skin cells from damage caused by UV exposure and pollution. Vitamin D and healthy aging. Vitamin D has been linked to longevity and healthy aging. Adequate vitamin D levels are associated with a lower risk of chronic diseases such as cardiovascular disease, diabetes, and cancer. Additionally, vitamin D helps maintain muscle mass and strength, which is critical in preventing falls and fractures in older adults. Latest research on vitamins and disease prevention. In recent years, ongoing research into the effects of vitamins has expanded our understanding of their potential therapeutic benefits. Some studies are now exploring how vitamins can help manage complex diseases or improve quality of life in specific populations. Vitamin D and mental health. There is growing evidence suggesting that vitamin D deficiency is associated with mood disorders such as depression, anxiety, and even schizophrenia. Some studies show that increasing vitamin D intake can improve mood, reduce the severity of depression, and may be a useful adjunct in treating psychiatric conditions. Vitamin B12 and dementia. Recent research suggests that vitamin B12 may play a protective role against cognitive decline and dementia. Individuals with low B12 levels have a higher risk of developing Alzheimer's disease, and studies show that supplementing with vitamin B12 could slow cognitive decline in older adults. Vitamin C and immune health. Recent research highlights the importance of vitamin C in immune function, especially during cold and flu season. Clinical trials have shown that vitamin C supplementation can reduce the severity and duration of common cold symptoms and may have a role in preventing upper respiratory infections. Conclusion. The interconnected role of vitamins in health. Vitamins are essential for almost every function in the body, from energy production and cellular repair to immune defense and disease prevention. They work synergistically with other nutrients and play critical roles in maintaining overall health and well-being. Ongoing research continues to reveal the many ways vitamins influence our bodies, including their potential to prevent chronic diseases, slow the aging process, and support longevity. By ensuring adequate vitamin intake through a balanced diet, and possibly supplementation when needed, we can enhance our health, reduce the risk of diseases, and promote a longer, healthier life. Whether you're managing a chronic condition, focusing on healthy aging, or aiming to prevent future health issues, vitamins are a cornerstone of good nutrition and overall wellness. Emerging roles of vitamins in cutting-edge research. New studies continue to reveal the far-reaching impact of vitamins on human health, highlighting their potential in treating and managing various conditions, as well as influencing biological mechanisms that were previously underappreciated. Vitamin D and immune modulation. Immunotherapy and autoimmune diseases. The role of vitamin D in the immune system has expanded beyond its well-known function in bone health. Recent studies have found that vitamin D modulates immune responses and may be beneficial in autoimmune diseases, such as multiple sclerosis, MS, rheumatoid arthritis, and lupus. Vitamin D appears to help regulate the production of cytokines, the signaling molecules that mediate inflammation, potentially alleviating symptoms and disease activity in autoimmune conditions. Cancer immunotherapy. There's growing interest in how vitamin D might enhance the effectiveness of cancer immunotherapies. Some researchers are investigating whether vitamin D could boost the immune system's ability to target and destroy cancer cells, thus complementing treatments like immune checkpoint inhibitors. B vitamins and mental health. Cognitive decline and neurodegenerative diseases. New research suggests that B vitamins, particularly B12, B6, and folate, may play a critical role in reducing the risk of neurodegenerative diseases like Alzheimer's and Parkinson's. B vitamins help regulate homocysteine levels, and elevated homocysteine is a known risk factor for cognitive decline and brain shrinkage. Supplementation with B vitamins may slow the progression of cognitive impairment. Although more research is needed in this area, mental health and mood disorders, vitamin B12 and folate have been found to influence mood and cognitive function, with deficiencies linked to an increased risk of depression and anxiety. Some studies suggest that supplementing with these vitamins could improve mood, energy levels, and overall mental well-being, making them potential adjuncts in managing depression. Vitamin A and skin regeneration. Retinoids in dermatology. Vitamin A, in its active form, retinoid, is well known for its role in skin health. Retinoids are extensively used in dermatology for the treatment of acne, psoriasis, and even for reducing the appearance of wrinkles and fine lines. Recent research has expanded the therapeutic potential of vitamin A derivatives to treat a range of skin conditions and promote wound healing, skin aging and repair. Research into retinoids has revealed their potential in stimulating the production of collagen, thus preventing skin aging. Retinoids can help accelerate cell turnover, increase skin elasticity, and reduce wrinkles. This has led to their widespread use in anti-aging skincare regimens. Vitamin E and longevity. Vitamin E as a senolytic agent. Some groundbreaking research has explored the potential of vitamin E in aging and longevity. Studies have indicated that tocopherol, a form of vitamin E, might function as a senolytic agent, helping to remove senescent, old or dysfunctional cells from the body. These cells accumulate with age and contribute to chronic diseases and aging-related decline. By eliminating senescent cells, vitamin E could potentially slow down the aging process and improve the quality of life in elderly individuals. Vitamin E and cardiovascular health. A new wave of studies suggests that vitamin E, due to its antioxidant and anti-inflammatory properties, could help protect against cardiovascular diseases. Vitamin E supplementation may reduce the buildup of plaque in the arteries, improve blood circulation, and prevent oxidative stress that contributes to heart disease and atherosclerosis. Vitamin C and the gut microbiome. Microbiome health. Emerging research is exploring the role of vitamin C in modulating the gut microbiome, the complex community of microorganisms living in the digestive system. The microbiome is crucial for digestion, immune function, and overall health. Vitamin C has been shown to influence the diversity and composition of gut bacteria, which in turn could affect immune responses and even mood. Gut health and inflammation. Studies suggest that vitamin C's antioxidant properties may help reduce gut inflammation, which is linked to conditions like irritable bowel syndrome, IBS, inflammatory bowel disease, IBD, and leaky gut syndrome. By reducing oxidative stress in the gut lining, vitamin C may contribute to improved digestion, reduced bloating, and better overall gut function. Vitamin K2 in bone and vascular health. Bone health and calcium regulation. Vitamin K2 is essential not just for bone health but also for regulating calcium metabolism. Recent studies have shown that vitamin K2 helps prevent calcium from accumulating in the arteries, thus reducing the risk of vascular calcification. It also promotes the proper placement of calcium in bones, potentially helping prevent osteoporosis and improving bone density, particularly in postmenopausal women. Heart health. Vitamin K2 is believed to play an important role in cardiovascular health by activating matrix GLA protein, MGP, which inhibits the calcification of blood vessels. This could reduce the risk of arterial stiffness and associated conditions like hypertension. Vitamins and stress response. Our bodies rely on vitamins to manage physical and mental stress, which can impact a wide range of bodily functions. Here's how vitamins contribute to stress regulation. Vitamin C and cortisol. Stress and cortisol. Cortisol is the hormone released during stress, and long-term high levels can lead to health issues like high blood pressure, weight gain, and immune suppression. Vitamin C plays a key role in regulating cortisol levels, and research has shown that adequate vitamin C intake can lower cortisol levels during stressful situations. Adaptation to stress. During physical or mental stress, the body's vitamin C requirements increase. This is why individuals under chronic stress or those with high intensity Jobs or lifestyles may need more vitamin C to help combat the oxidative stress associated with elevated cortisol levels. B vitamins and stress resilience. B vitamins and stress management. The B-complex vitamins, particularly B6, B9, and B12, are known to support the nervous system, regulate mood, and increase the body's resilience to stress. Vitamin B6 helps produce neurotransmitters such as serotonin and dopamine, which influence mood and emotional responses to stress. B12 and folate also support cognitive function, which is essential for stress management. Decreased B vitamin levels and stress sensitivity. Research has found that people who are deficient in B vitamins, especially B6 and B12, may experience higher levels of stress and anxiety. Adequate intake of these vitamins supports the body's ability to handle stress effectively and maintain mental clarity. Magnesium and vitamin D in stress and anxiety. Magnesium, while not technically a vitamin, magnesium is often discussed in relation to stress and anxiety. Magnesium plays a role in muscle relaxation and calming the nervous system, which is essential during periods of stress. Magnesium deficiency has been linked to increased anxiety and poor sleep quality. Vitamin D and stress response. Studies suggest that vitamin D may help mitigate the effects of stress and anxiety. Low vitamin D levels are often seen in individuals with chronic stress and anxiety disorders. Some research shows that supplementing with vitamin D may help reduce symptoms of depression and improve overall emotional well-being. Vitamins and metabolism. Vitamins play an essential role in energy metabolism, the biochemical process by which our bodies convert food into energy. Here's how certain vitamins are involved in metabolism. Vitamin B1, thiamine, and carbohydrate. Metabolism. Carbohydrate breakdown. Thiamine is crucial for the metabolism of carbohydrates. It helps convert carbohydrates into glucose, which is used by the body for energy. A deficiency in thiamine can lead to impaired energy production, resulting in symptoms like fatigue, weakness, and neurological problems. Vitamin B3, niacin, and fat metabolism. Fat breakdown. Niacin is involved in the breakdown of fats, proteins, and carbohydrates into energy. Niacin works as a precursor to two important coenzymes, NAD and NADP, which are essential for cellular energy production. Niacin also plays a role in regulating cholesterol levels by increasing HDL, good cholesterol, and reducing LDL, bad cholesterol. Vitamin B7, biotin, and fatty acid synthesis. Fatty acid metabolism. Biotin, or vitamin B7, is essential for the synthesis of fatty acids, which are important for energy storage. It is also involved in amino acid metabolism and plays a role in maintaining healthy hair, skin, and nails. Conclusion: the future of vitamin research and therapeutics. As science continues to uncover the roles of vitamins in health, emerging research is expanding our understanding of how these micronutrients can be harnessed in both disease prevention and treatment. The growing focus on personalized medicine, where genetic factors are considered in nutritional recommendations, means that vitamins may play an even more tailored role in healthcare in the future. Moreover, the integration of vitamins in new therapeutic areas, such as immunotherapy, mental health, longevity, stress resilience, and the microbiome, illustrates their profound impact on overall well-being. Whether through dietary intake, supplements, or integrative therapies, vitamins are emerging as key players in optimizing health, reducing disease risks, and promoting a higher quality of life. Understanding their interactions, the impact of deficiencies, and their potential therapeutic uses offers exciting opportunities for improving global health outcomes in the coming years. Vitamins and metabolic disorders. Metabolic disorders affect the body's ability to properly convert food into energy or regulate specific metabolic processes, often leading to conditions like diabetes, obesity, and insulin resistance. Vitamins play key roles in managing these conditions by supporting the function of enzymes involved in metabolism. Vitamin D and insulin sensitivity. Vitamin D and type 2 diabetes. Adequate levels of vitamin D are crucial for improving insulin sensitivity and reducing the risk of type 2 diabetes. Vitamin D receptors are found in insulin-producing cells of the pancreas. And research shows that vitamin D deficiency is often associated with an increased risk of insulin resistance, a precursor to diabetes. Some studies suggest that vitamin D supplementation could improve insulin sensitivity, helping to manage blood sugar levels and preventing the onset of diabetes. Metabolic syndrome. Vitamin D has been linked to metabolic syndrome, a cluster of conditions that increase the risk of heart disease, stroke, and type 2 diabetes. Deficient levels of vitamin D may contribute to inflammation, obesity, high blood pressure, and high blood sugar, which are all hallmark signs of metabolic syndrome. B vitamins in energy and metabolism. B1, thiamine. B2, riboflavin, B3, niacin, and B7, biotin. These vitamins are all essential for energy metabolism. They are involved in converting carbohydrates, fats, and proteins into usable energy. For individuals with metabolic disorders, ensuring adequate intake of these vitamins can support healthy metabolism and energy production. Vitamin B6. B6 plays a role in the metabolism of amino acids and neurotransmitters, and deficiencies can lead to complications in energy regulation, especially in individuals with diabetes or obesity. Vitamin A and obesity. Vitamin A. Emerging research suggests that vitamin A plays a role in regulating fat storage and metabolism. Some studies have found that vitamin A deficiency is associated with an increased risk of obesity and metabolic syndrome. On the other hand, an excess of vitamin A, particularly in the form of supplements, can lead to toxicity, so it is important to maintain a balanced intake. Retinoids, a form of vitamin A, have been studied for their potential to modulate adipocyte fat cell differentiation, which could have therapeutic potential in obesity treatment. Vitamins and skin health. Vitamins are integral to maintaining healthy, radiant skin, influencing everything from hydration and elasticity to protection against aging and damage. Vitamin A and skin repair. Vitamin A, retinol, the most prominent vitamin for skin health. Vitamin A plays a vital role in skin regeneration and repair. It stimulates collagen production, promotes healthy cell turnover, and improves skin texture. Retinoids, derivatives of vitamin A, are widely used in dermatology for treating acne, fine lines, wrinkles, and pigmentation issues. Retinol helps reduce the visibility of acne scars and sunspots, rejuvenating the skin and giving it a smoother, more youthful appearance. Vitamin A deficiency and skin issues. Deficiency in vitamin A can lead to skin dryness, dullness, and an increased risk of infections. Xerophthalmia, a condition that leads to dry, damaged eyes, and follicular hyperkeratosis, where the skin becomes rough with raised bumps, are two common skin conditions linked to a lack of vitamin A. Vitamin C and collagen synthesis. Vitamin C, known for its powerful antioxidant properties. Vitamin C is essential for collagen synthesis, which is necessary for maintaining skin elasticity and structure. Collagen is a protein that helps the skin stay firm and youthful looking. Vitamin C protects the skin from oxidative damage caused by UV rays, pollution, and other environmental stressors, reducing the appearance of wrinkles and fine lines. Vitamin C in sun protection. While vitamin C cannot replace sunscreen, it can help protect skin from UV damage by neutralizing free radicals that are produced when the skin is exposed to the sun. Some studies suggest that vitamin C can reduce UV-induced erythema, skin redness, skin pigmentation, and sunburn. Vitamin E and skin hydration. Vitamin E, as an antioxidant. Vitamin E helps reduce skin inflammation, protects against oxidative stress, and supports skin hydration. Topical use of vitamin E in oils or lotions is often recommended for dry skin, as it helps lock in moisture and promotes smoother, more supple skin. Some studies also show that vitamin E can help heal scars and promote wound healing. Vitamin E and skin aging. Vitamin E helps protect the skin from UV-induced damage, which is a leading cause of premature aging. Its anti-inflammatory properties also reduce the appearance of wrinkles, fine lines, and skin discoloration associated with aging. Vitamin D and skin protection. Vitamin D, exposure to Sunlight helps the body synthesize vitamin D, which has important benefits for the skin. Vitamin D is essential for skin cell growth and repair and helps protect the skin from chronic conditions like eczema and psoriasis. However, excessive sun exposure to produce vitamin D can lead to skin damage and increase the risk of skin cancer, which is why safe sun practices, including sunscreen use, are vital. Vitamins and cognitive function. The brain is highly sensitive to changes in nutrient levels, and vitamins play crucial roles in maintaining cognitive function, preventing cognitive decline, and supporting overall brain health. B vitamins and cognitive decline. Vitamin B12. A deficiency in vitamin B12 can cause neurological issues, including memory loss, fatigue, mood changes, and in severe cases, irreversible nerve damage. Vitamin B12 is involved in the synthesis of myelin, the protective covering of nerve fibers, and helps maintain healthy brain function. As people age, vitamin B12 levels tend to drop, increasing the risk of cognitive decline. Supplementation may help reduce this risk in older adults. Folate, vitamin B9. Folate is essential for brain function and development. Low folate levels have been linked to cognitive impairment, especially in the elderly. Folate is involved in the synthesis of neurotransmitters such as serotonin and dopamine, which regulate mood and cognitive function. Adequate folate intake has been shown to protect against age-related cognitive decline. Vitamin D and brain health. Vitamin D. Adequate vitamin D levels are essential for cognitive health. Research has shown that vitamin D receptors are abundant in areas of the brain that control memory and learning. A deficiency in vitamin D has been associated with an increased risk of cognitive disorders such as Alzheimer's disease and dementia. In addition, vitamin D may play a role in neuroprotection by reducing inflammation in the brain and protecting against neurodegenerative diseases. Vitamin D and depression. There is also strong evidence linking vitamin D deficiency with depression. Some studies suggest that individuals with low vitamin D levels are more prone to mood disorders, and supplementation may help improve symptoms in those with depression, particularly in the winter months when sunlight exposure is limited. Vitamin E and neuroprotection. Vitamin E. As a potent antioxidant, vitamin E helps protect the brain from oxidative stress, which can contribute to cognitive decline and neurodegenerative diseases. Studies have shown that higher levels of vitamin E may slow the progression of Alzheimer's disease and prevent neuronal damage. Its neuroprotective effects are partly due to its ability to neutralize free radicals that cause brain cell damage. Innovative therapeutic approaches involving vitamins. The therapeutic potential of vitamins is becoming increasingly recognized in medicine, beyond their traditional role in preventing deficiencies and promoting overall health. Research is focusing on using vitamins in novel ways to treat and manage specific conditions. Vitamins as adjuncts in cancer treatment. Vitamin D in cancer therapy. Some studies suggest that vitamin D may have anti-cancer properties. It has been shown to regulate the growth of cancer cells, reduce the spread of tumors, and enhance the effectiveness of cancer therapies. Vitamin D may be used alongside chemotherapy, radiation, or immunotherapy to improve outcomes for certain cancers. Vitamin C in cancer treatment. Vitamin C is being investigated for its potential to enhance the effectiveness of chemotherapy and reduce the side effects of cancer treatment. High-dose vitamin C has been shown in some studies to slow tumor growth, increase the effectiveness of certain chemotherapy drugs, and boost the immune system. Vitamin B12 in neurological disorders. Vitamin B12. Vitamin B12 deficiency is increasingly recognized as a contributing factor to neurological disorders, including peripheral neuropathy, Parkinson's disease, and multiple sclerosis. Vitamin B12 supplementation has been explored as a potential treatment to slow the progression of these diseases, particularly for individuals with low B12 levels. Conclusion: the future of vitamin research and therapeutics. Vitamins are indispensable for health, offering a wide array of benefits beyond basic nutritional requirements. Their roles in preventing and managing metabolic disorders, promoting skin health, enhancing cognitive function, and supporting the body's natural ability to heal are becoming more widely appreciated. Emerging research into the therapeutic uses of vitamins, particularly in combination with other treatments, opens new avenues for improving health outcomes. Personalized approaches to nutrition and vitamin supplementation will become increasingly important as we discover more about how vitamins influence various bodily systems and their potential in treating diseases and promoting longevity. Ultimately, the future of vitamins in healthcare looks promising, with ongoing research paving the way for new and innovative ways to leverage these essential nutrients for better health and disease management. Vitamins and chronic disease prevention. Chronic diseases, such as cardiovascular disease, diabetes, cancer, and neurodegenerative disorders, are among the leading causes of death globally. Vitamins have a crucial role in preventing the onset of these diseases, maintaining optimal health, and managing symptoms. Vitamin D and cardiovascular health. Vitamin D and heart disease. Growing evidence suggests that vitamin D plays a significant role in reducing the risk of cardiovascular diseases. Adequate vitamin D levels have been linked to lower blood pressure, improved blood vessel function, and reduced inflammation, all of which help protect the heart. Vitamin D helps regulate calcium levels in the blood and tissues, reducing the risk of arterial calcification, a key factor in cardiovascular disease. Vitamin D and hypertension. Studies have indicated that individuals with low vitamin D levels are at a higher risk for developing high blood pressure, hypertension. Supplementation with vitamin D may help regulate blood pressure by improving the function of blood vessels and reducing the inflammatory response that contributes to hypertension. B vitamins in preventing cancer. Vitamin B9, folate, and cancer prevention. Folate, along with other B vitamins, is believed to play a role in DNA synthesis and repair, helping to prevent mutations that can lead to cancer. Vitamin B9, folate, deficiency has been associated with an increased risk of various cancers, including colorectal cancer. However, the relationship between folate supplementation and cancer risk is complex. While adequate levels may reduce cancer risk, excessive intake, especially from supplements, may increase the risk of certain cancers. Vitamin B12 and cancer asterisk. Some research suggests that B12 deficiencies could be linked to higher cancer risks, especially for individuals with low levels of B12 over a long period. Vitamin B12 also works in tandem with folate to help repair DNA damage and prevent mutations that could lead to cancerous growths. Vitamin E in cancer prevention. Vitamin E has long been studied for its potential to reduce cancer risk due to its powerful antioxidant properties. Some studies have suggested that vitamin E may protect cells from oxidative stress, which can damage DNA and increase the risk of cancer. However, findings are mixed, with some large-scale studies showing limited effects in cancer prevention. More research is needed to clarify the exact role of vitamin E in cancer prevention. Vitamins in personalized medicine. Personalized medicine, which tailors medical treatment to individual characteristics, is an exciting field that has gained momentum in recent years. One aspect of personalized medicine is how vitamins and nutritional interventions can be optimized based on an individual's genetics, lifestyle, and environmental factors. Genetics and vitamin metabolism. Genetic variability. Research in nutrigenomics is uncovering how genetic variations affect the metabolism of vitamins and other nutrients. For example, genetic variations in enzymes that process vitamin D, folate, and vitamin C can influence how efficiently the body absorbs, metabolizes, and utilizes these vitamins. Vitamin D and genetic predisposition. Genetic polymorphisms, or variations in specific genes, may affect how well a person responds to vitamin D supplementation. For instance, certain genetic variants can influence how efficiently the body synthesizes vitamin D from sunlight. As a result, individuals with these genetic variations may require higher doses of vitamin D to achieve optimal levels. Personalized vitamin D supplementation strategies are already being explored based on genetic profiles. Nutrigenetics and disease risk. Folate and neural tube defects. Women with certain genetic variations may require higher levels of folate to prevent neural tube defects during pregnancy. The study of genetic differences in folate metabolism has led to recommendations for folic acid supplementation to prevent birth defects, especially in populations at higher risk based on their genetic makeup. Vitamin A and eye health. Personalized approaches are being developed to optimize vitamin A intake in individuals based on their genetic ability to convert beta-carotene, a precursor to vitamin A, into active vitamin A. This could help prevent age-related macular degeneration, AMD, or other eye diseases. Vitamins and environmental influences. Our environment significantly affects how we synthesize, absorb, and metabolize vitamins, influencing health outcomes. Environmental factors, such as sunlight exposure, diet, and pollutants, interact with vitamin levels in complex ways. Vitamin D and sunlight. Sunlight exposure. The most well-known example of vitamin synthesis influenced by the environment is vitamin D. When the skin is exposed to ultraviolet B, UVB, rays from sunlight, it synthesizes vitamin D. However, factors such as geographic location, time of year, skin pigmentation, and sunblock use can all impact how much vitamin D the body produces. For example, people living in higher latitudes with less sunlight exposure may be more prone to vitamin D deficiency, particularly during the winter months. Vitamin D and pollution. Air pollution, especially in urban areas, may reduce the skin's ability to produce vitamin D, making individuals in polluted environments more vulnerable to deficiency. Studies suggest that pollutants like PM2.5, fine particulate matter, can decrease the efficacy of sunlight in stimulating vitamin D synthesis in the skin, leading to lower circulating vitamin D levels. Dietary changes and vitamin intake. Plant-based diets and vitamin B12 deficiency. People following plant-based diets, vegan or vegetarian, may be at risk for vitamin B12 deficiency, as B12 is found almost exclusively in animal products. While some plant-based foods are fortified with B12, individuals on plant-based diets should be mindful of their vitamin B12 intake, as deficiency can lead to neurological issues, anemia, and cognitive decline. Folate and food processing. Food processing methods, like cooking and refining grains, can destroy certain vitamins, including folate. This has led to fortified foods in many countries to prevent widespread vitamin deficiencies, particularly folic acid in cereals and grains to reduce the risk of neural tube defects. Vitamins and life stages. Vitamins play different roles in health depending on age, gender, and life stage. Understanding these variations is crucial for ensuring proper intake across the lifespan. Vitamins in pregnancy and lactation. Folate. Folate is essential during pregnancy to prevent neural tube defects, and many women are advised to take a folic acid supplement in the months leading up to and during pregnancy. Folate also supports cell growth and the development of the baby's nervous system. Vitamin D in pregnancy. Adequate vitamin D levels during pregnancy are important for both the mothers and babies' health. Low vitamin D levels can lead to complications such as gestational diabetes, preeclampsia, and low birth weight. Vitamin D also supports the baby's developing bones. Vitamin B12 in lactation. Vitamin B12 is vital for both the mother and baby during lactation. Deficiency in B12 can cause neurological issues and cognitive delays in infants. Vegan mothers, in particular, need to ensure they are getting enough B12 through fortified foods or supplements. Vitamins in children and adolescents. Vitamin D in growth. In children, vitamin D is crucial for healthy bone development and the prevention of rickets, a condition characterized by weakened bones. Vitamin D helps regulate calcium absorption and bone mineralization. Vitamin A for vision. Vitamin A is essential for proper vision and immune function in children. It supports the growth of new cells, the health of the skin, and the functioning of the immune system, which is crucial during early childhood when the body is rapidly developing. Vitamins in aging populations. Vitamin B12 in older adults. Older adults are at an increased risk of vitamin B12 deficiency due to reduced stomach acid production, which affects the absorption of B12 from food. Deficiency in B12 can lead to cognitive decline, memory problems, and even dementia. Supplementation with B12 is often recommended for older adults to maintain cognitive health. Vitamin D in older adults. As people age, their skin becomes less efficient at producing vitamin D from sunlight. Older adults are also more likely to spend less time outdoors, contributing to a higher risk of vitamin D deficiency, which can lead to osteoporosis, fractures, and weakened immune function. Vitamin K for bone health. Vitamin K is important for maintaining bone health in older adults, particularly postmenopausal women who are at risk of osteoporosis. Vitamin K helps regulate calcium metabolism and promotes the activity of bone-forming cells, thereby supporting bone density and reducing fracture risk. Future directions in vitamin research. As science continues to evolve, we can expect to see significant advancements in how we understand vitamins and their effects on human health. The future may hold personalized vitamin supplementation, with advances in nutrigenomics. Personalized vitamin regimens tailored to individuals' genetic profiles will become more widespread, improving both health and disease prevention. Vitamins and disease-specific therapies. Research will continue to explore vitamins as adjuncts and therapies for chronic diseases like cancer, heart disease, and neurodegenerative disorders, as well as in their roles in mental health treatment. Sustainable vitamin production. Innovations in sustainable plant-based sources of vitamins will help address global nutrition needs, especially as the world's population grows and the demand for sustainable food sources increases. In conclusion, vitamins are not only vital for basic bodily functions but are also integral to chronic disease prevention, personalized medicine, and environmental health. Ongoing research into how vitamins interact with our genes, diet, and the environment will continue to reveal new insights, offering hope for more effective therapies and preventative measures in the future. Emerging research on vitamin supplementation in specific conditions. Vitamin supplementation has long been used to address deficiencies, but it is now increasingly being studied as an adjunct in treating specific health conditions. Research is uncovering the broader potential of vitamins in managing complex health issues beyond just deficiency prevention. Vitamin C and immune support. Vitamin C in respiratory infections. While vitamin C is well known for its role in supporting the immune system, emerging research suggests that high-dose vitamin C may have therapeutic benefits during viral infections, including the common cold and even COVID-19. Some studies have suggested that vitamin C may reduce the severity and duration of respiratory infections by boosting immune responses. It acts as an antioxidant to combat oxidative stress and supports the production and function of white blood cells that fight off infections. Vitamin C in cancer treatment. New clinical trials are exploring high-dose vitamin C as a complementary treatment for cancer. The hypothesis is that vitamin C could enhance the effects of chemotherapy and radiation therapy, reduce inflammation, and protect normal cells from damage. This is particularly important in cancer treatments where oxidative stress and inflammation contribute to side effects and cellular damage. Vitamin D in autoimmune diseases. Vitamin D in multiple sclerosis, MS. Vitamin D has been increasingly linked to autoimmune diseases, with studies suggesting that adequate vitamin D levels may help reduce the risk of conditions like multiple sclerosis, MS. In MS, the immune system attacks the protective sheath of nerve fibers, leading to neurological problems. Research indicates that vitamin D helps modulate the immune system and may reduce the risk of MS or prevent disease flare-ups. Many individuals with MS show lower levels of vitamin D, suggesting that supplementation could be beneficial. Rheumatoid arthritis and vitamin D. Rheumatoid arthritis, RA, another autoimmune disease, has been associated with lower vitamin D levels. Supplementation with vitamin D may improve disease outcomes by reducing inflammation and the severity of symptoms. However, the exact role of vitamin D in managing autoimmune diseases is still being investigated, and more randomized clinical trials are needed. Vitamin B12 in neurodegenerative diseases. Vitamin B12 and Alzheimer's disease. Emerging evidence suggests that vitamin B12 may play a critical role in preventing or slowing the progression of Alzheimer's disease and other forms of dementia. Vitamin B12 is involved in the production of neurotransmitters in maintaining healthy brain cells. Deficiency in B12 has been linked to cognitive impairment, and supplementation has been shown to improve memory and cognitive function in people with mild cognitive impairment. MCI, or early Alzheimer's, Parkinson's disease. Research is also looking at the role of B vitamins, including B12 and folate, in slowing the progression of Parkinson's disease. In neurodegenerative diseases, ensuring optimal levels of B vitamins is essential for supporting nerve health, reducing inflammation, and preventing further neurological damage. Interactions between vitamins and minerals. Vitamins do not work in isolation, they interact with minerals and other nutrients to ensure optimal body function. Some vitamins enhance the absorption and utilization of minerals, while others work synergistically to support specific bodily functions. Vitamin D and calcium. Vitamin D and bone health. One of the most well-known interactions is between vitamin D and calcium. Vitamin D enhances calcium absorption in the intestines, which is crucial for maintaining bone density and preventing diseases like osteoporosis and rickets. Inadequate vitamin D can impair calcium absorption, leading to weakened bones and an increased risk of fractures. Calcium and vitamin D in older adults. As individuals age, they often become more susceptible to osteoporosis and bone fractures due to declining calcium absorption and bone density. In these cases, vitamin D and calcium supplementation together can help reduce bone loss and promote stronger bones. Vitamin C and iron absorption. Vitamin C and non-heme iron. Vitamin C plays a crucial role in enhancing the absorption of non-heme iron, the type of iron found in plant-based foods like legumes, grains, and vegetables. When taken together with iron-rich foods, vitamin C increases the bioavailability of iron, making it easier for the body to absorb and use. This interaction is particularly beneficial for individuals on plant-based diets, who may not get enough heme iron from animal products, and are more prone to iron deficiency anemia. Vitamin B6 and magnesium. Vitamin B6 and magnesium. Vitamin B6 and magnesium are often discussed together, as they work synergistically to support muscle and nerve function, regulate blood sugar levels, and reduce inflammation. Magnesium is essential for converting vitamin B6 into its active form, and the two nutrients also help each other in the management of stress and anxiety. Together, they have shown promise in treating conditions such as premenstrual syndrome, PMS, and insomnia. Vitamins and immune function. Vitamins play a fundamental role in regulating and supporting immune function, which is crucial in defending the body against pathogens, infections, and diseases. Vitamin A and immune response. Vitamin A is vital for maintaining the integrity of epithelial tissues, such as the skin, lungs, and digestive system, which serve as the first line of defense against infections. Retinoids, the active form of vitamin A, enhance the function of immune cells like T cells and B cells, both of which are essential for adaptive immunity. Vitamin A deficiency. A deficiency in vitamin A can severely impair immune function, making individuals more susceptible to infections such as measles and diarrheal diseases. Ensuring adequate vitamin A intake, particularly in developing countries, is a key intervention to reduce the burden of infectious diseases. Vitamin E and immune function. Vitamin E acts as a potent antioxidant that helps to protect immune cells from oxidative stress. It supports the immune system by promoting the activity of T cells, which are important for responding to pathogens. Vitamin E supplementation has been shown to enhance immune responses, particularly in older adults, whose immune function tends to decline with age. Vitamin E in aging. Older adults often experience a decrease in immune function, referred to as immunosenescence. Supplementation with vitamin E in this population has been shown to improve immune responses and help the body fight off infections more effectively. Vitamin D and immune modulation. Vitamin D plays a crucial role in modulating immune function. Vitamin D receptors are found on nearly every immune cell, including macrophages, dendritic cells, and T cells, which are involved in defending the body against infections. Adequate levels of vitamin D help regulate the immune system, reduce inflammation, and promote pathogen clearance. Vitamin D deficiency and autoimmunity. Research suggests that vitamin D deficiency is linked to an increased risk of autoimmune diseases, such as type 1 diabetes, rheumatoid arthritis, and multiple sclerosis. Vitamin D supplementation has shown promise in reducing autoimmune flare-ups and promoting immune balance. Vitamin delivery systems, innovation in the future. As our understanding of vitamins and their effects on health deepens, new and innovative delivery systems are emerging to enhance vitamin absorption and effectiveness. These systems aim to optimize the bioavailability of vitamins and ensure that they reach the right parts of the body at the right time. Liposomal vitamin delivery. Liposomal encapsulation. Liposomal technology is a cutting-edge method used to improve the bioavailability of vitamins by encapsulating vitamins in tiny lipid, fat particles. Liposomes help protect the nutrients from degradation in the digestive system, ensuring more efficient absorption into the bloodstream. Liposomal vitamin C, for example, has been shown to have higher bioavailability compared to traditional oral vitamin C supplements. Nanoencapsulation. Nanotechnology in vitamin delivery uses nano-sized particles to enhance the delivery and absorption of vitamins. This technology allows vitamins to be absorbed more efficiently, transported through the bloodstream more effectively, and delivered to targeted cells or tissues. This could be particularly important for individuals with compromised digestion or absorption issues, such as those with Crohn's disease or celiac disease. Transdermal and sublingual delivery. Transdermal, through the skin, and sublingual, under the tongue, delivery systems are gaining popularity as effective ways to absorb vitamins. These methods bypass the digestive system and liver, allowing for more direct and rapid absorption. Transdermal vitamin D patches and sublingual B12 tablets, for example, are becoming increasingly common, offering people an alternative to traditional oral supplements. Public health approaches to vitamin intake. Ensuring adequate vitamin intake at the population level is crucial for maintaining public health. In many parts of the world, vitamin deficiencies are prevalent, leading to significant health challenges. Fortification programs. Fortification of foods. Many countries have introduced fortification programs to address common vitamin deficiencies, particularly vitamin A, vitamin D, folic acid, and iodine. For example, folic acid fortification of cereals has been shown to reduce the incidence of neural tube defects in newborns. Similarly, the addition of vitamin D to milk has helped reduce the prevalence of rickets in children. Global vitamin A deficiency. Vitamin A deficiency remains a major public health issue in many developing countries, leading to blindness, immune system impairment, and increased mortality. Large-scale interventions, such as vitamin A supplementation and fortified foods, have been successful in reducing the burden of vitamin A deficiency. Education and public awareness. Public health campaigns. Education about the importance of vitamins and how to obtain them through a balanced diet and appropriate supplementation is key to reducing vitamin deficiencies. Governments and organizations like the World Health Organization, WHO, play a crucial role in raising awareness and providing guidelines for optimal vitamin intake, especially in regions where deficiencies are prevalent. In summary, vitamins are essential not only for maintaining everyday health but also in managing and preventing complex diseases. Through ongoing research, we are uncovering more about their potential roles in immune support, chronic disease management, and aging, alongside exploring innovative ways to deliver these vital nutrients efficiently. Future efforts in personalized medicine, public health initiatives, and sustainable practices will help ensure that everyone has access to the vitamins they need to live healthier lives. Advanced areas in vitamin research and applications. In recent years, vitamin research has expanded into areas that explore not just deficiency and supplementation, but also the broader impact of vitamins on disease mechanisms, therapeutic interventions, and individualized health strategies. Vitamins and gene expression. Vitamins as epigenetic regulators. Epigenetics refers to the study of changes in gene expression without alterations in the DNA sequence itself. Vitamins particularly vitamin D, folate, and B12, have been shown to influence gene expression through epigenetic mechanisms. For example, vitamin D can modify the activity of certain genes that are involved in immune function, inflammation, and cell growth. This has important implications for the prevention and treatment of diseases like cancer, autoimmune disorders, and cardiovascular disease. Folate and DNA methylation. Folate, vitamin B9, is directly involved in the process of DNA methylation, a key epigenetic mechanism that controls gene expression. Deficiency in folate can lead to improper DNA methylation, which is linked to the development of various diseases, including cancer. Current research is exploring the role of folate supplementation in maintaining healthy epigenetic regulation and its potential in cancer prevention. Vitamin D and its role in chronic inflammation. Vitamin D in inflammatory diseases. Chronic inflammation is a key driver of many conditions such as heart disease, diabetes, and autoimmune disorders. Recent studies suggest that vitamin D has an anti-inflammatory effect, helping to regulate immune responses and lower the levels of inflammatory markers in the body. Adequate vitamin D intake may therefore play a protective role in managing chronic inflammatory diseases and reducing the risk of developing such conditions. Vitamin D and inflammation in aging. In older adults, inflammation is often elevated due to aging and can contribute to conditions like osteoarthritis and frailty. Studies have suggested that vitamin D supplementation can help reduce these inflammatory markers, improving overall health and reducing the risk of chronic diseases in elderly populations. Vitamins in mental health and cognitive function. Beyond their well-established role in physical health, vitamins are also being investigated for their potential benefits in mental health, cognitive function, and neuroprotection. B vitamins in mental health. Vitamin B12 and depression. Vitamin B12 is essential for the production of serotonin, a neurotransmitter that regulates mood. Deficiency in vitamin B12 has been linked to symptoms of depression and other mood disorders. Studies have shown that B12 supplementation can improve mood, reduce depression symptoms, and even help prevent cognitive decline, particularly in older adults. Researchers are also investigating the impact of vitamin B12 in schizophrenia and other serious mental health conditions. Folate and cognitive function. Low levels of folate have been associated with cognitive decline, depression, and an increased risk of dementia. Some research suggests that adequate folate intake may be associated with better cognitive performance and a reduced risk of neurodegenerative diseases, including Alzheimer's disease. Folate supplementation has also shown promise in improving mood and reducing the severity of depressive symptoms. Vitamin D and brain health. Vitamin D in neurodevelopment. Vitamin D plays a vital role in brain development, particularly during pregnancy and early childhood. Low levels of vitamin D in pregnant women have been associated with an increased risk of neurodevelopmental disorders in their children, such as autism and attention deficit hyperactivity disorder, ADHD. Ensuring adequate vitamin D during these critical periods is essential for optimal brain function. Cognitive decline and vitamin D. In older adults, vitamin D deficiency has been linked to an increased risk of cognitive decline, dementia, and Alzheimer's disease. Vitamin D receptors are found throughout the brain, and this vitamin may influence the functioning of neurotransmitters and the maintenance of brain structure. Research continues to explore whether vitamin D supplementation could slow the progression of cognitive decline and improve brain health in aging populations. The future of vitamin supplementation, trends and technologies. As our understanding of vitamins deepens, new technologies and trends are emerging to improve how we deliver vitamins, optimize absorption, and individualize treatment. Targeted vitamin delivery systems. Nanotechnology for vitamin delivery. Nanotechnology is revolutionizing vitamin delivery. By using nanoparticles, vitamins can be encapsulated and transported more efficiently into the body, bypassing the digestive system and enhancing absorption. This technology can be particularly useful for individuals with conditions like irritable bowel syndrome or malabsorption syndromes that hinder nutrient absorption. Micronutrient-rich smart supplements. Personalized vitamins are now being developed based on genetic testing, blood tests, and lifestyle factors. These smart supplements are designed to meet individual needs for specific vitamins, minerals, and other nutrients based on factors like age, sex, genetics, and health conditions. Companies are offering tailored vitamin subscriptions, providing consumers with personalized daily vitamin packs. Probiotic and vitamin synergy, gut health and vitamin absorption, the microbiome, the community of bacteria and microorganisms in our gut, has a profound impact on vitamin absorption. Studies have shown that a healthy microbiome is essential for absorbing vitamins, especially those like vitamin K, B12, and biotin. Probiotics, which are beneficial bacteria that support gut health, are increasingly being used in conjunction with vitamins to improve absorption and overall effectiveness. Prebiotics and vitamins. Prebiotics, the fiber that feeds beneficial gut bacteria, are also being explored as adjuncts to vitamin supplementation. By promoting the growth of beneficial bacteria in the gut, prebiotics can enhance the effectiveness of vitamin supplementation, leading to better health outcomes. Public health and global vitamin deficiencies. Addressing vitamin deficiencies on a global scale remains a key public health challenge. Despite significant advances in fortification and supplementation, deficiencies in vitamins A, D, B12, and folate continue to affect large portions of the population, particularly in low-income countries. Vitamin A deficiency and blindness. Global efforts to combat vitamin A deficiency. Vitamin A deficiency remains one of the leading causes of preventable blindness in children worldwide. Public health interventions, such as vitamin A supplementation programs, fortified foods, and breastfeeding promotion, are crucial in regions where deficiency is widespread. International organizations like the World Health Organization, WHO, and UNICEF have been instrumental in leading these efforts. Folic acid and neural tube defects. Folic acid fortification. The fortification of foods with folic acid has been a significant success in reducing the incidence of neural tube defects, NTDs, in newborns. Many countries have implemented mandatory folic acid fortification of grains, cereals, and other staple foods. In countries where fortification programs are not yet widespread, folic acid supplementation is recommended for women of reproductive age to reduce the risk of NTDs. Vitamin D deficiency in developing countries. Vitamin D deficiency and malnutrition. Vitamin D deficiency is common in developing countries, where limited access to sunlight, poor dietary intake, and malnutrition contribute to low vitamin D levels. Public health programs focusing on vitamin D-rich foods, supplementation, and education are critical in preventing deficiency-related diseases like rickets and osteomalacia. Vitamin B12 and vegans. B12 deficiency in plant-based diets. As the popularity of plant-based diets increases, vitamin B12 deficiency has become more prevalent, particularly among vegans and vegetarians. Vitamin B12 is found primarily in animal products, so individuals following plant-based diets must rely on fortified foods or supplements. Public health campaigns are working to raise awareness about the importance of vitamin B12 and to ensure that at-risk populations are properly informed. Sustainable vitamin production and the future of nutrition. The future of vitamins goes beyond supplementation and into sustainability and environmental impact. As demand for vitamins rises globally, it's crucial to explore environmentally friendly and sustainable methods of production and distribution. Sustainable vitamin production. Plant-based vitamin sourcing. With growing concerns about sustainability, plant-based sources of vitamins are gaining popularity. For example, biofortified crops, crops that are genetically modified or selectively bred to contain higher levels of vitamins, are being developed to combat deficiencies in developing countries. These crops can help reduce the need for external supplementation and improve food security. Fermentation and biotechnology. Advances in fermentation and biotechnology are being used to produce high-quality vitamins in more environmentally friendly ways. Companies are now using microorganisms to produce vitamins like B12, vitamin D, and vitamin K, reducing the reliance on animal products and minimizing environmental impact. In conclusion, Vitamins are at the forefront of ongoing research aimed at improving human health. From supporting mental health and cognitive function to innovative delivery systems and global public health efforts, vitamins play a central role in preventing and managing chronic diseases. As science continues to evolve, new discoveries and technologies will enhance our ability to harness the power of vitamins, making them an even more powerful tool for improving global health in the years to come. Emerging research on vitamin-specific roles in disease prevention. Vitamins are increasingly being studied for their therapeutic potential beyond their traditional roles in maintaining basic health. Research into their impact on complex diseases is growing, uncovering new insights into how vitamins may prevent or even treat conditions previously thought unrelated to nutrient status. Vitamin C and chronic disease prevention. Vitamin C in cardiovascular disease, long known for its antioxidant properties, vitamin C is being explored for its role in preventing cardiovascular disease, CVD. Studies suggest that vitamin C may help reduce the oxidative stress that accelerates atherosclerosis, plaque buildup in arteries, contributing to heart disease. Furthermore, vitamin C has been shown to improve the function of blood vessels, lower blood pressure, and support healthy cholesterol levels. Some clinical trials are investigating whether high doses of vitamin C might also aid in treating heart disease by enhancing endothelial function. Vitamin C and cancer prevention. The relationship between vitamin C and cancer prevention continues to be studied, particularly in terms of its potential to reduce DNA damage caused by oxidative stress. Research suggests that regular vitamin C intake may lower the risk of certain cancers, especially when combined with other antioxidants. Furthermore, vitamin C is being tested as an adjunctive therapy for cancer patients, as its antioxidant and immune-boosting properties may help mitigate chemotherapy's side effects. Vitamin E and cognitive protection. Vitamin E in Alzheimer's disease. As we age, our ability to combat oxidative stress declines, contributing to neurodegenerative diseases like Alzheimer's. Vitamin E, a powerful antioxidant, is being studied for its potential to protect brain cells from free radical damage and slow the progression of Alzheimer's. Some studies have shown that vitamin E supplementation may improve cognitive function in individuals with mild to moderate Alzheimer's disease, while other research is focusing on its ability to prevent cognitive decline in healthy aging adults. Vitamin E in Parkinson's disease. Parkinson's disease, characterized by the degeneration of dopamine-producing neurons, has been linked to oxidative damage. Research suggests that vitamin E, with its potent antioxidant effects, may slow the disease's progression and alleviate symptoms in those affected by Parkinson's. Clinical trials are exploring the efficacy of vitamin E as a neuroprotective agent for people with Parkinson's. Innovative vitamin supplementation techniques. While traditional pill or capsule forms of vitamins are effective, new and more efficient methods of delivering vitamins are gaining traction. These innovative delivery systems aim to enhance bioavailability, improve adherence, and offer more targeted health benefits. Microencapsulation for targeted delivery. Microencapsulation involves enclosing vitamins in a small, protective coating that prevents them from breaking down before reaching their target area in the body. This method is especially useful for fat-soluble vitamins like vitamin A, D, E, and K, which are often poorly absorbed when taken orally. Microencapsulation protects the vitamins from being degraded in the stomach, improving their absorption in the intestines and providing more effective health outcomes. Microencapsulated vitamin D. In the case of vitamin D, microencapsulation allows for a steady release of the vitamin over time, which may be especially beneficial for individuals with low absorption rates or conditions like Crohn's disease. This approach may also help avoid the peaks and valleys of vitamin D levels associated with traditional supplementation. Transdermal vitamin patches. Vitamin patches. The use of transdermal patches to deliver vitamins is an emerging trend. This method bypasses the digestive system, delivering nutrients directly through the skin into the bloodstream. Vitamin D patches, for instance, have been shown to provide an effective means of supplementation for individuals who struggle to get enough sunlight. Similarly, patches for B12 and magnesium are becoming more common, especially for individuals with digestive disorders or those who need a constant and consistent supply of nutrients. Advantages of patches. The major advantage of transdermal patches is that they can provide a controlled release of vitamins over an extended period, ensuring a steady stream of nutrients. This is particularly beneficial for individuals with gastrointestinal conditions that reduce nutrient absorption. Sublingual and buccal vitamin delivery. Sublingual tablets. Sublingual, under the tongue, and buccal, in the cheek. Delivery systems are gaining popularity for certain vitamins like B12 and vitamin D. These delivery methods allow for direct absorption into the bloodstream through the mucous membranes, bypassing the digestive system altogether. For individuals with pernicious anemia or those who have difficulty absorbing B12 through the digestive tract, sublingual tablets are an effective alternative. Vitamin B12. Sublingual B12 supplements are particularly popular in people with B12 deficiency who may not absorb the vitamin properly through the intestines. The direct absorption into the bloodstream allows for faster delivery of the vitamin and can be a more effective approach for addressing deficiency compared to traditional oral supplements. Personalized vitamin regimens and precision nutrition. Personalized nutrition, including tailored vitamin regimens, is a rapidly growing field that aims to optimize health by considering individual genetic profiles, lifestyle factors, and health conditions. Genetic and nutrigenomic testing. Genetic testing for vitamin needs. New technologies in genetic testing can help identify how a person's genes influence the way they metabolize and absorb specific vitamins. For example, variations in the MTHFR gene can affect folate metabolism, leading to a higher risk of deficiency and complications in pregnancy. Nutrigenomic testing can also indicate a person's need for certain vitamins like B12, vitamin D, or iron, based on their genetic predispositions, allowing for more personalized supplementation recommendations. Tailored vitamin plans. Companies now offer personalized vitamin subscriptions based on an individual's genetic test, results, blood work, lifestyle, and dietary habits. For instance, someone with a genetic predisposition to vitamin D deficiency may receive vitamin D-rich supplements in addition to other essential nutrients. This customized approach ensures that people are getting the right nutrients in the right amounts for their individual needs. Personalized vitamin regimens for athletes. Sports nutrition. Vitamins are critical for optimizing athletic performance and recovery. Professional athletes often work with nutritionists and health coaches to determine the best vitamin regimens tailored to their training schedules and performance goals. For instance, vitamin D plays a key role in muscle function and immune health, and vitamin C can reduce exercise-induced oxidative stress, enhancing recovery. Vitamin B6 and performance. Research suggests that vitamin B6 plays a role in improving performance by enhancing the body's ability to metabolize proteins and amino acids, which are crucial for muscle growth and repair. Personalized nutrition plans for athletes are becoming more sophisticated, integrating vitamins like B6 to support recovery and optimize training outcomes. Global public health strategies for vitamin deficiency. Ensuring that people globally have access to sufficient vitamins continues to be a major public health challenge. Governments, international organizations, and researchers are working to develop sustainable strategies for addressing vitamin deficiencies in underserved populations. Food fortification programs. Fortification of staple foods. Food fortification is one of the most successful public health interventions for reducing vitamin deficiencies worldwide. By adding essential vitamins like vitamin A, iron, folate, and vitamin D to commonly consumed foods such as flour, salt, oil, and milk, countries can significantly reduce the prevalence of nutrient deficiencies. For example, iodized salt has helped eliminate iodine deficiency disorders globally, while folic acid fortification has reduced the occurrence of neural tube defects. Biofortification. Another exciting development is biofortification, the process of breeding crops to naturally contain higher levels of vitamins and minerals. Golden rice, for example, has been engineered to contain high levels of vitamin A, addressing vitamin A deficiency in regions where rice is a staple food. Global vitamin A supplementation initiatives. Vitamin A and childhood mortality. Vitamin A deficiency remains one of the leading causes of preventable childhood blindness and death in developing countries. Massive public health campaigns led by organizations like UNICEF have provided high-dose vitamin A supplements to children in areas where deficiency is prevalent, significantly reducing both childhood blindness and mortality rates. Folic acid and pregnancy health. Universal folic acid supplementation in many developed countries. Folic acid supplementation before and during pregnancy has become routine practice, reducing the risk of neural tube defects in newborns. However, many countries with high levels of folic acid deficiency still struggle with this issue. And improving the availability of folic acid through fortified foods and direct supplementation is a key public health priority. Sustainable and eco-friendly vitamin sources. As the world increasingly shifts towards sustainable nutrition, the future of vitamin production is focusing on reducing the environmental impact of traditional vitamin production methods. Plant-based and algae-derived vitamins. Plant-based vitamin D. Vitamin D, traditionally sourced from animal products, is now available in plant-based forms derived from lichen or mushrooms that are exposed to ultraviolet, UV, light. This provides an alternative for vegans and vegetarians who may not wish to consume animal-derived products. Algae-derived omega-3 fatty acids. While omega-3 fatty acids are often derived from fish oil, algae are now considered a more sustainable and eco-friendly source of these essential fatty acids. Algae-based supplements are also being enriched with vitamins like D and E, making them a more sustainable and comprehensive nutrient source. In summary, the future of vitamins encompasses innovative delivery methods, personalized nutrition, and public health initiatives aimed at tackling deficiencies globally. As scientific research progresses, the role of vitamins in disease prevention, mental health, athletic performance, and aging will continue to be explored, offering more tailored and effective approaches to improving health for individuals and populations alike. Vitamins and longevity. Role in healthy aging. With the growing global population of older adults, researchers are increasingly investigating how vitamins contribute to healthy aging and longevity. Vitamins play crucial roles in cellular health, immune function, and preventing chronic diseases that are common in the elderly, such as cardiovascular disease, osteoporosis, and cognitive decline. Vitamin D and bone health. Vitamin D and osteoporosis. Vitamin D is essential for maintaining bone health, as it helps regulate calcium absorption in older adults. Low levels of vitamin D are linked to a higher risk of osteoporosis, fractures, and falls. Researchers are exploring how vitamin D supplementation can help prevent bone loss and improve muscle function, potentially reducing the incidence of falls and fractures in the elderly. Vitamin K and bone strength. Vitamin K is another important vitamin for bone health. It is involved in the activation of proteins that help bind calcium to bones. Some studies suggest that vitamin K supplementation may improve bone density and reduce the risk of fractures in older adults, particularly when combined with vitamin D. Vitamin E and cellular protection. Vitamin E as an antioxidant. Vitamin E is well known for its antioxidant properties, helping to neutralize harmful free radicals that can cause cellular aging. By protecting cells from oxidative stress, vitamin E may help slow down the aging process and reduce the risk of chronic diseases associated with aging, such as heart disease and neurodegeneration. Vitamin E and skin aging. In the realm of cosmetic and dermatological applications, vitamin E is often used for its role in protecting the skin from UV-induced damage. Topical application of vitamin E, as well as oral supplementation, has been shown to reduce the appearance of wrinkles and fine lines, making it a common ingredient in anti-aging skincare products. B vitamins in cognitive function. B vitamins and memory. Vitamins in the B-complex group, especially B6, B12, and folate, are crucial for brain health and cognitive function. As we age, our ability to process and utilize B vitamins can decline, which is why adequate intake is so important for preventing Memory loss and cognitive decline. Research suggests that B12 deficiency is a key factor in the development of dementia, and supplementation may help slow cognitive decline in elderly individuals. Vitamin B1, thiamine, and Alzheimer's disease. Emerging research is looking at the role of thiamine, vitamin B1, in neurodegenerative diseases, including Alzheimer's disease. Studies suggest that thiamine supplementation might help improve symptoms and slow the progression of Alzheimer's, particularly in patients with early-stage cognitive decline. Vitamins and mental health, mood, depression, and anxiety. The role of vitamins in mental health is a rapidly expanding field. There is growing evidence linking vitamin deficiencies to mood disorders like depression, anxiety, and seasonal affective disorder, SAD. Understanding how vitamins affect mental health could help in developing new approaches to managing these conditions. Vitamin D and depression. Vitamin D deficiency and depression. Vitamin D has long been associated with mood regulation. A deficiency in vitamin D has been linked to an increased risk of depression, particularly in individuals living in regions with long winters or limited sunlight. Vitamin D receptors in the brain influence the production of mood-regulating neurotransmitters like serotonin and dopamine. Research is investigating whether vitamin D supplementation can help alleviate symptoms of depression, especially in those with low levels of the vitamin. Seasonal affective disorder, SAD. A form of depression that occurs during the winter months when sunlight exposure is limited, is often treated with light therapy and vitamin D supplementation. The growing evidence suggests that vitamin D plays a vital role in preventing and managing seasonal depression, which affects millions of people globally. B vitamins and mental health. Vitamin B12 and mood disorders. Vitamin B12 is essential for the production of neurotransmitters, including serotonin and dopamine, which help regulate mood. Deficiency in B12 is often linked to symptoms of depression and anxiety. Supplementation with vitamin B12 may improve mood, reduce feelings of fatigue, and alleviate symptoms of depression, particularly in individuals with low B12 levels due to poor absorption or dietary factors. Folate and mental health. Folate, vitamin B9, plays a key role in the synthesis of neurotransmitters that regulate mood, such as serotonin. Studies have shown that individuals with low folate levels are at a higher risk of developing depression, and folate supplementation can improve the efficacy of antidepressant treatments. Some research also suggests that folate may help in managing symptoms of schizophrenia and other psychiatric disorders. Vitamin C and stress relief. Vitamin C and stress management. Vitamin C is not only important for immune function but also has a crucial role in reducing cortisol levels, the hormone associated with stress. Research has shown that vitamin C supplementation can lower anxiety levels and improve mood, particularly in high-stress environments like the workplace or during periods of intense emotional distress. Oxidative stress and mental health. Chronic stress can lead to an increase in oxidative stress in the body, which in turn affects brain health. Vitamin C, along with other antioxidants like vitamin E, helps mitigate the effects of oxidative stress, potentially offering a protective effect against stress-induced damage to the brain and mood disorders. Vitamin therapies and immune function. Enhancing immune health. Vitamins play a key role in immune health by supporting the body's defense mechanisms, regulating immune cells, and preventing infections. In light of recent global health challenges, the role of vitamins in maintaining and enhancing immune function has gained particular attention. Vitamin C and immunity. Vitamin C and immune defense. Vitamin C is a well-known immune booster. It stimulates the production of white blood cells and enhances their ability to fight off infections. During times of illness or stress, the body's demand for vitamin C increases, making supplementation important for supporting immune function. Research also suggests that vitamin C may reduce the duration and severity of common colds and other respiratory infections. Vitamin C and antioxidant protection. As an antioxidant, vitamin C protects immune cells from damage caused by oxidative stress. This is crucial for maintaining the optimal functioning of immune cells, especially in aging populations or those suffering from chronic diseases. where oxidative stress and inflammation are elevated. Vitamin D and immune regulation. Vitamin D and immune response. Vitamin D is crucial for activating the immune system. It helps regulate the production of cytokines, proteins that play a central role in immune signaling. Adequate vitamin D levels can help prevent autoimmune diseases, reduce inflammation, and improve responses to infections. For example, studies have shown that vitamin D deficiency may be linked to an increased susceptibility to respiratory infections, including the flu and COVID-19. Vitamin D and autoimmune diseases. Recent studies indicate that vitamin D may help modulate the immune system, potentially reducing the risk or severity of autoimmune diseases such as rheumatoid arthritis, multiple sclerosis, and type 1 diabetes. This has led to a renewed interest in the potential therapeutic effects of vitamin D in managing autoimmune conditions. Vitamin A and immune function. Vitamin A and immune protection. Vitamin A is essential for maintaining the health of the skin, mucous membranes, and epithelial tissues, which are the body's first line of defense against pathogens. It also regulates the activity of T cells, which are critical in fighting infections. Vitamin A deficiency can impair immune function, leading to increased susceptibility to infections, particularly in children. Vitamin A and vaccine response. Studies have shown that vitamin A supplementation can enhance the effectiveness of vaccines, improving the immune response, especially in children in low-resource settings. This highlights the importance of ensuring adequate vitamin A levels to optimize immune function and response to immunization. Vitamin innovation in public health. As global health initiatives continue to evolve, public health strategies are focusing on making vitamins more accessible and effective in populations worldwide, particularly those with limited access to nutrition or healthcare services. Smart fortification and biofortified foods. Biofortified crops. Biofortification is the process of breeding crops to naturally enhance their vitamin content. Biofortified foods like golden rice, enriched with vitamin A, and iron-fortified beans are being developed to help address nutrient deficiencies in regions where people have limited access to diverse diets or supplements. Smart fortification, along with traditional food fortification. The concept of smart fortification involves targeting micronutrient deficiencies using tailored fortification strategies that take into account regional diets, health needs, and local challenges. This ensures that the right vitamins are being provided to the right populations in the most effective way. In conclusion, the future of vitamins is deeply intertwined with advancements in personalized medicine, immune support, longevity, mental health, and global public health strategies. As our understanding of vitamins continues to evolve, they will undoubtedly play an even greater role in promoting health, preventing disease, and improving the overall quality of life across the globe. Vitamins and chronic disease management. Chronic diseases such as diabetes, hypertension, cancer, and obesity continue to be major global health challenges. Vitamins are increasingly being studied not just for their roles in prevention but also for their potential therapeutic applications in managing chronic conditions. Vitamin C and diabetes management. Vitamin C and insulin sensitivity. Research suggests that vitamin C may play a role in improving insulin sensitivity, particularly in individuals with type 2 diabetes. Oxidative stress is often higher in people with diabetes, leading to cellular damage and insulin resistance. Since vitamin C is a powerful antioxidant, it may help to counteract this oxidative stress, making it easier for the body to regulate blood sugar levels. Vitamin C and diabetes complications. Diabetic patients are at higher risk for developing complications like cardiovascular disease, kidney disease, and neuropathy. Some studies have shown that adequate vitamin C levels may help to reduce the risk of these complications by improving vascular health, reducing inflammation, and enhancing the function of the immune system. Vitamin D and cardiovascular health. Vitamin D deficiency and heart disease. Emerging evidence suggests that vitamin D deficiency is associated with a higher risk of heart disease, including conditions like hypertension, coronary artery disease, and heart failure. Vitamin D is thought to help regulate blood pressure, improve endothelial function, the lining of blood vessels, and reduce inflammation, all of which are key factors in cardiovascular health. Vitamin D supplementation. There is ongoing research into the potential benefits of vitamin D supplementation for individuals with heart disease. Some studies suggest that vitamin D might help to lower blood pressure, improve cholesterol levels, and reduce the risk of heart attacks. However, more research is needed to establish optimal dosages and determine how vitamin D interacts with other heart-healthy nutrients. Vitamin E and neurodegenerative diseases. Vitamin E and Alzheimer's disease. Vitamin E has been studied for its role in protecting neurons from oxidative damage, which is a key factor in the progression of neurodegenerative diseases like Alzheimer's and Parkinson's disease. Vitamin E's antioxidant properties may help reduce the formation of toxic compounds, such as amyloid plaques, which are characteristic of Alzheimer's. Some studies suggest that higher levels of vitamin E could slow cognitive decline in people with Alzheimer's. Although the results are still inconclusive. Vitamin E in Parkinson's disease. In Parkinson's disease, oxidative stress contributes to the degeneration of dopaminergic neurons. Vitamin E, being a potent antioxidant, has been proposed as a potential therapeutic agent to slow the progression of the disease by reducing oxidative damage in the brain. Clinical studies are continuing to evaluate whether vitamin E supplementation can have a protective effect in individuals with Parkinson's. Vitamins in global nutrition policies. Globally, addressing vitamin deficiencies remains a priority for public health authorities, as vitamin deficiencies continue to affect millions of people, particularly in low-income countries. Governments and international organizations have implemented a variety of strategies to improve vitamin intake and reduce deficiency-related diseases. Global fortification efforts. Fortification of staple foods. The fortification of staple foods with essential vitamins and minerals has been one of the most successful interventions in improving public health. Commonly fortified foods include flour, salt, sugar, and cooking oil, all of which are consumed on a daily basis by large populations. Vitamins like vitamin A, folic acid, vitamin D, and iron are commonly added to help combat widespread deficiencies. Universal iodine fortification. The iodization of salt has been an immensely successful public health measure to combat iodine deficiency, which can lead to goiter, cognitive impairments, and developmental delays. Many countries have now made iodized salt a public health requirement, helping to eliminate iodine deficiency globally. Vitamin A for child health. Vitamin A deficiency remains one of the leading causes of preventable childhood blindness and is linked to weakened immune systems, which increase the risk of death from infections. Various organizations, including UNICEF and WHO, have led large-scale vitamin A supplementation programs that have significantly reduced childhood mortality in countries where deficiency is widespread. Biofortification for sustainability. Biofortification is an emerging strategy where crops are genetically enhanced to contain higher levels of essential nutrients, including vitamins. Golden rice, engineered to contain more vitamin A, is one example. This biofortified crop has been developed to combat vitamin A deficiency in regions where rice is a staple food but other sources of vitamin A are scarce. Iron biofortification. Iron deficiency anemia is another common issue, particularly in pregnant women and young children. Efforts to biofortify crops such as beans, maize, and wheat with iron are underway to help alleviate this issue in regions where iron-rich foods are not readily available. Sustainable agricultural practices. Biofortification aligns with sustainable agriculture, as it reduces the need for external inputs, like synthetic fertilizers and pesticides, while ensuring that the crops are more nutritious. This can be particularly beneficial in developing countries where access to diverse foods is limited, and it offers an eco-friendly solution to micronutrient deficiencies. Gene-environment interactions. The future of personalized vitamin use. The future of vitamins may move beyond general supplementation to more individualized strategies, where genetic predisposition and environmental factors determine the optimal vitamins for a person's health. Research into nutrigenomics, how genetics influences nutrient needs, and personalized nutrition is expanding rapidly. Genetic variability and vitamin metabolism. Genetic variations in vitamin absorption. Variations in genes can influence how well a person absorbs, metabolizes, and utilizes certain vitamins. For example, some people have genetic mutations that affect folate metabolism, meaning they require more folate to achieve the same health benefits as others. Identifying such genetic markers can lead to personalized supplementation recommendations, ensuring individuals receive the right amount of vitamins based on their unique genetic makeup. Vitamin D receptor, VDR, variants. The presence of certain VDR gene variants can affect how efficiently the body responds to vitamin D. Some individuals with these variants may require higher doses of vitamin D to achieve optimal blood levels. Personalized vitamin D supplementation can help address such genetic predispositions and optimize bone health, immune function, and mood. The role of diet and lifestyle in vitamin absorption. Environmental factors. Vitamin requirements can be influenced by lifestyle factors such as diet, exercise, and sun exposure. For instance, individuals with limited exposure to sunlight may require more vitamin D, while athletes may need higher levels of vitamin B6 and antioxidants due to the increased oxidative stress associated with intense physical activity. Nutrient interactions. Nutrients like vitamin C, vitamin E, and zinc can influence each other's absorption and effectiveness. Personalized vitamin plans will consider these interactions to optimize overall nutrient intake. For example, individuals with high zinc levels may need higher vitamin C to support immune function, while those with high iron intake may benefit from increased vitamin C for better iron absorption. Sustainable vitamin production and environmental considerations. The sustainability of vitamin production is a growing concern as global awareness of environmental impacts rises. Innovations in eco-friendly vitamin production are addressing how vitamins can be produced with a smaller environmental footprint. Plant-based and algae-derived vitamins. Algae as a sustainable source. Algae are increasingly being used to produce omega-3 fatty acids, vitamin D, and other nutrients. Algae-derived vitamins are not only highly bioavailable but are also considered more sustainable than traditional animal-derived sources, as algae are grown in controlled environments. Their cultivation requires fewer resources and has a lower environmental impact compared to land-based crops or animal farming. Plant-based vitamin D. The demand for plant-based vitamin D is increasing, especially among vegans and those with dietary restrictions. Unlike animal-based vitamin D, from sources like fish liver oil, vitamin D2, from mushrooms, and vitamin D3 derived from lichen are sustainable, vegan-friendly alternatives. Conclusion. The future of vitamins in health and sustainability. The role of vitamins in chronic disease management. Personalized health, global nutrition policy, and environmental sustainability is rapidly evolving. As research progresses, the future will likely see more targeted, personalized vitamin regimens, a stronger focus on biofortification and sustainable production, and better public health strategies to address vitamin deficiencies worldwide. The ability to optimize health through vitamins will become increasingly accessible, with innovative approaches improving the health and well-being of populations across the globe. Vitamin interactions. The science behind synergy and antagonism. Vitamins do not work in isolation, they often interact with one another, as well as with minerals and macronutrients, to influence health outcomes. Understanding these interactions is crucial for optimizing health through proper nutrition and supplementation. Synergy between vitamins. Vitamin D and calcium. One of the most well-known vitamin interactions is between vitamin D and calcium. Vitamin D enhances the absorption of calcium from the digestive tract, which is critical for bone health and preventing conditions like osteoporosis and rickets. When there is a deficiency in vitamin D, the body cannot absorb calcium effectively, leading to weakened bones. Even if calcium intake is adequate. Vitamin C and iron. Vitamin C is essential for the absorption of non-heme iron, the type of iron found in plant-based foods. Consuming vitamin C-rich foods, like citrus fruits or bell peppers, with iron-rich foods, like spinach or beans, can significantly increase iron absorption. This is particularly beneficial for individuals with iron deficiency anemia, especially in populations with limited access to animal-based iron sources. Vitamin B12 and folate. Vitamin B12 and folate work closely together in the production of red blood cells and the synthesis of DNA. A deficiency in either vitamin can lead to megaloblastic anemia, characterized by large, abnormal red blood cells. Both vitamins are also involved in homocysteine metabolism, an amino acid that, when elevated, is associated with an increased risk of cardiovascular disease. Ensuring adequate intake of both B12 and folate helps reduce this risk. Antagonistic interactions. Vitamin E and vitamin K. While vitamin E acts as an antioxidant, vitamin K plays a crucial role in blood clotting. Excessive vitamin E intake can interfere with vitamin K's function, potentially increasing the risk of bleeding. It is essential to balance these vitamins, particularly when supplementing with vitamin E at high doses. Vitamin A and vitamin D. Vitamin A and vitamin D are both fat-soluble vitamins and can influence each other's absorption. High levels of one may inhibit the absorption or metabolism of the other. It is important to maintain balance to avoid toxicity or deficiency of either vitamin. Optimizing vitamin absorption. Understanding how vitamins interact with dietary fats, fiber, alcohol, and medications can help optimize their absorption and effectiveness. Dietary fats. Since many vitamins, including A, D, E, and K, are fat-soluble, consuming them with healthy fats, such as avocado or olive oil, can significantly enhance absorption. Fiber. High levels of fiber can sometimes interfere with the absorption of fat-soluble vitamins, particularly in individuals consuming large amounts of fiber supplements or fiber-rich foods. Medications. Certain medications, like antacids, antibiotics, or statins, can impact vitamin absorption or metabolism, leading to deficiencies. For example, antacids can reduce stomach acid, impairing the absorption of vitamin B12. Therefore, individuals taking long-term medications should consult their healthcare providers about potential nutrient interactions. Emerging delivery systems. Innovative methods for vitamin supplementation. As the demand for personalized nutrition and bioavailability increases, researchers are developing more efficient and sustainable ways to deliver vitamins to the body. This includes novel delivery systems that enhance the absorption and effectiveness of vitamins. Nanoencapsulation and nanoparticles. Nanoencapsulation involves enclosing vitamins in nanometer-sized particles to protect them from degradation and enhance their absorption. This technology is being used to deliver vitamins that are typically hard to absorb or are destroyed in the digestive process. For instance, vitamin D and omega-3 fatty acids can be encapsulated in nanoparticles, improving their stability and bioavailability. Nanoemulsions. Nanoemulsions are stable mixtures of water and oil, often used to improve the solubility of fat-soluble vitamins like vitamin E, D, and A. These emulsions increase the surface area of the vitamins, allowing for better absorption in the body. Transdermal delivery systems. Patch-based delivery. Transdermal vitamin patches are a growing trend, particularly for individuals who have difficulty swallowing pills or who need a consistent vitamin dose throughout the day. These patches allow vitamins, such as vitamin D, vitamin B12, or magnesium, to be absorbed through the skin, bypassing the digestive system entirely. Topical vitamin applications. Topical vitamin formulations, such as those containing vitamin E for skin health or vitamin C for collagen production, are increasingly popular in the cosmetic industry. Additionally, vitamin-infused creams and serums may offer targeted health benefits. Smart supplements and personalized vitamin packs. Smart supplements. Wearable devices or apps that track your nutrient intake and health data are being integrated with personalized vitamin regimens. These smart supplements adjust the types and dosages of vitamins based on factors like dietary intake, blood tests, and lifestyle habits, creating a more targeted and precise approach to vitamin supplementation. Subscription-based vitamin packs. Personalized vitamin subscription services are gaining popularity. where consumers receive monthly packs tailored to their specific health needs. These services often incorporate detailed health assessments to create custom supplements based on an individual's genetic profile, dietary habits, and activity levels. Vitamins in preventing emerging diseases, a focus on pandemic preparedness. The role of vitamins in disease prevention, particularly in response to global pandemics, has garnered significant attention during times of public health crises such as the COVID-19 pandemic. Vitamins like D, C, and A have been studied for their potential to reduce the severity of infections and strengthen the immune response. Vitamin D and viral infections. Vitamin D and respiratory health. Research has suggested that adequate levels of vitamin D may help reduce the risk of upper respiratory infections, including the common cold, flu, and COVID-19. Vitamin D supports immune cells, including T cells, that are responsible for fighting off pathogens. Some studies have shown that individuals with vitamin D deficiency are more likely to experience severe symptoms and complications from respiratory infections. Vitamin D and COVID-19. During the COVID-19 pandemic, several studies have explored the potential role of vitamin D supplementation in reducing the severity and mortality of the virus. While more research is needed, some evidence suggests that maintaining adequate vitamin D levels may improve the body's ability to fight off the virus and reduce the risk of complications. Vitamin C and immune response. Vitamin C is a preventative supplement, given its well-established role in immune function. Vitamin C has been widely studied for its ability to prevent or mitigate infections, especially viral ones. During times of heightened illness risk, vitamin C has been shown to boost white blood cell activity, protect against oxidative damage, and reduce the duration of colds. Vitamin C in hospitalized patients, in clinical settings. Intravenous vitamin C has been used in critical care to reduce inflammation and support recovery in patients with severe respiratory distress or those suffering from severe viral infections. This has led to ongoing research into the potential therapeutic use of vitamin C in pandemic preparedness. Vitamin A and immune health in developing countries. Vitamin A and immunization. Vitamin A deficiency remains a significant issue in developing countries, where it is associated with an increased risk of infection and child mortality. Global health organizations, including WHO and UNICEF, have led efforts to supplement vitamin A to improve immune function and support vaccine efficacy. Adequate vitamin A intake is especially crucial for children, as it helps to strengthen their immune systems and reduce the risk of measles, diarrheal diseases, and other infections. Vitamin A and disease prevention. In regions where malnutrition is prevalent, vitamin A supplementation has been linked to improved health outcomes, including reduced morbidity and mortality in young children. The global efforts to address vitamin A deficiency continue to be a cornerstone in preventing emerging infectious diseases in vulnerable populations. Vitamin deficiency in maternal and child health. Vitamins play a critical role in maternal and child health, influencing everything from pregnancy outcomes to child growth and development. Proper vitamin intake during pregnancy is crucial for both the mother and the child. Folic acid in pregnancy. Folic acid and neural tube defects. Adequate folate, vitamin B9, intake before and during early pregnancy is essential for preventing neural tube defects, NTDs, in infants, such as spina bifida and anencephaly. Many countries now mandate the fortification of flour with folic acid to reduce the incidence of these birth defects. Folate and maternal health. Folate also helps prevent anemia and supports placental function, ensuring proper oxygen and nutrient delivery to the fetus. Additionally, folate contributes to the synthesis of DNA and the development of the fetal nervous system. Vitamin D in pregnancy. Vitamin D and pregnancy outcomes. Adequate vitamin D levels are essential for maternal bone health and fetal development. Vitamin D deficiency during pregnancy has been associated with an increased risk of gestational diabetes, preeclampsia, and low birth weight. Vitamin D for infant health. Adequate vitamin D intake during pregnancy ensures that the baby receives sufficient amounts through the placenta. This is important for bone development and the prevention of rickets in infancy. Conclusion. The path forward for vitamins. The role of vitamins in health optimization and disease prevention is more crucial than ever as we navigate complex global health challenges. Advances in personalized nutrition, vitamin delivery systems, and chronic disease management are changing the way we think about these essential nutrients. As research continues, the understanding of how vitamins interact with genetics, environment, and lifestyle will allow for more targeted approaches to improving health outcomes and global nutrition security. The future of vitamins is deeply connected to innovative technologies, sustainability efforts, and public health strategies that prioritize accessibility, efficacy, and equity in improving health across the world. Vitamins and mental health. Emerging research suggests that vitamins play an integral role in maintaining mental health, preventing cognitive decline, and managing mental health disorders. Vitamins are involved in key biochemical processes that influence mood, cognition, and mental resilience. Vitamin D and depression. Vitamin D and mental health. A growing body of evidence suggests that vitamin D deficiency is associated with an increased risk of depression and other mood disorders. Vitamin D receptors are found in the brain, and adequate levels are necessary for the synthesis of neurotransmitters like serotonin, which regulate mood and emotional well-being. People with low vitamin D levels are more likely to experience symptoms of seasonal affective disorder, SAD, a type of depression that occurs during the winter months when sunlight exposure is limited. Vitamin D supplementation. Supplementing with vitamin D has shown promise in improving mood in individuals with low levels of the vitamin. Clinical trials have reported that vitamin D supplementation can reduce the severity of depression in some patients, although more research is needed to determine optimal dosages and the best approach for incorporating it into treatment plans. B vitamins and cognitive function. Vitamin B12 and cognitive health. Vitamin B12 is essential for the production of myelin, the protective sheath around nerve fibers, and for maintaining proper brain function. A deficiency in vitamin B12 is linked to cognitive decline, memory problems, and even dementia. Older adults, vegetarians, and people with absorption issues are at greater risk of B12 deficiency. Folate and mental health. Folate, vitamin B9, plays a role in serotonin production and mood regulation. Low folate levels have been associated with depression and cognitive impairments. Folate is also essential for neurodevelopment in children and cognitive function in adults. Vitamin B6 and mental health. Vitamin B6 is involved in the synthesis of neurotransmitters such as dopamine and serotonin, which are crucial for mood regulation. A deficiency in vitamin B6 can lead to irritability, depression, and cognitive impairments. Adequate B6 levels are essential for maintaining emotional stability and preventing mental health disorders. Vitamin E and neurodegenerative diseases. Vitamin E and Alzheimer's disease. As an antioxidant, vitamin E has been studied for its potential to protect brain cells from oxidative stress, which plays a role in the development of neurodegenerative diseases like Alzheimer's disease. Research suggests that vitamin E may help slow cognitive decline and protect against memory loss in Alzheimer's patients, although more research is needed to establish its effectiveness. Vitamin E in Parkinson's disease. Vitamin E has also been explored for its potential in preventing Parkinson's disease, a neurodegenerative disorder. It is believed to reduce oxidative stress, which contributes to the loss of dopamine-producing neurons. Some studies have shown that higher vitamin E intake may help slow disease progression, although the evidence is mixed. Vitamins and aging, promoting longevity and healthy aging. As the global population ages, maintaining health through proper nutrition is more important than ever. Vitamins play a significant role in slowing the aging process, supporting longevity, and reducing the risk of age-related diseases. Vitamin D and bone health and aging. Bone health and osteoporosis. Vitamin D is crucial for calcium absorption and bone health. As people age, the body's ability to produce vitamin D from sunlight decreases, leading to an increased risk of osteoporosis and fractures. Ensuring adequate vitamin D levels in older adults is vital for maintaining bone density, preventing falls, and promoting overall musculoskeletal health. Falls and fractures. adequate vitamin D levels have been shown to reduce the risk of falls in the elderly by improving muscle strength and balance. This is particularly important for preventing fractures, which can lead to long-term disability. Antioxidant vitamins and cellular aging. Vitamin C and skin aging. Vitamin C plays a critical role in collagen synthesis, which is essential for maintaining skin elasticity and firmness. As we age, the natural production of collagen decreases, leading to the formation of wrinkles and sagging skin. Vitamin C also acts as an antioxidant, protecting skin cells from damage caused by free radicals and UV radiation, which accelerates skin aging. Vitamin E and skin protection. Vitamin E is another important antioxidant that helps protect skin from oxidative stress and the damaging effects of UV radiation. It also supports the skin's barrier function, reducing inflammation and promoting wound healing. These properties help maintain youthful skin and prevent age-related skin damage. B vitamins and age-related cognitive decline. Cognitive function and memory. Vitamin B12, folate, and vitamin B6 play critical roles in brain health and cognitive function, particularly as we age. Studies suggest that adequate levels of these vitamins can help reduce the risk of cognitive decline and dementia. B vitamins help maintain nerve health, support brain cell communication, and reduce homocysteine levels, which are linked to an increased risk of cognitive disorders. Neuroprotective effects of B vitamins. Ensuring adequate intake of B vitamins, especially B12 and folate, has been associated with better memory, slower cognitive decline, and a lower risk of Alzheimer's and Parkinson's disease. Global challenges, climate change and socioeconomic disparities. Vitamins also play a role in addressing global health disparities and the impact of climate change on nutrition. As the world faces environmental changes, there is a growing need to ensure nutritional security and provide adequate vitamins to vulnerable populations. Climate change and vitamin deficiencies. Impact on food security. Climate change can affect global food production, leading to disruptions in food supply chains and nutrient availability. Changing weather patterns, droughts, floods, and extreme temperatures can negatively impact the growth of crops, reducing the availability of essential vitamins and minerals, especially in low-income countries. Reduced crop yields. Changes in temperature and precipitation can lead to decreased yields of vitamin-rich crops like fruits, vegetables, and grains, which are crucial for maintaining micronutrient intake. For example, vitamin A, found in carrots and sweet potatoes, could be less available if these crops are damaged by changing weather conditions. Nutrient loss from cooking. Increased energy costs due to climate change could result in cooking methods that use less water or cooking time. However, this can impact the bioavailability of certain vitamins like vitamin C, which is sensitive to heat and water-soluble. Understanding how to preserve vitamins in the face of climate-induced changes in food production is critical for maintaining public health. Socioeconomic disparities and vitamin deficiencies. Vitamin deficiency in low-income populations. Vitamin A, vitamin D, iron, and folate deficiencies are widespread in low-income countries. These deficiencies can lead to serious health problems, including blindness, immune dysfunction, and birth defects. Socioeconomic factors, including poor access to nutrient-dense foods, inadequate healthcare, and lack of education about nutrition, contribute to these deficiencies. Nutrition programs and vitamin distribution, to address vitamin deficiencies in vulnerable populations. Governments and non-governmental organizations, NGOs, are implementing large-scale vitamin supplementation programs. For example, UNICEF and the World Health Organization, WHO, have spearheaded initiatives to provide vitamin A supplements to children in regions where deficiency is prevalent. Similarly, iron-fortified foods are widely distributed in countries suffering from iron deficiency anemia. Global collaboration. Tackling vitamin deficiencies requires global collaboration between governments, international organizations, and local communities. Strategies like biofortification, where crops are genetically enhanced to contain higher levels of essential nutrients, e.g., golden rice with higher vitamin A, are being explored as sustainable solutions to global micronutrient malnutrition. Conclusion: the future of vitamins in a changing world. The role of vitamins in mental health, aging, global challenges, and socioeconomic equity continues to evolve. As research deepens, it is clear that vitamins are not just essential for preventing deficiencies but are pivotal in promoting mental resilience, cognitive function, and healthy aging. Moreover, addressing vitamin deficiencies in the context of climate change and socioeconomic disparities will require collaborative efforts, innovative technologies, and sustainable strategies. Vitamins will remain at the forefront of global health initiatives, supporting healthier populations, reducing the burden of chronic diseases, and improving the quality of life for people worldwide. As we continue to explore the vast potential of vitamins, a holistic approach that incorporates personalized nutrition, environmental sustainability, and equitable access will be key to addressing both present and future health challenges. Vitamins in disease prevention, a proactive approach to health. Vitamins are fundamental in preventing a variety of chronic diseases, not just through dietary intake but also via supplementation strategies. While deficiency-related diseases, e.g., rickets, scurvy, are well-known, chronic diseases like cardiovascular disease, diabetes, and cancer are increasingly linked to suboptimal vitamin intake. Vitamin D and cardiovascular health. Vitamin D and heart disease. There is growing evidence that vitamin D plays an important role in cardiovascular health. Adequate vitamin D levels may reduce the risk of heart disease, high blood pressure, and stroke. This is believed to be because vitamin D helps regulate blood pressure, supports heart muscle function, and prevents the buildup of plaque in arteries. Vitamin D and inflammation. Chronic low-grade inflammation is a key factor in many cardiovascular conditions. Research suggests that vitamin D has anti-inflammatory properties, which may help reduce the risk of atherosclerosis, the hardening and narrowing of arteries, and improve vascular health. Vitamin C and immune function. Immune system support. Vitamin C is essential for maintaining a healthy immune system, acting as an antioxidant and supporting the function of white blood cells. It has been shown to help boost immune response, reduce the severity of infections, and help the body recover faster from illness. Vitamin C and chronic diseases. Chronic diseases like cardiovascular disease and type 2 diabetes are associated with oxidative stress, a condition where harmful molecules called free radicals damage cells. Vitamin C's antioxidant properties help neutralize free radicals and may reduce the risk of chronic disease progression. Vitamin A and cancer prevention. Vitamin A and cancer. Vitamin A, particularly in its beta-carotene form, found in plant-based foods, plays an important role in cellular function and immune support. Studies suggest that adequate intake of vitamin A may help protect against certain cancers, particularly those of the lung, breast, and skin. It is thought that vitamin A's role in cell differentiation and immune response may be key in cancer prevention. Retinoid therapy for cancer. Retinoids, compounds derived from vitamin A, have also been studied for their role in cancer treatment. Researchers are exploring how retinoid therapy can be used to slow or stop the growth of cancer cells by influencing gene expression and enhancing immune surveillance. The future of vitamin research, emerging directions. As scientific understanding of vitamin functions expands, future research will likely focus on personalized nutrition, the biochemistry of vitamin metabolism, and the exploration of new compounds with potential health benefits. Personalized vitamin therapy. Genetic variations in vitamin requirements. Advances in nutrigenomics, the study of how genetics influence the way the body responds to nutrients, are expected to drive the future of personalized vitamin therapy. Research is uncovering how genetic variations affect vitamin absorption, metabolism, and utilization. Understanding an individual's genetic makeup will allow for more tailored vitamin regimens that meet specific health needs. Vitamin response. Personalized nutrition could lead to customized vitamin supplements based on individual needs and potential genetic variations. For instance, some people might metabolize vitamin D differently, requiring higher or lower doses, while others might need more vitamin B12 due to absorption issues. Bioavailability of vitamins. New delivery systems. While vitamins are essential for health, their bioavailability, the extent to which a nutrient can be absorbed and used by the body, varies depending on the form of the vitamin and the presence of other nutrients. The future of vitamin supplementation may involve innovative delivery systems such as nano-encapsulation, liposomal formulations, and slow-release supplements to increase the absorption and effectiveness of vitamins, particularly for people with digestive issues. Plant-based bioavailability. As more people adopt plant-based diets, researchers are focusing on the bioavailability of vitamins found in plants, such as vitamin D from mushrooms or iron from leafy greens. Improving the absorption of these vitamins through dietary strategies or supplementation could be key in addressing nutrient gaps in plant-based diets. The modern diet and nutritional challenges. Modern diets, particularly those rich in processed foods, have led to vitamin deficiencies and imbalanced nutrition. The increasing consumption of ultra-processed foods and the popularity of fast foods may result in poor intake of vitamin-rich foods, contributing to global health challenges. Vitamin deficiencies in the modern diet. Vitamin D deficiency. As many people spend less time outdoors and live in urban environments, vitamin D deficiency has become a widespread issue. Vitamin D is mainly obtained through sunlight exposure, and those who spend most of their time indoors or live in northern latitudes may not get enough. The rise in indoor lifestyles and the use of sunscreen has also contributed to a rise in deficiency rates. B vitamin deficiency. Vitamin B12 deficiency is particularly common in people following vegetarian or vegan diets, as it is mainly found in animal products. The modern tendency to consume a refined carbohydrate-heavy diet, which is often low in whole grains, fruits, and vegetables, can also lead to deficiencies in folate, vitamin B6, and other B vitamins that are essential for energy production and cognitive function. Inadequate vitamin A. A diet lacking in fruits and vegetables, particularly those rich in carotenoids, such as sweet potatoes, carrots, and spinach, can lead to a vitamin A deficiency. This is particularly problematic in low-income regions where access to diverse, nutritious foods is limited. Over-reliance on supplements. While vitamin supplementation can help correct deficiencies, there is concern that people may become over-reliant on supplements rather than focusing on a balanced diet. Supplementation should ideally be used to address specific deficiencies rather than to replace healthy eating habits. Oversupplementation can also lead to toxicity, especially with fat-soluble vitamins like A, D, E, and K, which can accumulate in the body and cause adverse effects. Fortification of foods. Fortifying staple foods like bread, milk, and cereals with vitamins and minerals is one solution to address global deficiencies. Many countries have successfully implemented fortification programs, e.g., fortifying salt with iodine, to ensure that populations receive essential nutrients. However, ongoing research is needed to identify the most effective vitamins to fortify and ensure that fortified foods are accessible to all. Lifestyle factors and vitamin needs. The stress levels, physical activity, and sleep patterns of modern life can significantly influence vitamin requirements. People living under chronic stress with poor sleep, or those who are highly active, may have increased demands for certain vitamins. The impact of stress on vitamin needs. Stress and vitamin C. Chronic stress depletes vitamin C levels, as it plays a crucial role in the adrenal gland's response to stress. When the body is under stress, it produces more cortisol, which in turn increases the need for vitamin C to combat oxidative stress and support immune function. Vitamin B complex and stress. Vitamins in the B complex group, especially B6, B12, and folate, are known to be involved in nerve function, energy production, and stress regulation. When the body is stressed, it often uses up these vitamins more rapidly. B12 deficiencies are also linked to mood disorders like depression, which is commonly associated with stress. Magnesium and stress. Magnesium, while not a vitamin, is a key nutrient that works in conjunction with vitamins to regulate muscle relaxation, nerve function, and stress reduction. People who are stressed may be at higher risk for magnesium deficiency, which can lead to muscle cramps, fatigue, and irritability. Exercise and vitamin needs. Vitamin D and exercise. Active individuals, especially those who engage in high-intensity sports, may have higher needs for vitamin D, as it supports muscle function and bone health. Adequate levels of vitamin D are important for athletes in preventing injuries and improving performance. Vitamin C in recovery. Athletes may also have increased vitamin C needs to help combat exercise-induced oxidative stress. Vitamin C's antioxidant properties can help repair tissue and reduce inflammation after intense physical activity. Conclusion: embracing the future of vitamin science. The role of vitamins in preventing disease, promoting mental health, and enhancing physical well-being is more important than ever. As we face global challenges, from climate change and food insecurity to aging populations and mental health crises, a better understanding of vitamin functions, absorption, and supplementation will be critical to improving global health. Future advancements in personalized nutrition, bioavailability, and vitamin delivery systems will allow for more effective and efficient ways of meeting our vitamin needs. With ongoing research, we can expect to gain deeper insights into the ways that vitamins contribute to optimal health, disease prevention, and longevity, leading to better health outcomes for individuals worldwide. Emerging vitamin-related technologies. As technology continues to evolve, new vitamin-based technologies and supplementation methods are emerging that could significantly improve our ability to maintain optimal health. These technologies are driven by advancements in genomics, biotechnology, and nanotechnology, and they promise to make vitamin supplementation more personalized, effective, and efficient. Nanoencapsulation of vitamins. Enhanced bioavailability. One of the biggest challenges with vitamins is ensuring that they are efficiently absorbed by the body. Nanoencapsulation involves enclosing vitamins in tiny particles, usually at the nanometer scale, to improve their absorption and bioavailability. This technology could potentially increase the effectiveness of fat-soluble vitamins like vitamin D, A, and E, which are often difficult for the body to absorb. Targeted delivery. Nanotechnology could also allow for targeted delivery of vitamins to specific parts of the body. For instance, liposomal formulations are already being used to deliver vitamin C and vitamin D more effectively to cells, improving their effectiveness. Future research could lead to the development of even more advanced systems that specifically target areas of the body that need certain vitamins most, such as bone tissue for vitamin D or the immune system for vitamin C. Smart supplements and wearable technology. Smart supplements. The future of vitamin supplementation may involve smart supplements that can be tailored to the individual's needs based on real-time data. For example, wearable devices like fitness trackers or biosensors could monitor vitamin levels in the body and send feedback to a mobile app, which would recommend precise vitamin dosages to optimize health. Mobile health applications. With the advent of mobile health apps, people can track their vitamin intake and nutrient levels to ensure they are meeting their daily needs. These apps might integrate with wearable devices to analyze blood biomarkers related to vitamin deficiencies and provide actionable advice on how to improve nutritional intake. Gene editing and vitamin synthesis. CRISPR and vitamin synthesis, gene editing technologies, particularly CRISPR-Cas9, are opening up exciting possibilities for biofortification, the process of genetically modifying plants to enhance their vitamin content. In the future, it might be possible to create genetically engineered crops that contain higher levels of specific vitamins, helping populations suffering from deficiencies access nutrients directly from their food. Biosynthesis of vitamins. Gene editing tools might also be used to produce vitamins through synthetic biology. For example, microbes could be engineered to produce vitamins in large quantities, enabling more sustainable and cost-effective vitamin production. This approach could lead to new ways of producing essential vitamins for supplementation or fortification. potentially reducing the need for synthetic vitamin production. Vitamin-based therapies, the future of personalized medicine. The potential for vitamins to be used therapeutically is becoming a major area of focus in both medical research and clinical practice. Vitamin-based therapies could go beyond simply preventing deficiencies and evolve into treatments for various health conditions. Vitamin D and autoimmune diseases. Autoimmune disease prevention. Vitamin D is being researched for its role in autoimmune diseases like multiple sclerosis, rheumatoid arthritis, and type 1 diabetes. It is thought that vitamin D helps modulate the immune system, preventing the overreaction of immune cells that can damage tissues and organs. Clinical trials are underway to see if vitamin D supplementation can help prevent or manage autoimmune conditions by supporting the immune system's balance. Vitamin D as a therapy for inflammation. Vitamin D's role in regulating inflammatory processes has also led to investigations into its use as a therapeutic agent for diseases associated with chronic inflammation, such as inflammatory bowel disease, IBD, asthma, and arthritis. Studies suggest that vitamin D supplementation could reduce inflammatory markers, improving outcomes in individuals with these conditions. Vitamin B12 in neurological disorders, cognitive decline, and Alzheimer's disease. Vitamin B12 is essential for nerve health, and its deficiency can lead to neurological symptoms such as memory loss, numbness, and tingling. There is increasing interest in using vitamin B12 therapy to treat neurodegenerative diseases like Alzheimer's disease and Parkinson's disease, where B12 may help improve cognitive function and nerve repair. Research is ongoing into the therapeutic potential of high-dose B12 for slowing cognitive decline in elderly patients. Vitamin B12 and mood disorders. Emerging research suggests that vitamin B12 supplementation may help improve mood in people with depression, particularly in those who have low levels of B12. B12 is involved in the production of serotonin, the neurotransmitter linked to mood regulation. Supplementing B12 in combination with other therapies may offer a new approach to managing depression and anxiety. Vitamin A in cancer treatment. Retinoid therapy for cancer. Retinoids, which are derived from vitamin A, are being explored for their ability to help treat cancers. Retinoids are believed to have anti-tumor properties that can slow or stop the growth of certain cancer cells. Clinical studies are evaluating how retinoids can be used to complement traditional cancer treatments like chemotherapy and radiation, offering potential for reducing cancer progression and improving patient outcomes. Vitamin A in skin cancer. Research into the role of vitamin A in preventing skin cancer and melanoma has also garnered attention. Topical applications of retinoid creams have been studied for their ability to reduce skin cancer risk by promoting healthy cell turnover and repairing damaged skin cells. Addressing vitamin deficiency, a global perspective. While vitamin deficiencies are a concern worldwide, certain regions face unique challenges in providing adequate nutrition to their populations. Let's explore some of the key issues and solutions for addressing global vitamin deficiencies. Vitamin A deficiency and its impact. Global health impact. Vitamin A deficiency, VOD, is a major cause of preventable blindness in children and can also contribute to immune system suppression. It remains a serious public health concern in many developing countries where access to vitamin A-rich foods, like dark leafy greens, orange vegetables, and animal liver, is limited. Vitamin A supplementation programs have been successful in some regions, but more work is needed to address this issue on a global scale. Biofortification to combat VOD. One promising solution to vitamin A deficiency is biofortification. This involves genetically modifying crops like golden rice to contain higher levels of beta-carotene, a precursor to vitamin A. This strategy aims to provide populations with limited access to vitamin A-rich foods a reliable source of this essential nutrient. Iron deficiency and anemia. Iron deficiency anemia. Iron deficiency is the most common nutritional deficiency in the world, particularly among women and children in low-income countries. Anemia caused by iron deficiency can lead to fatigue, impaired immune function, and reduced cognitive performance. Iron supplements are commonly used to treat this condition. But efforts to combat deficiency also include fortification of staple foods, like flour and rice, with iron. Addressing iron deficiency in pregnancy. Pregnant women are at higher risk for iron deficiency anemia, which can lead to preterm birth and low birth weight. National health programs that provide iron and folic acid supplements to expectant mothers have been shown to reduce these risks significantly. Folate deficiency and birth defects. Folate and neural tube defects. Adequate intake of folate, vitamin B9, before and during pregnancy is critical to reducing the risk of neural tube defects, NTDs, like spina bifida. In many countries, folic acid is now added to fortified grains to help prevent NTDs. But educational campaigns are still needed to ensure that women of reproductive age are aware of the importance of folate during the early stages of pregnancy. Global fortification efforts. Some countries have successfully implemented mandatory folic acid fortification programs, which have led to a significant reduction in the prevalence of neural tube defects. Expanding these programs to more countries and communities could have a major impact on maternal and child health worldwide. Conclusion: a bright future for vitamins. Vitamins play a central role in maintaining good health, preventing diseases, and supporting our mental and physical well-being. As scientific understanding and technological advancements continue to evolve, the future of vitamins holds immense promise, with personalized supplementation, novel vitamin-based therapies, and innovative delivery systems offering new opportunities to optimize health outcomes. At the same time, addressing global vitamin deficiencies and ensuring that vitamins are accessible to everyone, regardless of their geographic location or socioeconomic status, remains an important challenge. Through research, policy, and technological innovation, we can work towards a future where vitamins contribute to the well-being of people worldwide, enhancing health and quality of life for all. Emerging trends in vitamin research, novel findings and technologies. Advancements in science and technology are providing us with new tools to understand vitamins and their roles in human health, leading to exciting breakthroughs in vitamin-related therapies, bioavailability, and global nutrition strategies. Vitamins and the gut microbiome. The role of the microbiome, the gut microbiome, the trillions of bacteria and other microorganisms living in the digestive system, plays a crucial role in nutrient absorption, including the absorption of vitamins. New research is uncovering how the microbiome affects the body's ability to process and absorb certain vitamins. This is particularly important for fat-soluble vitamins, A, D, E, K, which require a healthy gut for proper absorption. Gut health and vitamin D, which is essential for bone health, immune function, and cardiovascular health, is closely tied to gut health. Studies suggest that a diverse microbiome may help increase vitamin D absorption, improving its bioavailability. Research is also looking into how gut bacteria may influence how the body converts vitamin D into its active form, highlighting the link between gut health and immune support. Gut-driven vitamin synthesis. Interestingly, certain gut bacteria are capable of synthesizing vitamin K2, a form of vitamin K that plays a key role in bone health and cardiovascular function. This suggests that improving gut health through probiotics and a balanced diet could help optimize the body's use of vitamins, potentially reducing the need for supplementation. Vitamin E and aging. Anti-aging properties. Vitamin E is an antioxidant. Vitamin E, known for its powerful antioxidant properties, may play a role in slowing down the aging process. Oxidative stress caused by free radicals is a major contributor to cellular aging and degenerative diseases like Alzheimer's. New research suggests that vitamin E may reduce oxidative damage and improve skin health, delaying signs of aging and improving cognitive function in older adults. Vitamin E and skin health. In addition to fighting oxidative stress, vitamin E is also known to promote healthy skin. It is commonly included in skincare products due to its ability to reduce wrinkles, skin inflammation, and improve overall skin elasticity. Studies are ongoing into how vitamin E can be used in combination with other treatments for anti-aging therapies, vitamins and cancer prevention, exploring new frontiers. Vitamin D in cancer prevention. Vitamin D has long been recognized for its role in bone health, but recent studies have suggested that it may also play a protective role in cancer prevention. Adequate levels of vitamin D may lower the risk of developing certain cancers, particularly colon, breast, and prostate cancers. Researchers are studying how vitamin D modulates the immune system and gene expression to prevent the abnormal cell growth that leads to cancer. Vitamin E and anti-cancer effects. Research into vitamin E's anti-cancer properties is expanding. Vitamin E may help to prevent cancer cell growth by neutralizing free radicals and reducing oxidative damage to cells. Clinical trials are evaluating its potential in cancer therapies, particularly for skin and lung cancers. However, more studies are needed to determine its effectiveness in different cancer types. Vitamin B12 and cognitive function. Vitamin B12 deficiency and brain health. There is increasing evidence that vitamin B12 deficiency can have severe consequences for brain function. Insufficient B12 levels have been linked to memory loss, confusion, and dementia in older adults. Researchers are investigating the role of vitamin B12 in neuroprotection, especially in people at risk of neurodegenerative diseases like Alzheimer's and Parkinson's. The link between folate and B12, folate, vitamin B9, works in conjunction with vitamin B12 in the body to maintain cognitive health. These two B vitamins are crucial in the formation of red blood cells, the function of the nervous system, and the repair of DNA. Emerging research suggests that ensuring adequate intake of both vitamins may be key to maintaining mental health and preventing age-related cognitive decline. Global public health strategies for addressing vitamin deficiencies. Despite the growing availability of vitamins in supplements, vitamin deficiencies remain a significant problem, particularly in developing countries and areas affected by food insecurity. Public health efforts to combat these deficiencies are evolving and becoming more integrated into global nutrition policies. Vitamin A deficiency and global nutrition programs. Vitamin A supplementation programs. Vitamin A deficiency is a leading cause of preventable blindness in children and contributes to immune system suppression. In response, many countries have implemented mass vitamin A supplementation programs, especially in regions where the diet lacks vitamin A-rich foods, such as carrots, sweet potatoes, and dark leafy greens. The World Health Organization, WHO, recommends high-dose vitamin A supplementation for children under 5 in areas with high deficiency rates. Biofortification in golden rice. In countries where vitamin A deficiency is rampant, biofortification efforts are being implemented to improve the nutritional quality of staple crops. Golden rice, for example, is genetically modified to produce higher levels of beta-carotene, the precursor to vitamin A. This innovation can potentially provide a sustainable, food-based solution to vitamin A deficiency. Folic acid fortification to prevent neural tube defects. Mandatory folic acid fortification. Folate is essential for neural tube development during early pregnancy. Many countries have adopted mandatory folic acid fortification in staple foods, such as wheat flour, to reduce the incidence of neural tube defects, NTDs, in newborns. This public health measure has been successful in many countries, leading to a dramatic decrease in NTD rates. Educational campaigns. While folic acid fortification has been successful, many women still fail to take supplements in the early stages of pregnancy. Ongoing educational campaigns aim to raise awareness about the importance of folate during the preconception period and early pregnancy to further reduce NTDs globally. Iodine deficiency and salt iodization programs. Iodine deficiency prevention. Iodine deficiency remains a major public health issue in parts of the world, especially in regions where iodine-rich foods, like seafood, are not widely consumed. Iodine deficiency can lead to goiter and developmental delays in children. Many countries have adopted salt iodization as a cost-effective solution to prevent iodine deficiency. By adding iodine to table salt, which is consumed by nearly every household, Iodine deficiency rates have dropped significantly in areas with historically low iodine intake. Future innovations in vitamin production and sustainability. Sustainability is becoming an important focus in vitamin production as the world faces challenges related to climate change and resource conservation. Future vitamin production methods are likely to prioritize sustainability, efficiency, and environmental impact. Sustainable vitamin production. Plant-based vitamin synthesis, as demand for plant-based diets increases. Sustainable production methods are needed to meet the vitamin needs of populations that follow vegetarian or vegan diets. Plant-based vitamins and their bioavailability are gaining more attention as solutions to meet the nutritional needs of those avoiding animal-based products. Fermentation and microbial synthesis. Some vitamins, like vitamin B12, are produced through microbial fermentation. Advances in fermentation technology are making it possible to produce vitamins more sustainably, with fewer resources and reduced environmental impact. This process uses microbes to synthesize vitamins, which can then be harvested and purified for use in supplements or food fortification. Precision agriculture and vitamin-rich crops. Fortified crops. Advances in precision agriculture are allowing farmers to grow crops with higher levels of key vitamins through genetic modification or biofortification. This approach offers a sustainable, environmentally friendly way to enhance global nutrition by ensuring that crops are nutrient-dense, especially in regions where access to fresh, varied produce is limited. Vertical farming and vitamin-rich foods. Urban farming and vertical farming are emerging trends in food production, particularly in cities. These techniques offer the potential to grow highly nutritious crops, such as leafy greens, herbs, and tomatoes, in controlled, indoor environments. These crops can be enhanced with vitamins to provide essential nutrients year-round, contributing to better nutrition for urban populations. The influence of age and lifestyle on vitamin needs. As we age, our body's ability to absorb, metabolize, and utilize vitamins can change. Understanding how age, lifestyle, and chronic conditions influence vitamin requirements is crucial for maintaining optimal health throughout the lifespan. Age-related changes in vitamin metabolism. Vitamin D and aging. As we age, the body's ability to produce vitamin D from sunlight decreases, and the kidneys become less efficient at converting it into its active form. This makes older adults more vulnerable to vitamin D deficiency. Supplementation and vitamin D-rich foods become more important for preventing bone loss, muscle weakness, and immune dysfunction in older adults. Vitamin B12 deficiency in older adults. Vitamin B12 absorption also declines with age, especially due to a reduction in stomach acid production. Older adults may need higher levels of vitamin B12 through fortified foods or supplements to prevent cognitive decline and neurological issues. Conclusion: a future of optimized health and vitamin research. The future of vitamins holds immense potential for improving global health, from personalized nutrition to cutting-edge technologies. New vitamin-based therapies and sustainable production methods will revolutionize the way we meet our nutritional needs. By focusing on education, biofortification, and innovative supplementation methods, we can address vitamin deficiencies and ensure a healthier, more sustainable world for generations to come. The continued advancement of vitamin science promises to play a critical role in achieving better health outcomes across the globe. Vitamin science, integrating technology, genomics, and personalized health. As technology and personalized medicine continue to advance, the future of vitamin supplementation is increasingly geared toward more individualized and precise health solutions. Genomics and vitamin absorption. Genetic influence on vitamin needs. Advances in nutrigenomics, the study of how genes and nutrition interact, are revealing that genetic variations can affect how efficiently the body absorbs, metabolizes, and utilizes vitamins. For example, some people may have genetic variations that affect their ability to absorb vitamin D or folate from food. Understanding these genetic influences can help develop personalized vitamin plans to optimize health outcomes and prevent deficiencies. Genetic testing for vitamin needs. with the advent of genetic testing, it is becoming possible to tailor vitamin supplementation based on an individual's specific genetic makeup. This technology could allow healthcare providers to recommend the optimal dosage and types of vitamins a person should take based on their DNA. This kind of precision medicine could help address nutrient deficiencies more effectively and avoid unnecessary supplementation. Personalized nutrition and AI integration. Artificial intelligence, AI, and health data. Artificial intelligence, AI, is playing a growing role in personalized nutrition. AI-powered apps and platforms are already being developed to analyze data from wearable devices, blood tests, and dietary habits. These platforms can provide personalized recommendations on vitamin supplementation based on real-time health metrics. For example, an AI tool could suggest adjustments to your vitamin intake based on your exercise routine, sleep patterns, or stress levels, helping you meet specific health goals more effectively. Nutrition apps and smart devices. Apps that track vitamin intake are becoming more sophisticated. Some apps now integrate with smartwatches or fitness trackers, measuring parameters like blood pressure, blood sugar levels, or even hydration to provide personalized vitamin and nutrient recommendations. This could allow for continuous monitoring and more targeted advice for individuals looking to optimize their health, as well as preventive care for those at risk of certain deficiencies. Environmental changes and their impact on vitamin needs. Climate change, urbanization, and environmental degradation are factors that could significantly affect vitamin availability and absorption in the future. Understanding these influences will be critical in shaping the global nutritional landscape. Climate change and crop nutrient levels. The impact of CO2 on vitamin content. Research has shown that rising CO2 levels could decrease the nutritional content of certain crops, including their vitamin levels. For example, higher CO2 concentrations have been linked to lower levels of zinc and iron in staple crops like rice and wheat. As global temperatures rise, nutrient-poor foods could exacerbate existing nutritional deficiencies in many parts of the world, especially in developing nations where people rely on basic grains for sustenance. Solutions for climate-resilient crops. Addressing these challenges may involve developing climate-resilient crops that maintain or even enhance their nutritional content despite environmental stressors. Biofortification can be a key strategy in this regard, ensuring that even as the climate changes, crops are still rich in essential vitamins and minerals. Research into growing crops with higher levels of vitamin C, vitamin A, and iron could help combat potential nutrient loss due to climate change. Urbanization and access to fresh, nutrient-rich foods. Access to fresh foods in urban areas. As the world's population continues to urbanize, access to fresh, nutrient-dense foods may become more limited, especially in food deserts where access to fresh produce is scarce. Urban farming and vertical farming could help mitigate these issues by growing nutrient-dense vegetables and fruits locally, making them more accessible and reducing the carbon footprint of food production. Future urban food systems could include urban greenhouses and hydroponic farms that allow for the year-round production of fresh, vitamin-rich crops like leafy greens, tomatoes, and berries. Food system innovations for sustainability. Sustainable food systems will be crucial to meeting global vitamin needs. The growing interest in plant-based diets and lab-grown foods could create new avenues for providing essential vitamins. Lab-grown meats and alternative proteins such as edible insects, algae, and fermented foods can be rich in essential vitamins, offering an innovative solution to address nutrient gaps while reducing the environmental impact of food production. Public health strategies to address vitamin deficiencies. While technological and scientific innovations continue to emerge, public health strategies remain essential for addressing widespread vitamin deficiencies, particularly in resource-limited regions. Global vitamin A supplementation campaigns. Expanding vitamin A distribution. Vitamin A deficiency, VOD, remains a critical issue in many parts of Africa, Asia, and Latin America, leading to preventable blindness and immune system dysfunction. Global health organizations. including the WHO and UNICEF, have been spearheading vitamin A supplementation campaigns. These programs provide high-dose vitamin A supplements to children in affected areas, which can significantly reduce the rates of child mortality and blindness. Future public health initiatives will likely focus on improving access to vitamin A-rich foods and enhancing the fortification of staple foods like rice and corn. Folic acid fortification and birth defects prevention. Expanding folic acid fortification. Folic acid fortification has been instrumental in reducing neural tube defects, NTDs, such as spina bifida and anencephaly. However, despite significant success, many countries still do not implement mandatory folic acid fortification. Expanding these efforts globally could dramatically reduce the incidence of NTDs and improve maternal and child health outcomes. Public health campaigns will need to continue raising awareness of the importance of folate in preventing birth defects, particularly for women of childbearing age. Addressing micronutrient malnutrition in developing countries. Scaling up micronutrient supplementation. Malnutrition remains a pressing issue, with millions of people suffering from micronutrient deficiencies. Programs that distribute micronutrient powders, MNPs, which contain a combination of vitamins and minerals, to children and pregnant women are already showing positive results in improving nutrition and immune health. These efforts can be expanded and integrated into healthcare systems, focusing on targeted interventions to reach those most at risk of deficiency. Biofortification of staple foods. Countries facing chronic micronutrient deficiencies could turn to biofortification to improve the nutrient content of staple crops. For example, iron-fortified rice and vitamin A-rich cassava can provide populations with critical nutrients without requiring significant changes to their eating habits or food production systems. Ensuring that these biofortified foods reach people in rural areas and low-income communities will be crucial in addressing hidden hunger and improving global health. Innovations in vitamin production and sustainable practices. As the demand for vitamins continues to grow, so does the need for innovative and sustainable production methods. Here are some of the key innovations that may shape the future of vitamin production. Synthetic biology for vitamin production. Microbial production of vitamins. Synthetic biology is revolutionizing vitamin production by using genetically engineered microorganisms, such as bacteria and yeast, to produce vitamins like B12, vitamin C, and vitamin D. These methods are environmentally friendly and can scale up production efficiently, making vitamins more accessible and affordable. Microbial fermentation has already been widely adopted for the mass production of vitamin B12, and researchers are exploring its potential for producing other vitamins in a similar way. Sustainable vitamin synthesis. Biological synthesis from renewable resources. The future of vitamin production will likely see a shift towards sustainable and bio-based methods, using renewable resources such as algae, plant-based biomass, or even waste products from agriculture and food industries. This reduces the environmental footprint of vitamin production and minimizes dependence on synthetic chemical processes. Algae-based vitamins are already becoming a popular alternative for vitamin D and omega-3 fatty acids, offering a more sustainable solution than traditional animal-based sources. Food waste utilization for vitamin production. Upcycling food waste. As the world grapples with food waste and its environmental impact, some researchers are looking into ways to upcycle food scraps into valuable nutrients. For instance, spent grains from brewing and fruit peels could be used to extract vitamins such as vitamin C or B vitamins, contributing to a circular economy in food production. This approach not only tackles food waste but also offers a more sustainable method of nutrient generation. Conclusion. A holistic approach to vitamin health. The future of vitamin science holds great promise, driven by innovations in technology, sustainable food systems, and personalized health solutions. By integrating genomics, artificial intelligence, and environmental sustainability, we can optimize vitamin intake across the lifespan while addressing global deficiencies. whether through biofortification, vitamin-rich crops, or personalized supplementation. Vitamins will continue to be a cornerstone of human health, helping people of all ages achieve optimal nutrition and well-being in the years to come. The role of vitamins in aging populations and longevity. As the global population ages, the nutritional needs of older adults become more critical. Vitamins play an essential role in maintaining health and preventing chronic diseases that are prevalent in aging populations. Understanding how vitamins can contribute to healthy aging will be key to managing the health of aging societies. Vitamin D and bone health in the elderly. Preventing osteoporosis. As we age, our bones become more susceptible to osteoporosis due to a decrease in bone mineral density. Vitamin D plays a critical role in calcium absorption, which is essential for bone health. Deficiency in vitamin D is linked to weak bones and an increased risk of fractures in the elderly. In many older adults, the body's ability to synthesize vitamin D from sunlight decreases, making supplementation important. Vitamin D in preventing muscle weakness. Beyond bone health, vitamin D also helps maintain muscle strength. Deficiency has been associated with muscle weakness and falls in older adults, given the high rates of falls and fractures in elderly populations. Ensuring adequate vitamin D levels can significantly contribute to reducing the risk of injuries and improving quality of life for seniors. Vitamin B12 and cognitive health. B12 deficiency and cognitive decline. As people age, the body's ability to absorb vitamin B12 from food declines, which can lead to neurological issues, including memory problems, dementia, and depression. Ensuring that older adults receive adequate levels of vitamin B12 is crucial for maintaining cognitive health and mental clarity. In fact, B12 deficiency has been implicated in the onset of Alzheimer's disease, and some studies suggest that correcting B12 deficiency may slow cognitive decline in the elderly. B vitamins in preventing dementia. There is growing evidence that the B vitamins, including B6, B9, folate, and B12, may help lower homocysteine levels in the blood, a substance linked to neurodegenerative diseases. Proper intake of these vitamins may protect against dementia and memory loss, making them critical nutrients for elderly populations. Antioxidant vitamins for age-related diseases. Vitamin C and skin aging. As we age, the skin's ability to produce collagen declines, leading to wrinkles, sagging, and loss of elasticity. Vitamin C, a powerful antioxidant, plays a key role in collagen production. It also helps protect the skin from the damaging effects of free radicals, which accelerate the aging process. Ensuring adequate vitamin C intake can help reduce visible signs of aging and maintain skin health. Vitamin E for cellular protection. Vitamin E is another potent antioxidant that helps protect cells from oxidative stress. As the body ages, oxidative stress increases, leading to cellular damage and the development of age-related conditions such as arthritis, heart disease, and cancer. Vitamin E can reduce inflammation and may play a role in slowing the progression of these conditions. Emerging vitamin research and technological innovations. As science progresses, new technologies and research are shaping how we view vitamins and their role in health and disease prevention. From biotechnology to nutritional interventions, innovations are pushing the boundaries of vitamin-related science. Microbiome and vitamin synthesis. Gut microbiome's role in vitamin production. As research on the gut microbiome advances, scientists are discovering that the microbes living in our digestive system have a significant impact on vitamin synthesis. Certain gut bacteria produce essential vitamins, such as vitamin K and biotin, vitamin B7, and are involved in vitamin B12 metabolism. Understanding the relationship between the microbiome and vitamins will enable new strategies to optimize vitamin absorption and enhance overall health. Probiotics and prebiotics for better vitamin absorption. The use of probiotics and prebiotics may also play a crucial role in improving vitamin absorption and synthesis. Probiotic-rich foods like yogurt, fermented vegetables, and kombucha can help balance the gut microbiota, while prebiotics like fiber nourish beneficial bacteria. potentially increasing the body's ability to absorb and utilize vitamins more effectively. Personalized nutrition and vitamin optimization. DNA testing for personalized vitamin plans, personalized nutrition. Powered by advancements in genomics and big data, is expected to revolutionize the way we approach vitamin supplementation. DNA tests, such as those offered by companies like 23andMe and Ancestry.com, are now being used to provide insight into an individual's genetic predisposition to vitamin deficiencies or needs. As a result, individuals could receive tailored vitamin recommendations based on their genetic makeup, lifestyle, and health goals. Artificial intelligence and nutritional guidance, AI-powered apps and platforms are increasingly being used to help individuals optimize their vitamin intake. These tools can track an individual's diet, exercise patterns, and health data to provide personalized advice on vitamin supplements or adjustments. Additionally, AI is being used to predict how specific vitamin deficiencies might affect a person's overall health, enabling proactive interventions to optimize vitamin intake. Global public health policies and initiatives on vitamin deficiencies. Addressing vitamin deficiencies on a global scale requires a multifaceted approach that includes policy reforms, public health education, and innovative interventions. Here are some key areas where policies could drive progress in improving global health. Vitamin D and global health policies. Expanding vitamin D supplementation. In many countries, vitamin D deficiency is a widespread issue, particularly in regions with long winters or limited sunlight exposure. Governments and health organizations are starting to recognize the need for universal vitamin D supplementation. Policies that incorporate vitamin D fortification in common foods like milk, bread, and orange juice could have a profound impact on public health, reducing rates of osteoporosis, cardiovascular disease, and autoimmune disorders. Vitamin D for vulnerable populations. Special attention should be given to populations at greater risk of vitamin D deficiency, such as infants, elderly adults, and people with darker skin. Implementing targeted supplementation programs for these groups can help prevent the health complications associated with vitamin D deficiency, especially in regions with limited sunlight exposure. Vitamin A deficiency and public health campaigns. Scaling up vitamin A supplementation. Vitamin A deficiency, VOD, continues to be a major cause of blindness and immune system dysfunction in children, particularly in parts of sub-Saharan Africa and South Asia. Public health organizations are working to expand vitamin A supplementation programs to ensure that children under 5 receive the necessary doses, increasing access to vitamin A-rich foods like sweet potatoes, carrots, and dark leafy greens, as well as supporting biofortified crops, will also be important strategies in the fight against VOD. Biofortified foods for sustainable nutrition. Biofortification, the process of increasing the nutrient content of crops through conventional breeding or genetic modification, is a powerful tool to address vitamin deficiencies. For example, golden rice is genetically engineered to produce higher levels of beta-carotene, which the body can convert into vitamin A. Biofortified crops like golden rice have the potential to provide long-term solutions for populations at risk of vitamin A deficiency. Folic acid fortification to prevent birth defects. Universal folic acid fortification. One of the most successful global health initiatives has been the fortification of staple foods like flour with folic acid to prevent neural tube defects, NTDs. Public health campaigns in countries like the United States, Canada, and several European nations have significantly reduced the incidence of NTDs in newborns. Expanding folic acid fortification programs to developing countries where NTDs remain prevalent could save thousands of lives and prevent birth defects. Education campaigns for women of reproductive age, even in countries with folic acid fortification programs. Many women may not be aware of the importance of folate before and during pregnancy. Educational campaigns targeting women of childbearing age about the importance of folic acid for preventing NTDs could further improve health outcomes. Conclusion: the future of vitamins in global health. The future of vitamins lies at The intersection of advancements in science, public health innovation, and personalized medicine. As we move forward, the integration of genetic insights, microbiome research, artificial intelligence, and sustainable food systems will allow us to address the challenges of vitamin deficiencies more effectively. Whether it's through fortification, biofortification, supplementation, or personalized nutrition, vitamins will continue to play a crucial role in improving the health and longevity of populations worldwide, contributing to a healthier, more resilient global society. Vitamins and their role in chronic diseases. Chronic diseases such as cardiovascular disease, diabetes, cancer, and obesity are among the leading causes of mortality worldwide. Vitamins play a crucial role in the prevention, management, and progression of these conditions. Emerging research continues to highlight the preventive and therapeutic potential of vitamins. Vitamin D and cardiovascular disease. Vitamin D's role in heart health. Emerging research suggests that vitamin D plays an important role in reducing the risk of cardiovascular diseases. Vitamin D helps regulate blood pressure, improves vascular health, and has anti-inflammatory effects, all of which are essential for maintaining heart health. Deficiency in vitamin D has been linked to an increased risk of hypertension, atherosclerosis, and heart failure. Vitamin D supplementation for heart disease prevention. Some studies suggest that adequate levels of vitamin D may help lower the risk of stroke and heart attack by supporting proper calcium regulation in the arteries. As the global population ages and cardiovascular diseases become more prevalent, ensuring sufficient vitamin D levels through diet and supplementation may play an important role in preventive cardiology. Vitamin B6, B9, folate, and B12 in diabetes management. Managing blood sugar with B vitamins. Vitamins in the B-complex family, including B6, B9, and B12, are essential for glucose metabolism and may help regulate blood sugar levels in people with diabetes. Vitamin B6, in particular, is involved in insulin secretion and the utilization of glucose by cells. Folate and B12 are critical for proper nerve function, and deficiency in these vitamins is common in individuals with diabetes, leading to complications like neuropathy. Homocysteine regulation. High levels of homocysteine, an amino acid, are a risk factor for diabetes-related complications such as heart disease and kidney damage. Adequate intake of folate, B6, and B12 helps regulate homocysteine levels, thereby reducing the risk of cardiovascular and kidney diseases in diabetic individuals. Vitamin A and cancer prevention. Vitamin A and its anti-cancer properties. Research into the role of vitamin A, through its active form, retinol, suggests that it may help prevent the development of certain types of cancer, particularly cancers of the skin, lungs, and the digestive system. Vitamin A acts as a powerful antioxidant, protecting cells from the damage caused by free radicals, and has been shown to support the body's immune system, which is vital in detecting and eliminating cancerous cells. Retinoids in cancer treatment, in addition to prevention. Retinoids, vitamin A derivatives, are being studied for their potential as a treatment for skin cancer, leukemia, and other malignancies. They have shown promise in regulating gene expression and in promoting the differentiation of cancer cells into normal, healthy cells. Vitamin C and immune function. Supporting the immune system, vitamin C is a potent antioxidant that supports immune function by stimulating the production of white blood cells, which help fight infections during times of stress or illness, such as during cancer treatment or chronic infections. The body's need for vitamin C increases. Studies suggest that vitamin C supplementation can shorten the duration of colds and reduce the severity of symptoms. Vitamin C and chronic inflammation. Chronic inflammation is at the root of many non-communicable diseases such as heart disease, diabetes, and arthritis. Vitamin C's antioxidant properties help neutralize free radicals, reducing oxidative stress and inflammation, which can significantly lower the risk of these conditions. Emerging research on vitamins and new diseases. With new diseases and health challenges emerging globally, Vitamin science is continually evolving to explore how vitamins may be used to treat or prevent these conditions. Vitamin D and autoimmune diseases. Vitamin D and immune modulation. Research is increasingly showing that vitamin D is crucial for the regulation of the immune system, potentially helping to prevent or mitigate the development of autoimmune diseases. Conditions like multiple sclerosis, MS, rheumatoid arthritis, and type 1 diabetes have been associated with low levels of vitamin D. Some studies suggest that vitamin D may help modulate immune responses and prevent the immune system from attacking the body's own tissues. Vitamin D and COVID-19. During the COVID-19 pandemic, research emerged suggesting that vitamin D deficiency could increase the risk of severe illness and complications from the virus. Adequate levels of vitamin D may play a role in reducing inflammation, boosting immune function, and improving respiratory health, which is critical in fighting viral infections. The role of vitamins in mental health. Vitamins and depression. There is growing evidence that deficiencies in certain vitamins, including vitamin D, B12, and folate, may contribute to the development of depression, anxiety, and other mood disorders. For instance, low levels of vitamin B12 are often associated with fatigue, irritability, and cognitive dysfunction, all of which are symptoms commonly linked to depression. Vitamin D and mental health. Vitamin D deficiency has been linked to an increased risk of depression, seasonal affective disorder, SAD, and schizophrenia. Ensuring that individuals have adequate levels of this vital vitamin may not only help prevent mood disorders but may also play a key role in mental health treatment and therapy. Public health strategies for addressing global vitamin deficiencies. To combat the widespread issue of vitamin deficiencies globally, governments and organizations are developing public health strategies to improve access to vitamin-rich foods and supplementation programs. Global vitamin D supplementation programs. Universal vitamin D fortification. Countries with high rates of vitamin D deficiency, particularly those in northern latitudes with limited sunlight exposure, may implement fortification programs to ensure that the population gets enough of this vital nutrient. For example, countries like Finland and Norway have had successful programs fortifying milk and other dairy products with vitamin D to combat deficiency, particularly among children and elderly adults. Addressing at-risk groups. Special focus should be given to elderly populations, pregnant women, infants, and individuals with darker skin, who are at higher risk of vitamin D deficiency. Public health initiatives may include offering vitamin D supplements in clinics, as well as increasing public awareness about the importance of getting enough vitamin D. Food fortification and biofortification. Expanding food fortification programs. Food fortification, adding essential nutrients to commonly consumed foods, is a highly effective strategy for addressing widespread nutrient deficiencies. Iodine fortification of salt and iron fortification of flour have been key to eliminating iodine deficiency and iron deficiency anemia, respectively. Similarly, fortifying staple foods with vitamin A, vitamin D, and folic acid can help address widespread deficiencies in developing nations. Biofortification for sustainable nutrition. Biofortified crops, such as golden rice, rich in vitamin A and iron-fortified beans, have the potential to provide a sustainable solution to nutrient deficiencies. These crops are grown to naturally have higher nutrient levels, improving access to essential vitamins and minerals for populations that lack dietary variety. Public health education and awareness. Raising awareness about vitamin deficiencies. Public health education campaigns aimed at improving knowledge about the importance of vitamin intake and the risks associated with deficiencies are crucial. Programs targeting pregnant women, children, and adults can encourage healthier eating habits and proper supplementation where necessary. Innovating public health messaging. Creative campaigns leveraging social media, community outreach, and public health influencers can help promote vitamin-rich diets and raise awareness about the signs and symptoms of vitamin deficiencies. Educational materials that focus on the practical ways to include more nutrient-dense foods, such as fruits, vegetables, and fortified grains, can be impactful tools in tackling global malnutrition. Conclusion: shaping a healthier future with vitamins. The future of vitamins in public health, disease prevention, and personalized nutrition holds tremendous promise. With increasing scientific research, technological innovations, and global public health initiatives, we are moving toward a future where vitamin deficiencies are better understood and addressed. By leveraging new discoveries in genomics, microbiome health, and sustainable food systems, we can optimize vitamin intake to prevent chronic diseases, enhance mental health, and support healthy aging. Public health strategies, global education, and innovative solutions will pave the way for a future where people worldwide can achieve optimal nutrition, combat deficiencies, and live longer, healthier lives. The role of personalized nutrition in vitamin health. Personalized nutrition has gained momentum as a powerful tool for tailoring health interventions to individual needs. With advancements in genomics, artificial intelligence, and biotechnology, personalized vitamin supplementation and dietary plans are becoming more accessible and effective. Genetics and vitamin requirements. Genetic variations in vitamin metabolism. As we advance in the understanding of nutrigenomics, it's becoming clear that individual genetic variations influence how people metabolize and utilize vitamins. For example, certain genetic variants can affect the ability to absorb or process vitamin D, leading to higher or lower requirements for supplementation. Understanding these genetic markers will allow for more targeted vitamin recommendations. Tailored vitamin plans. Companies are increasingly offering DNA testing to provide personalized vitamin plans based on an individual's genetic makeup. These tests can help determine the right levels of essential vitamins, such as vitamin D, B12, and folate, which are critical for individuals with specific genetic predispositions or health conditions. Personalized health apps and AI integration. Artificial intelligence in nutrition. AI-based applications now enable individuals to track their nutritional intake in real time and receive recommendations for vitamin-rich foods or supplements based on their lifestyle, activity level, and health data. By integrating data from fitness trackers, health wearables, and dietary apps, AI can make precise suggestions to improve vitamin intake and correct deficiencies. Smart supplements. Future smart supplements could use AI and machine learning to adjust the doses of vitamins based on the real-time needs of the body. For instance, microsensors could detect nutrient deficiencies in an individual's body and prompt them to take the appropriate vitamins at optimal times, improving bioavailability and absorption. Vitamin accessibility and global collaborations. Addressing global vitamin deficiencies requires international cooperation, innovative food systems, and broad-scale public health initiatives to ensure that all populations have equitable access to essential nutrients. Global collaborative efforts to combat vitamin deficiencies. Partnerships between governments and NGOs, governments, international organizations, and non-governmental organizations, NGOs, can work together to implement large-scale nutrient supplementation programs, such as providing vitamin A, iron, and folate to vulnerable populations, especially in developing countries. Initiatives like the Global Alliance for Improved Nutrition, GAIN, and the World Health Organization, WHO, support fortification efforts and help distribute supplements in areas facing nutrient poverty. Public-private partnerships, collaborative projects between the public sector and private companies in the food industry could lead to large-scale biofortification and food fortification efforts, fortifying staple foods like rice, corn, and wheat with essential vitamins and minerals can address widespread nutrient deficiencies in communities with limited access to diverse diets. Global food systems and sustainability. Sustainable agriculture and biofortified crops. As the world's population grows, the demand for nutritious and sustainable food increases. Biofortified crops, such as golden rice, enriched with vitamin A and iron-rich beans, hold the potential to feed millions of people with improved nutrient content without the need for external supplements. This could help provide long-term, sustainable solutions to vitamin deficiencies. Climate change and food security. climate change poses a significant threat to global food security, affecting crop yields and the availability of key nutrients. Adapting agricultural practices to ensure that crops retain or even increase their vitamin content under changing environmental conditions will be critical. Researchers are looking at ways to create climate-resilient crops that are rich in vitamins to ensure food security in a changing world. Emerging technological innovations to address vitamin deficiencies. Technology is increasingly being applied to create innovative solutions that ensure vitamins are delivered more efficiently and equitably to populations in need. Nanoencapsulation for improved vitamin absorption. Nanoencapsulation refers to the process of enclosing nutrients, including vitamins, within tiny particles, known as nanoparticles, to enhance their absorption in the body. This technology is particularly beneficial for fat-soluble vitamins, like vitamin A, D, E, and K, that require fat to be absorbed. Nanoparticles can help deliver these nutrients more effectively and ensure that they reach the cells where they are most needed. Nutrient delivery systems. Nanoencapsulation technology can also be used to develop micronutrient supplements that are more easily absorbed by the body. These supplements could target specific tissues, organs, or systems, improving the bioavailability of vitamins and other nutrients, particularly for individuals with digestive issues or metabolic conditions that impair nutrient absorption. 3D printing for personalized nutrition. Custom nutrient supplements. The rise of 3D printing technology is making it possible to create personalized nutrient supplements tailored to an individual's specific needs. By using data from genetic tests, blood tests, or nutrient assessments, 3D printers can create customized pills or food items that contain precise amounts of vitamins and other nutrients. This could be especially helpful for people with specific health conditions or dietary restrictions. Personalized fortified foods. In addition to supplements, 3D printing could also be used to create personalized fortified foods that meet an individual's specific nutrient needs. By printing nutrient-dense food items, such as vitamin-enriched snacks or meal replacements, this technology could make vitamins more accessible in a way that aligns with personal preferences and dietary restrictions. Education and public health campaigns. Raising awareness about the importance of vitamins and how they contribute to overall health is vital for addressing global deficiencies. With modern tools and global reach, educational campaigns are more effective than ever. Digital campaigns for vitamin awareness. Social media and influencer partnerships. Social media platforms have become powerful tools for spreading information about nutritional health. Partnering with health influencers, nutritionists, and celebrities can help spread awareness about the importance of vitamins. These campaigns can promote the benefits of eating a variety of vitamin-rich foods, as well as highlight the risks of deficiencies. Virtual health consultations. Through telemedicine and virtual consultations, people in underserved areas can receive personalized dietary advice, vitamin supplementation recommendations, and access to healthcare professionals who can address specific nutrient deficiencies. This technology can bridge the gap in healthcare access, especially in remote and low-resource settings. School programs and nutritional education. Vitamin education in schools. Early education about healthy eating and the importance of vitamins can make a lasting impact on children's health. School programs can include lessons about vitamin-rich foods, the importance of balanced diets, and how to identify signs of vitamin deficiencies. Introducing healthy eating habits in childhood can encourage lifelong habits that reduce the risk of diet-related diseases later in life. School lunch programs and fortified foods. School feeding programs could expand to include fortified foods or provide vitamin supplements to ensure children are getting the nutrients they need for growth and development. Fortifying foods in school lunch programs is a cost-effective way to combat vitamin deficiencies in younger populations. Conclusion. A future of wellness powered by vitamins. The future of vitamins promises a convergence of scientific innovation, technological advancements, and global health collaborations that will transform how we approach nutrition. From personalized nutrition based on genetic data to global public health initiatives designed to address vitamin deficiencies, the potential to improve health outcomes on a global scale is vast. By focusing on sustainable food systems, biofortification, and advanced nutrient delivery technologies, the world can tackle widespread deficiencies and ensure that every individual has access to the essential vitamins that promote health and well-being. Whether through AI-powered health apps, biofortified crops, or global supplementation programs, vitamins will continue to play a crucial role in shaping a healthier future for generations to come. The role of vitamins in healthy aging. As populations worldwide age, maintaining optimal health through vitamin supplementation becomes increasingly important. Aging is often associated with declines in nutrient absorption, and several vitamins play a key role in supporting the health of older adults. Vitamin D and bone health. Osteoporosis prevention. As people age, they are at a higher risk of bone fractures and osteoporosis due to decreased bone mineral density. Vitamin D is essential for the absorption of calcium, which is crucial for bone health. In fact, vitamin D deficiency in older adults is a significant risk factor for fractures and falls. Ensuring sufficient vitamin D levels, either through sunlight, diet, or supplementation, is critical for maintaining bone strength and reducing the risk of fractures. Improved muscle function. Beyond bone health, vitamin D plays an essential role in muscle function. Older adults who are vitamin D deficient may experience muscle weakness and a higher risk of falls. Research suggests that maintaining optimal vitamin D levels can improve muscle strength and balance, preventing the loss of mobility in aging populations. Vitamin B12 and cognitive function. Prevention of cognitive decline. Vitamin B12 is vital for maintaining cognitive health, especially in older adults. A deficiency in B12 has been linked to memory loss, confusion, and in severe cases, dementia and Alzheimer's disease. As the ability to absorb B12 decreases with age, supplementation becomes crucial for maintaining brain health and preventing neurological decline. Protecting nerve health. Vitamin B12 is also essential for the maintenance of nerves and red blood cells. Older adults are at higher risk of neurological damage due to B12 deficiencies, so supplementation can prevent peripheral neuropathy, nerve damage, and other cognitive impairments. Vitamin C and skin health. Skin aging. Vitamin C is a powerful antioxidant that helps protect skin from damage caused by UV rays and environmental pollutants. As we age, our skin becomes more vulnerable to wrinkles, loss of elasticity, and dryness. Vitamin C plays an important role in the production of collagen, a protein that helps keep the skin firm and youthful. Regular intake of vitamin C can help prevent premature aging of the skin and maintain a healthy glow. Wound healing. Older adults often experience slower wound healing, and vitamin C is essential for the proper repair of tissues. Adequate vitamin C intake can speed up recovery from injuries and surgical procedures by enhancing collagen synthesis. Advances in vitamin supplementation and delivery systems. As vitamin research continues to evolve, new delivery systems and innovative supplementation methods are being developed to enhance the bioavailability and effectiveness of vitamins. Liposomes and micronutrient delivery. Liposomal supplements. One of the most promising advancements in vitamin supplementation is the use of liposomal delivery systems. Liposomes are tiny spherical vesicles made of lipid, fat, membranes, and they can encapsulate vitamins, improving their absorption and bioavailability. Liposomal formulations are particularly useful for vitamin C, vitamin D, and vitamin B12, as they help protect these nutrients from degradation in the digestive system and allow for better cellular uptake. Enhanced absorption. The liposomal encapsulation ensures that vitamins pass through the digestive tract more efficiently, meaning they can reach the bloodstream and tissues in higher concentrations. This method holds promise for individuals with digestive issues or poor absorption of nutrients, making supplementation more effective. Microencapsulation for long-lasting release. Extended release supplements. Another advancement is microencapsulation, where vitamins are enclosed in tiny capsules that dissolve slowly over time, providing a controlled release of the nutrient. This ensures that the body receives a steady supply of vitamins throughout the day rather than a quick burst. It can be particularly useful for vitamins like B12, which are needed regularly for energy production, or vitamin C, which is often lost quickly through urine if taken in large doses. Targeted delivery. Microencapsulation can also be used for targeted delivery to specific tissues or organs, such as vitamin D targeted to bone tissue for better absorption. This could revolutionize personalized nutrition, providing nutrients in the most effective forms and in the exact amounts needed for individual health conditions. Nutraceuticals and functional foods. Vitamins in functional foods. The concept of nutraceuticals, food-derived supplements, is rapidly growing, especially for the elderly population. Nutraceuticals are foods that provide medicinal or therapeutic benefits, and they can be fortified with vitamins and minerals to meet specific health needs. For example, vitamin-fortified beverages, such as vitamin D-enhanced milk or B12-rich energy drinks, provide an easy way for individuals to increase their vitamin intake without needing additional pills. Bioavailability enhanced foods. Advances in food technology also include enhancing the bioavailability of vitamins in everyday foods. For example, certain processing techniques may increase the absorption of vitamin D in fortified grains, or improve the iron content in vegetarian products to meet the needs of non-meat eaters. This technology ensures that even individuals with restricted diets can access essential nutrients. The role of vitamin research in public health policy. Research into vitamin deficiencies and micronutrient supplementation is essential for informing public health policy and improving global health outcomes. As our understanding of vitamins evolves, so too does the need for robust policy changes to ensure nutrient accessibility. Nutrient recommendations and public health guidelines. Refining dietary guidelines. National health organizations, such as the FDA, U.S. Food and Drug Administration, and the EFSA, European Food Safety Authority, continuously update dietary guidelines based on emerging research on vitamin requirements. This includes recommendations for daily intake of key vitamins like vitamin A, vitamin C, vitamin D, and vitamin B12, adjusted for factors like age, gender, activity level, and health conditions. Targeted public health programs. Governments and organizations like the World Health Organization, WHO, use data from vitamin research to target specific deficiencies in vulnerable populations. This might include pregnant women, children, or people living in areas with low access to fresh produce. Vitamin supplementation programs aimed at these groups can prevent birth defects, from folate deficiency, and malnutrition in children, and improve maternal health. Global vitamin supplementation initiatives. Fortification programs. The success of food fortification, such as the fortification of salt with iodine or flour with folic acid, has led to ongoing efforts to address deficiencies globally. Governments in many countries are focusing on fortifying staple foods, e.g., rice, wheat flour, and cooking oils, with vitamins and minerals. Such strategies can help combat widespread deficiencies, especially in developing countries. Vitamin A supplementation in low-income countries. Vitamin A deficiency remains a significant health concern in low-income countries, particularly in sub-Saharan Africa and South Asia. Global health organizations like UNICEF and WHO have led massive efforts to distribute vitamin A supplements to children and pregnant women in areas where deficiency is widespread, dramatically improving child survival rates and reducing maternal mortality. Policy challenges and solutions for global vitamin access. Addressing economic barriers. One of the significant challenges in ensuring global access to vitamins is economic inequality. Even though fortified foods and supplements are widely available in high-income countries, many individuals in low-income regions may lack the financial means to purchase supplements. Strategies to address this issue include government subsidies, community-based programs, and international aid focused on ensuring that the most vulnerable populations have access to vitamins. Public education campaigns. Public health policies must not only focus on the availability of vitamins but also on educating communities about healthy eating habits and the importance of micronutrients. Public awareness campaigns that explain the role of vitamins in maintaining good health can encourage populations to seek out more nutrient-dense foods and understand the impact of deficiencies. Conclusion: the expanding horizons of vitamin health. The future of vitamin health is exciting. With rapid advancements in science, technology, and global health strategies. From personalized supplementation based on genetics and AI to global vitamin fortification programs that address deficiencies, the possibilities for improving public health are vast. As vitamin science continues to evolve, it will be essential to combine innovative supplementation technologies, tailored health interventions, and global collaborations to ensure that people of all ages, from children to the elderly, have access to the nutrients they need to lead healthy, active, and fulfilling lives. By focusing on the most vulnerable populations, improving vitamin delivery systems, and expanding educational efforts, we can create a future where optimal nutrition is within reach for all. Emerging research on the role of vitamins in chronic diseases. As we continue to delve into the intricate roles of vitamins in the body, research is increasingly revealing how certain vitamins can prevent or mitigate chronic diseases. Understanding the specific role of vitamins in conditions like heart disease, diabetes, and cancer could transform prevention and treatment strategies. Vitamin D and cardiovascular health. Protecting the heart. Studies have shown that vitamin D deficiency may be linked to a higher risk of cardiovascular disease, including heart attacks and stroke. Vitamin D helps regulate calcium and phosphorus levels, which are crucial for vascular function. Low levels of vitamin D are associated with an increased risk of high blood pressure, heart disease, and inflammation in the body. Preventing heart disease. Ensuring adequate vitamin D levels, particularly through supplements or sun exposure, could become an essential part of cardiovascular disease prevention. As research on this topic advances, more effective strategies for preventing heart disease using vitamin D supplementation could be developed. B vitamins and diabetes. Regulating blood sugar. Vitamins from the B complex group, particularly B1, thiamine, B6, pyridoxine, and B12, have been shown to play critical roles in insulin resistance and glucose metabolism. Studies suggest that deficiency in these vitamins may worsen blood sugar control in individuals with type 2 diabetes. B vitamin supplementation. Research into B vitamins' role in diabetes management is evolving. Some studies suggest that B vitamin supplementation may help reduce nerve damage, a common complication of diabetes, and improve glucose regulation. As a result, public health strategies may increasingly focus on incorporating B vitamins into diabetic care protocols. Vitamin E and cancer prevention. Antioxidant properties. Vitamin E, a potent antioxidant, has long been studied for its potential in cancer prevention. Antioxidants protect the body from free radical damage, which can lead to the development of cancerous cells. Though the evidence is mixed, some studies suggest that vitamin E supplementation might help prevent certain types of cancer, including breast and prostate cancer. Cancer treatment. Ongoing research is examining whether vitamin E could play a role in reducing side effects from chemotherapy and radiation. Its antioxidant effects could help mitigate the damage to healthy cells during cancer treatment, improving patients' quality of life during recovery. The role of vitamin research in global public health initiatives. Global nutrition strategies are continuously evolving to address vitamin deficiencies and their health impacts, especially in low-income and underserved populations. Vitamins have a crucial role in these global health initiatives, improving overall health and economic stability. Vitamin A and global health. Combating malnutrition in children. Vitamin A deficiency remains one of the leading causes of preventable blindness in children, particularly in developing countries. In these areas, Vitamin A supplementation has proven to be an effective intervention for improving immune function and reducing child mortality rates. Expanded supplementation programs. Organizations like WHO and UNICEF have long promoted vitamin A supplementation to children under the age of 5. The success of these initiatives has significantly reduced childhood blindness and improved survival rates in high-risk regions. Future research could provide more refined strategies for targeting vitamin A supplementation to the most vulnerable groups. Global vitamin D deficiency. Addressing vitamin D shortages, one of the biggest health concerns in the global landscape is vitamin D deficiency. It's estimated that 1 billion people worldwide suffer from insufficient levels of vitamin D. This is particularly evident in regions with limited sunlight exposure or populations with darker skin tones who have a reduced ability to synthesize vitamin D from sunlight. Vitamin D fortification. Many countries have implemented fortification programs to combat vitamin D deficiency by adding it to staple foods like milk, cereals, and orange juice. However, more research is needed to determine the optimal levels of vitamin D in the population and how fortification programs can be tailored to specific regional needs. Iron deficiency and public health policy. Iron deficiency anemia. Iron deficiency is the most common micronutrient deficiency worldwide, especially in women of childbearing age and young children. Iron is essential for the production of hemoglobin, which carries oxygen throughout the body. Anemia can result in fatigue, compromised immune function, and developmental delays in children. Iron supplementation in pregnancy. Pregnant women are particularly at risk of iron deficiency anemia, which can lead to preterm births, low birth weights, and developmental complications. Global health organizations are working to expand iron supplementation programs for pregnant women to prevent anemia-related complications and improve maternal and fetal health. Technological innovations in vitamin synthesis and bioavailability. Advances in biotechnology and nanotechnology have allowed for new, more efficient ways to produce vitamins, improve their bioavailability, and ensure proper absorption in the human body. Sustainable vitamin production. Bioengineering for vitamin synthesis. Biotechnology has made it possible to produce vitamins in sustainable and eco-friendly ways. For example, genetically engineered microorganisms can be used to produce vitamin B12 and other micronutrients on a large scale, without the need for animal-based sources or synthetic chemical processes. Alternative sources of vitamin D. Given the importance of vitamin D in the global health context, researchers are investigating sustainable methods to produce vitamin D from non-animal sources. One promising development involves using yeast and fungi to produce vitamin D, offering a plant-based alternative for those with dietary restrictions or ethical concerns regarding animal-based products. Smart supplement delivery systems. Microneedles and transdermal systems. One exciting frontier in supplementation technology is the use of microneedles or transdermal delivery systems. These allow for the direct delivery of vitamins through the skin, bypassing the digestive system. This could be particularly beneficial for individuals with gastrointestinal disorders that impair nutrient absorption, such as Crohn's disease or celiac disease. Wearable micronutrient patches. In the future, wearable patches may become a viable method of delivering essential vitamins. These patches would release nutrients gradually, allowing for continuous absorption throughout the day, ensuring consistent vitamin intake without requiring pills or complex supplementation routines. Vitamin and mineral-infused personalized beverages. Customizable nutrient drinks. With the rise of personalized health, innovative companies are developing vitamin-infused beverages tailored to individual nutritional needs. These drinks are designed to provide specific vitamins and minerals based on personal health data, genetic makeup, and lifestyle factors. This trend could revolutionize how we consume vitamins, making it easier to integrate nutrients into our daily routines. The social and economic impacts of vitamin health. Ensuring proper vitamin intake has profound social and economic benefits, from improved productivity to reduced healthcare costs. Economic benefits of preventing vitamin deficiencies. Boosting productivity. adequate vitamin intake is linked to improved cognitive function, higher energy levels, and better physical performance, all of which contribute to increased work productivity. Populations with proper access to essential vitamins tend to have lower rates of absenteeism and early retirement, which in turn benefits the economy. Reducing healthcare costs. Vitamin deficiencies can lead to chronic diseases such as diabetes, heart disease, and osteoporosis, which are costly to treat. By preventing these diseases through proper nutrition, countries can reduce the burden on their healthcare systems and improve public health outcomes. Vitamin supplementation programs can be a cost-effective way to ensure a healthier, more productive population. Vitamin education and societal health. Public awareness campaigns. Education about the importance of vitamins in nutrient-dense foods can create societal changes that encourage healthier lifestyles. Governments, nonprofit organizations, and healthcare providers can use a variety of media platforms, including social media, to raise awareness about vitamin-rich diets and how to prevent deficiencies. School nutrition programs, early childhood education programs that focus on the importance of vitamins and healthy eating habits can have a lasting impact. By fostering an understanding of the role of vitamins from a young age, society can build a culture of preventive health that ensures long-term well-being. Conclusion: a brighter future with optimal vitamin health. The future of vitamins is incredibly promising. As we move toward personalized nutrition, advanced supplementation technologies, and global efforts to combat deficiencies, research into the preventive benefits of vitamins is opening doors to new treatments for chronic diseases, while innovative delivery systems make it easier to achieve nutrient adequacy for everyone. Continued collaboration between scientists, healthcare providers, and global health organizations will be key in addressing vitamin deficiencies and promoting optimal vitamin health. As we enhance our understanding of vitamins and their roles in human health, we pave the way for healthier populations, improved public health outcomes, and a more sustainable and efficient approach to global nutrition. Future research trends, exploring vitamin synergies and interactions. While much has been understood about individual vitamins, there is increasing interest in how different vitamins interact with one another and synergize to improve health outcomes. This kind of systems approach is critical for personalized nutrition and for tackling complex health conditions. Vitamin and mineral interactions. Vitamins don't work in isolation, they often interact with minerals and other nutrients to maintain bodily functions. For example, some key interactions include vitamin D and calcium. Vitamin D is essential for the absorption of calcium in the gut. Without sufficient vitamin D, the body cannot adequately absorb calcium, which could affect bone density and lead to conditions like osteoporosis. Supplementing with calcium without ensuring proper vitamin D levels might not provide the desired effects on bone health. Vitamin B12 and folate. Both vitamin B12 and folate are critical for the formation of red blood cells and the functioning of the nervous system. They work together to convert homocysteine, an amino acid, into methionine, an essential building block for proteins. A deficiency in either vitamin can lead to anemia and neurological issues. Vitamin C and iron. Vitamin C enhances the absorption of non-heme iron, the form of iron found in plant-based foods. People who are iron deficient, especially vegetarians or those with dietary restrictions, can benefit from vitamin C-rich foods like citrus fruits, which increase the bioavailability of iron. Research into these interactions helps develop more effective supplementation protocols for people suffering from nutrient deficiencies and ensures that nutrient combinations are tailored to individual needs. Vitamin toxicity. When more is not better. While vitamins are essential for health, taking them in excessive amounts can lead to toxicity, a serious health concern. With the growing popularity of vitamin supplements, it's crucial to understand the safe limits for each vitamin. Fat-soluble vitamins. Risk of overdose. Fat-soluble vitamins, A, D, E, and K, can accumulate in the body's fat stores and liver, making toxicity more likely when consumed in large amounts. Over time, this can lead to serious health complications, such as Vitamin A toxicity. Chronic vitamin A toxicity can result in symptoms like headaches, nausea, and liver damage. Pregnant women are particularly at risk because excessive vitamin A can harm the developing fetus. Vitamin D toxicity. Too much vitamin D can cause hypercalcemia, elevated levels of calcium in the blood, which can damage the kidneys, heart, and bones. High levels of vitamin D can be especially dangerous in individuals with pre-existing kidney conditions. Vitamin E toxicity. While vitamin E is an antioxidant, excessive amounts can impair blood clotting, leading to bleeding disorders. The potential for interactions with other medications, like blood thinners, makes it essential to monitor intake carefully. Water-soluble vitamins, less likely to cause toxicity. Water-soluble vitamins, C and the B vitamins, are typically excreted in the urine if consumed in excess, which reduces the risk of toxicity. However, very high doses of certain water-soluble vitamins can still cause adverse effects. Vitamin C overdose. Taking excessive vitamin C can lead to gastrointestinal distress, such as diarrhea and stomach cramps. In rare cases, it can cause kidney stones due to the high levels of oxalate. Vitamin B6 toxicity. Chronic high doses of vitamin B6 can lead to nerve damage, causing symptoms such as numbness and tingling in the hands and feet. In general, moderation and adhering to recommended daily allowances, RDAs, are key to avoiding vitamin toxicity. For individuals taking supplements, it's crucial to consult healthcare professionals to ensure that vitamin intake is safe and balanced. Sustainable vitamin production, revolutionizing the industry. As the global demand for vitamins increases, there is a growing emphasis on sustainable production methods to meet the demand without negatively impacting the environment. Plant-based sources of vitamins. The traditional sources of vitamins, especially fat-soluble vitamins like vitamin A, D, and E, often rely on animal products or synthetic chemicals. However, there's a shift toward plant-based sources and biotechnological advancements that provide more sustainable and ethical alternatives. Vitamin D. While vitamin D is often derived from lanolin, sheep's wool, there are growing efforts to produce vegan-friendly vitamin D from lichen or through biotechnology, using yeast or fungi to synthesize vitamin D2 or D3. Vitamin A. Beta-carotene, a precursor of vitamin A, is found abundantly in orange and green vegetables, and it can be extracted in a way that does not rely on animal products. This offers a more sustainable and plant-based alternative to retinol, animal-derived vitamin A. Fermentation and microbial synthesis. Fermentation is an environmentally friendly method of producing vitamins. Using microorganisms, such as bacteria, yeast, and fungi, nutrients like vitamin B12 can be synthesized in controlled environments, reducing reliance on animal-based products and chemical synthesis. Vitamin B12. The primary source of B12 for vegetarians and vegans has been through microbial fermentation, where bacteria produce vitamin B12. This process reduces the environmental impact compared to traditional animal-based sources like meat and dairy. Sustainable vitamin C. Traditionally, vitamin C was extracted from citrus fruits, but now advancements in biotechnology have enabled microbial fermentation to produce vitamin C more efficiently, reducing carbon emissions associated with growing and harvesting crops. Circular economy and vitamin production. A circular economy focuses on reducing waste and reusing resources to create a more sustainable, regenerative system. The vitamin industry can benefit from this approach by using waste products from food production or agriculture to create nutrients. Upcycling agricultural waste, for example, by using food scraps from fruit or vegetable processing, like peels and seeds, to extract vitamins. Companies can reduce food waste while also providing essential nutrients. This helps lower environmental impact and promotes a more sustainable, closed-loop supply chain. The future of personalized vitamin supplementation. With the rapid advancement in genetic research and personalized medicine, the future of vitamin supplementation is headed toward a customized approach. where individuals receive tailored vitamin regimens based on their genetic profiles, health conditions, and lifestyle. Genetic testing and vitamin needs. Research into nutrigenomics. The study of how genes influence the body's response to food and nutrients is providing the basis for personalized nutrition. Through genetic testing, it will be possible to determine which vitamins and minerals an individual may be genetically predisposed to needing more of, and which ones they may absorb more efficiently. Genetic predisposition and vitamin deficiencies. Some individuals may have genetic variants that affect how they process and utilize certain vitamins, such as vitamin D or folate. For example, people with specific variants of the MTHFR gene may have a reduced ability to metabolize folate, requiring higher levels of supplementation. Tailored supplementation plans. Personalized vitamin plans could become more common in the future. By analyzing genetic data, lifestyle habits, and environmental factors, healthcare providers could create personalized vitamin regimens that target an individual's specific nutritional needs. Wearable health technology for real-time monitoring. In the future, wearable devices may be used to monitor an individual's nutritional status in real time, allowing for the instant adjustment of vitamin supplementation based on changes in nutrient levels. For example, a smart patch could measure levels of vitamin D in the body, adjusting vitamin D release throughout the day based on exposure to sunlight or other factors. Continuous nutrient monitoring. Devices that track nutrient levels and biomarkers could provide individuals with personalized recommendations for dietary adjustments or vitamin supplementation in real time. This could lead to a more dynamic approach to nutrition, ensuring that vitamins are always at the optimal levels needed for health. Conclusion: a dynamic and sustainable future for vitamin health. The future of vitamin science and supplementation is incredibly promising, driven by cutting-edge research and innovative technologies. From personalized nutrition based on genetic profiles to sustainable production methods that reduce environmental impact, the vitamin industry is evolving to meet the needs of both individual consumers and global populations. As we move forward, it will be crucial to ensure accessibility, education, and sustainability in vitamin health, ensuring that everyone can achieve optimal health without harming the planet. The potential for improved health outcomes, reduced healthcare costs, and a more equitable approach to nutrition offers a hopeful vision for the future. Enhancing vitamin bioavailability, maximizing nutrient absorption. A key challenge in the field of vitamins is ensuring that nutrients are effectively absorbed and utilized by the body. Advances in bioavailability, the degree to which nutrients are absorbed and utilized, will significantly impact how vitamins are delivered, both in food and in supplements. Nanotechnology in vitamin delivery. Nanoparticles. Nanotechnology has been making strides in medicine and nutrition by creating nano-sized particles that can carry vitamins and other nutrients directly to cells, enhancing their absorption. By using liposomes, small lipid-based spheres, nutrients are shielded from digestive enzymes, allowing for more efficient delivery to target organs and tissues. Nanoencapsulation. Encapsulating vitamins in nano-sized particles or microparticles can increase their stability and absorption. For instance, vitamin C, a water-soluble nutrient that can degrade quickly when exposed to air, can be protected in a nano-encapsulated form, ensuring that it remains active and effective when ingested. Synergistic combinations for better absorption. Vitamin and mineral synergies to enhance absorption. Certain vitamins are often taken in combination with others. For example, vitamin C can enhance the absorption of iron from plant-based sources. Similarly, magnesium plays an essential role in the activation of vitamin D, making it crucial to ensure balanced intake of these nutrients together for optimal absorption. Optimizing dosage and timing. Personalized supplementation programs are expected to focus not just on which vitamins to take, but also on when and how they should be consumed. For instance, fat-soluble vitamins, A, D, E, and K, are best absorbed when taken with fat-containing meals. while water-soluble vitamins like B12 may be better absorbed when taken separately or at specific times during the day. Addressing global vitamin deficiency challenges. Despite significant advances in vitamin research and public health interventions, vitamin deficiencies remain a global concern. Several challenges persist, especially in low-income countries, where access to nutritious food and healthcare resources is limited. Vitamin A deficiency and blindness. A global health issue, vitamin A deficiency is the leading cause of preventable blindness in children, particularly in sub-Saharan Africa and Southeast Asia. Children with insufficient vitamin A have weakened immune systems, making them more vulnerable to infections and malnutrition. Vitamin A fortification programs, vitamin A fortification efforts, which add vitamin A to commonly consumed foods like rice, oil, and sugar, are a critical strategy in fighting deficiency in developing regions. The biofortification of staple crops, such as golden rice, enriched with beta-carotene, is another innovative solution to help communities suffering from vitamin A deficiency. Iron deficiency and anemia. Anemia in women and children. Iron deficiency is the most prevalent micronutrient deficiency globally, particularly affecting women of reproductive age and young children. Anemia can lead to fatigue, impaired cognitive development, and compromised immune function. Fortification and supplementation. Iron fortification programs, such as adding iron to flour, salt, or rice, have been successful in improving iron status in countries with high deficiency rates. Additionally, iron supplementation programs, particularly for pregnant women, are crucial to prevent low birth weight and maternal mortality. Vitamin D deficiency and bone health. Global epidemic. Vitamin D deficiency is increasingly recognized as a widespread issue worldwide, particularly in regions with limited sunlight exposure, such as in northern latitudes. This deficiency contributes to a higher risk of osteoporosis, muscle weakness, and autoimmune diseases. Public health strategies. Efforts to increase vitamin D levels have included fortification of milk and other dairy products, vitamin D supplementation, and the promotion of sun exposure as a natural source of vitamin D. However, more research is needed to understand the optimal vitamin D levels for different populations and the impact of various fortification strategies. The role of vitamins in longevity and aging. Research into the role of vitamins in promoting longevity and combating the effects of aging is an emerging area of interest. As the global population continues to age, there is a growing need to understand how vitamins can improve quality of life and extend healthy lifespan. Vitamin D and aging. Bone health and mobility. Vitamin D is essential for bone health, and adequate levels may help prevent osteoporosis and fractures in older adults. It also plays a role in maintaining muscle strength and balance, which are important for reducing the risk of falls in the elderly. Immune function. Vitamin D has been shown to play a critical role in regulating the immune system. Low levels of vitamin D are associated with an increased risk of autoimmune diseases, infections, and possibly age-related diseases like Alzheimer's disease. Antioxidant vitamins and cellular aging. Vitamin C and vitamin E. Both vitamin C and vitamin E are powerful antioxidants that help protect the body from oxidative stress and free radical damage, which are believed to contribute to the aging process. These vitamins may also help improve skin health, reduce the appearance of wrinkles, and maintain cellular integrity as we age. Anti-inflammatory properties. Chronic low-grade inflammation, or inflammaging, is linked to many age-related conditions. Some vitamins, such as vitamin D and omega-3 fatty acids, may have anti-inflammatory effects that help prevent the progression of chronic diseases associated with aging. Vitamin B12 and cognitive health. Memory and brain function. Vitamin B12 is essential for cognitive function in the nervous system. A deficiency in B12 can lead to memory loss, confusion, and even dementia in elderly individuals. Ensuring adequate vitamin B12 intake may help maintain brain health and reduce the risk of cognitive decline as people age. Cognitive decline prevention. Ongoing research into nutrient-dense diets and supplementation has shown that a Diet rich in B vitamins, particularly B12 and folate, may help delay the onset of Alzheimer's disease and reduce the risk of cognitive impairment in aging populations. Holistic approaches to health, integrating vitamins into wellness strategies. Vitamins are just one part of the broader health equation. Future healthcare trends are leaning toward a holistic approach to wellness, incorporating vitamins as part of lifestyle interventions that include diet, exercise, mental health, and stress management, nutritional therapy, and personalized medicine. Lifestyle interventions, personalized nutrition, based on genetic testing and lifestyle data, is at the forefront of health optimization. By understanding an individual's nutritional needs, healthcare providers can recommend targeted vitamin supplementation alongside other lifestyle changes like diet modifications, physical activity, and mental wellness practices, integrating vitamins with fitness, as fitness and nutrition become more intertwined. Athletes and active individuals are increasingly turning to vitamin supplementation to boost performance and recovery. Vitamin D, for example, has been shown to improve muscle function, while B vitamins are essential for energy production. Mental health and vitamin deficiencies. Mental well-being. The connection between mental health and nutrition is becoming more recognized. Vitamins like B12, vitamin D, and omega-3 fatty acids have been linked to mood regulation and the prevention of mental health disorders such as depression and anxiety. Mind-body connection, stress management, and mindfulness practices, in combination with adequate vitamin intake, can have a profound impact on overall well-being. Vitamins such as C and B complex play key roles in reducing stress and maintaining mental clarity. The future, toward a holistic, sustainable, and personalized vitamin approach. The future of vitamin science is incredibly promising, with a deeper focus on sustainable production, personalized health solutions, and the integration of vitamins into broader health strategies. Advances in bioavailability, nanotechnology, and personalized supplementation will ensure that individuals can optimize their vitamin intake to improve quality of life and longevity. At the same time, global health initiatives continue to address challenges related to vitamin deficiencies, ensuring that everyone has access to the micronutrients they need for good health. By combining cutting-edge science with holistic health approaches, the future of vitamins promises a healthier, more sustainable, and more equitable world. Emerging trends in vitamin research and application. The field of vitamin research is continuously evolving, with new insights into how vitamins impact our bodies and how they can be utilized more effectively. Recent trends in vitamin research are focusing on new delivery methods, new roles for vitamins in disease prevention, and the application of precision medicine to optimize individual health. Vitamin K2, a growing focus in bone and cardiovascular health. New insights into vitamin K2, while vitamin K1, found in leafy green vegetables, is well known for its role in blood clotting. Vitamin K2, found in fermented foods like natto and certain animal products, is being increasingly recognized for its benefits in bone health and cardiovascular health. Vitamin K2 activates proteins like osteocalcin, which helps bind calcium to bones, and matrix GLA protein, which helps prevent calcium from accumulating in arteries. Bone and heart health. Recent studies have shown that adequate vitamin K2 intake can reduce the risk of bone fractures and improve bone density. Additionally, K2 may prevent arterial calcification, reducing the risk of heart disease. Its potential as a supplement for aging populations and bone health interventions is under investigation. Vitamin E, antioxidant powerhouse in skin health and disease prevention. Beyond antioxidant protection, vitamin E is widely known as an antioxidant that helps protect the body from oxidative damage. However, recent studies are uncovering its role in immune function, cell membrane stability, and the prevention of chronic diseases like cancer and neurodegenerative disorders. Vitamin E in skincare. Topical vitamin E is popular in skincare products for its anti-aging properties, but recent research suggests that it may also play a role in reducing skin inflammation and protecting the skin from UV radiation. There is potential for vitamin E to be used in treatments for skin conditions such as eczema and psoriasis. Vitamin and disease prevention, expanding roles. The roles of vitamins in disease prevention and health optimization are being explored in much more depth, particularly for conditions that are growing concerns in modern society. Vitamins are being examined for their potential to prevent or manage chronic diseases, inflammatory conditions, and autoimmune disorders. Vitamin D and chronic disease prevention. Cancer prevention. There is growing evidence suggesting that adequate vitamin D levels may help prevent various types of cancer, particularly breast, colon, and prostate cancer. Research shows that vitamin D plays a crucial role in cell growth regulation, apoptosis, programmed cell death, and the inhibition of cancer cell spread. While more research is needed, vitamin D supplementation may become an adjunctive treatment for cancer prevention. Heart disease. Research indicates that vitamin D deficiency is associated with an increased risk of cardiovascular diseases, including heart attack, stroke, and hypertension. Adequate vitamin D levels may help regulate blood pressure, reduce inflammation, and improve heart function, making it an important factor in heart disease prevention. Vitamin B12 and neurological health. Cognitive decline and Alzheimer's disease. Vitamin B12 plays an essential role in maintaining the health of the nervous system. Deficiency in B12 has been linked to memory loss, cognitive decline, and Alzheimer's disease. There is emerging evidence that suggests high-dose B12 supplementation may help prevent or slow the progression of neurodegenerative diseases by improving myelin sheath health and brain function. Mental health disorders. Vitamin B12 is essential for mood regulation, and deficiencies are commonly seen in people with depression, anxiety, and other mental health conditions. As the mental health crisis grows globally, vitamin B12 supplementation may emerge as part of a holistic approach to mental health care. Vitamin C and immune system modulation. Immune support. Vitamin C is essential for the proper functioning of the immune system. It enhances the production of white blood cells and supports the integrity of epithelial barriers, skin and mucous membranes. While vitamin C has long been recognized for its role in fighting colds and infections, newer research is investigating its role in reducing systemic inflammation and promoting immune system resilience. Fighting infections and chronic inflammation, vitamin C is being studied for its potential role in preventing or managing chronic conditions like autoimmune diseases, inflammatory disorders, and infection-related complications. Research has also suggested that vitamin C may have a therapeutic role in viral infections such as COVID-19 and respiratory illnesses. Precision nutrition. Tailoring vitamin intake to genetic profiles. Advances in genomics and personalized medicine are paving the way for precision nutrition, the science of tailoring nutrition, including vitamin supplementation, to an individual's genetic profile, microbiome, and lifestyle. Nutrigenomics. The intersection of genetics and vitamin needs. Genetic variants and vitamin metabolism. Nutrigenomics is a field that studies how an individual's genetic makeup affects the body's response to food, nutrients, and vitamins. For instance, certain genetic variants can influence how effectively a person metabolizes and absorbs specific vitamins, such as vitamin D or folate. Personalized supplementation. With genetic testing, people may soon be able to receive tailored vitamin recommendations that take into account their nutritional needs based on their DNA. This could help optimize health outcomes, prevent deficiencies, and reduce the risk of chronic conditions. Microbiome and vitamin production. Gut health and vitamin synthesis. The gut microbiome plays a significant role in vitamin synthesis. Beneficial gut bacteria help produce several vitamins, such as vitamin K2, biotin, and B vitamins. Understanding the intricate relationship between the microbiome and vitamin production could lead to strategies for improving gut health and enhancing nutrient absorption. Probiotics and vitamin bioavailability. Research is also looking into how probiotics and prebiotics, fibers that feed healthy gut bacteria, can influence vitamin absorption and enhance nutrient bioavailability. This emerging area could lead to innovative microbiome-based approaches to nutrition and health. Sustainable vitamin production, green innovations and biotechnology. The global demand for vitamins continues to rise, making it increasingly important to focus on sustainable production methods that minimize environmental impact and enhance accessibility. Green biotechnology, plant-based vitamin production, sustainable sourcing of vitamins, more. Vitamin manufacturers are turning to plant-based sources and biotechnological innovations to meet global demand. Plant-based sources of vitamins, such as vitamin D2 from fungi, vitamin A from algae, and vitamin C from plants, are being explored as eco-friendly alternatives to traditional sources. Fermentation and synthetic biology, fermentation technology, which uses microorganisms like yeast or bacteria, is being employed to produce large quantities of vitamins, including B vitamins and vitamin D. This method is not only sustainable but also cost-effective, and is expected to become increasingly popular in the coming years. Vitamins from waste, circular economy solutions, upcycling agricultural byproducts. The concept of a circular economy in the vitamin industry is gaining traction, instead of relying solely on traditional farming for raw materials. Food waste and agricultural byproducts, like fruit peels, seeds, and stems, are being repurposed to extract vitamins, providing a more sustainable and cost-effective solution, reducing environmental impact by utilizing waste materials. Companies are not only reducing food waste, but also cutting down on the environmental impact of vitamin production. This circular approach will likely become more prevalent as sustainability becomes a greater priority. The future of vitamin health, a comprehensive approach. The future of vitamins in human health is set to evolve along multiple fronts: scientific discoveries, personalized nutrition, sustainability in production, and global health initiatives. Whether it's improving chronic disease prevention, enhancing cognitive function, or understanding the intricate relationships between genetics and vitamin metabolism, the research is promising. As we harness new technologies, we will be better equipped to optimize human health across populations and regions. By integrating vitamin supplementation into broader healthcare strategies, with an emphasis on personalization and sustainability, we can move toward a future where optimal vitamin health is accessible, affordable, and more sustainable for everyone. Technological innovations in vitamin science. As technology advances, the way we study, deliver, and utilize vitamins is also evolving. The future will likely see significant breakthroughs in how we optimize vitamin intake, monitor deficiencies, and deliver vitamins more effectively. Wearable tech for monitoring vitamin levels. Real-time vitamin monitoring. Wearable devices, like smartwatches or biosensors, may be able to measure key health metrics, including vitamin levels, in real time. For example, technology could be developed to measure vitamin D or B12 levels in sweat, saliva, or blood through non-invasive sensors, offering individuals a personalized understanding of their nutritional status and potential deficiencies. Smart supplementation. These devices could also be integrated with apps that recommend personalized supplements based on real-time data, helping people optimize their nutrient intake. Artificial intelligence, AI, could play a key role in analyzing data and creating precise vitamin plans tailored to each individual's unique needs. Bioprinting and vitamin delivery. 3D bioprinting, the use of 3D printing technology to create personalized supplements could revolutionize vitamin delivery. Researchers are exploring bioprinting methods to create vitamin-enriched structures, e.g., capsules or tablets, that can release nutrients in a targeted way. This could allow for sustained or timed release of specific vitamins throughout the day. Smart delivery systems. In addition to traditional pills, new vitamin delivery methods could include microneedles or nanosystems designed to inject vitamins directly into the bloodstream or target specific organs. This could improve the bioavailability and efficiency of vitamins, especially for individuals with digestive absorption issues. The role of vitamins in chronic diseases and aging. As the global population ages and chronic diseases continue to rise, there is a growing focus on nutrient-based therapies. Vitamins play a significant role in preventing, managing, and treating various chronic diseases and age-related conditions. Vitamins for managing chronic inflammatory diseases. Vitamin D and inflammation. Inflammation is a key factor in the development of chronic diseases like arthritis, diabetes, heart disease, and autoimmune conditions. Vitamin D, with its anti-inflammatory properties, is increasingly being studied for its role in controlling chronic low-grade inflammation. Adequate vitamin D levels are linked to reducing the risk of conditions like rheumatoid arthritis, inflammatory bowel disease, IBD, and multiple sclerosis, MS. Vitamin E and chronic inflammation. Vitamin E is also a potent antioxidant and has demonstrated anti-inflammatory effects in studies related to diseases like cardiovascular disease, diabetes, and neurodegenerative diseases. Research is continuing into how vitamin E supplementation can help manage chronic inflammation, particularly in the elderly, whose inflammation levels tend to increase as they age. Vitamin A in skin health and anti-aging. Skin aging and protection. Vitamin A, particularly in the form of retinol or retinoids, is widely used in skincare products to reduce wrinkles, fine lines, and sun damage. Emerging research suggests that vitamin A may help regenerate skin cells, protect against UV radiation, and improve the appearance of aging skin by boosting collagen production. Retinoids in treating acne and skin conditions. Retinoids are also essential for managing acne, psoriasis, and other dermatological conditions. Research is being conducted to develop better formulations of vitamin A that provide effective treatment with minimal irritation. Vitamins and mental health, exploring their impact on mood and cognitive function. In recent years, there has been growing interest in how vitamins can influence mental health and cognitive function. Certain vitamins are believed to play a direct role in mood regulation, stress response, and brain health, especially as we age. B vitamins and mental health. B6, B9, folate, and B12. These B vitamins are essential for mood regulation and neurotransmitter function. Folate, B9, for example, is involved in the synthesis of serotonin, the neurotransmitter responsible for regulating mood. Adequate levels of B6 and B12 are essential for dopamine and norepinephrine production, which influence mood stability and cognitive function. Depression and vitamin B deficiency. Deficiencies in B vitamins, particularly B12, have been linked to depression, cognitive decline, and fatigue. Recent studies have focused on B vitamin supplementation as an adjunctive treatment for mood disorders and as a way to improve mental well-being. Vitamin D and cognitive function. Cognitive decline prevention. There is growing evidence that vitamin D plays a role in maintaining cognitive health as we age. Deficiencies in vitamin D have been linked to an increased risk of dementia and Alzheimer's disease. The vitamin is thought to support brain cell function, neuroplasticity, and the regulation of inflammation in the brain. Mood disorders. There is also mounting evidence that vitamin D can have a significant impact on mood and the prevention of depression. Some studies suggest that low vitamin D levels correlate with higher incidences of seasonal affective disorder, SAD, a condition that often occurs in the winter months when sunlight exposure is limited. Vitamins and global health, addressing nutritional gaps. Although vitamins are vital for health, millions of people around the world still suffer from micronutrient deficiencies. These deficiencies have serious health consequences, particularly in low-income regions where access to a diverse, nutrient-dense diet is limited. Global efforts to combat micronutrient deficiencies. Fortification programs. Global nutrition interventions, such as fortifying staple foods with vitamins, e.g., adding vitamin A to oil or vitamin D to milk, have been successful in reducing deficiencies in some parts of the world. These fortification programs are essential in developing countries where malnutrition remains a persistent issue. Biofortification, in addition to food fortification. Biofortification, genetically improving crops to increase their vitamin content, is an emerging solution to global nutritional deficiencies. For example, golden rice, which is enriched with beta-carotene, a precursor to vitamin A. Aims to combat vitamin A deficiency in regions where rice is a primary food source. Sustainable food systems for nutrient-dense diets. Diversified agricultural systems, ensuring access to a variety of nutrient-rich foods is critical for fighting global vitamin deficiencies. Programs that promote diverse crop cultivation and local food production can help address nutrient gaps by increasing access to foods rich in vitamins, like green leafy vegetables, fruits, and legumes. Reducing food waste. An additional strategy is reducing food waste, which often results in the loss of vitamin-rich foods. By improving food preservation and storage methods, we can reduce waste and ensure that nutrient-dense foods reach those who need them most. The future of vitamin research, precision medicine, and global health solutions. As we move toward a future of personalized nutrition and precision medicine, the role of vitamins in health optimization will continue to expand. The potential for genetic testing, biotechnology, and advanced delivery systems to improve vitamin intake and absorption could dramatically enhance health outcomes, prevent diseases, and reduce healthcare costs. Personalized vitamin therapy, with the help of genomics, microbiome studies, and AI technology. Vitamins can be delivered in a more targeted, efficient way, ensuring that individuals receive the optimal amount for their unique needs. Health equity and access. As research progresses, it will be crucial to ensure that the benefits of advanced vitamin science and nutrition are accessible to all, particularly in low-income and underdeveloped regions. This may require innovative, cost-effective solutions to ensure global health equity and access to essential nutrients. Conclusion. A brighter future for vitamin science. The future of vitamins looks incredibly promising. With breakthroughs in technology, personalized medicine, and global health initiatives. From advancing vitamin delivery systems to reducing the impact of micronutrient deficiencies worldwide, the potential for vitamins to shape human health is vast. By integrating sustainability, precision nutrition, and holistic health strategies, the future promises improved health outcomes for people everywhere. Whether it's in combating chronic diseases, enhancing cognitive function, or improving overall well-being, vitamins will continue to be a critical part of the health equation, helping us live longer, healthier lives. Vitamin delivery systems, the future of targeted nutrition. As vitamin science evolves, the methods of delivering vitamins to the body are becoming more sophisticated. These innovative delivery systems aim to improve efficiency, bioavailability, and user compliance. Let's explore some emerging technologies that could reshape how we supplement vitamins. Nanotechnology in vitamin supplements. Nanoencapsulation. Nanotechnology refers to the manipulation of matter at an atomic or molecular scale. In the context of vitamins, nanoencapsulation involves encasing vitamins in tiny particles, making them easier to absorb and protecting them from degradation during digestion. This approach can improve the bioavailability of vitamins that are typically hard to absorb, such as vitamin D or vitamin E. Targeted delivery. Nanoparticles can also be designed to target specific organs or tissues, allowing for more precise vitamin delivery. For instance, vitamin C could be delivered directly to immune cells during an infection, maximizing its effect. This could revolutionize how we use vitamins for therapeutic purposes, such as in chronic disease management or preventing nutrient deficiencies. Liposomes for enhanced absorption. Liposome encapsulation. Liposomes are microscopic lipid, fat, vesicles that can encapsulate vitamins or other nutrients, enhancing their stability and absorption. Vitamins such as vitamin C and vitamin D can benefit from this technology, as it helps deliver the vitamins through the digestive system and into the bloodstream more efficiently. Liposomes protect vitamins from being broken down prematurely by stomach acids, increasing their effectiveness. Sustained release formulas. Liposomal technology also enables the creation of slow-release formulas, where vitamins are gradually released into the bloodstream over time. This can provide more consistent vitamin levels in the body and potentially lead to fewer side effects compared to rapid absorption. Vitamins and the gut microbiome. Unlocking a new frontier. The gut microbiome is increasingly recognized for its critical role in health and disease. Research has shown that vitamins and gut bacteria are interconnected, and this relationship may hold the key to improving nutrient absorption, managing inflammatory diseases, and supporting mental health. Vitamins and gut health. Gut bacteria and vitamin production. The human gut is home to trillions of microbes that produce a variety of vitamins, particularly B vitamins, B2, B6, B12, folate, and vitamin K2. The gut microbiome influences how efficiently we absorb and metabolize vitamins from food. Research into the microbiome's role in vitamin production could lead to therapies or diets that optimize microbiome health, improving nutrient absorption and overall wellness. Probiotics and vitamin synthesis. Specific probiotic strains may be able to boost the production of certain vitamins, especially vitamin K2 and B vitamins. There's also evidence that certain probiotics can help enhance the bioavailability of vitamins like vitamin D and vitamin C, which could open the door for microbiome-based strategies to combat vitamin deficiencies. Gut dysbiosis and vitamin deficiencies. Dysbiosis, an imbalance of the gut microbiota, has been linked to a number of health issues, including vitamin deficiencies. For example, a disrupted microbiome may impair the synthesis of vitamin K2 or affect the absorption of fat-soluble vitamins like A and D. As scientists understand the complex relationship between the microbiome and vitamins, therapies designed to restore a healthy gut environment might play a role in treating nutritional deficiencies in chronic conditions. Vitamins in personalized and precision medicine. Personalized medicine is transforming how healthcare is delivered, rather than a one-size-fits-all approach. This concept involves tailoring healthcare treatments to individual characteristics, such as genetics, lifestyle, and environment. Vitamins will be increasingly integrated into precision medicine to help individuals achieve their optimal health. Genetics and vitamin requirements. Nutrigenomics is the study of how our genetic makeup influences our response to nutrients, including vitamins. Certain genetic variants may affect how individuals process, absorb, or metabolize vitamins. For example, some people have genetic mutations that make it harder for them to convert vitamin D into its active form. Others may have genetic predispositions that increase their needs for specific vitamins, like B12 or folate. Customized vitamin plans. Genetic testing could enable the development of personalized vitamin plans, optimizing intake for an individual's unique genetic profile. For example, people with a genetic predisposition to low folate levels may benefit from higher doses of folic acid, while individuals with a vitamin D receptor mutation may require tailored vitamin D supplementation. Microbiome-based personalized nutrition. As research into the gut microbiome deepens, it's becoming clear that our microbiota also influences how our bodies respond to vitamins. Personalized nutrition could involve gut microbiome testing to determine which vitamins are poorly absorbed or synthesized in an individual's system. Tailored supplementation strategies could help improve nutrient absorption and gut health. Vitamins and global health challenges. Addressing nutrient deficiencies. Despite advancements in global nutrition, vitamin deficiencies remain a major public health issue, especially in low-income regions. Many populations still suffer from a lack of essential vitamins, leading to severe health consequences such as blindness from vitamin A deficiency or birth defects from folate deficiency. Efforts to address these issues are evolving. Global vitamin A deficiency and blindness. Vitamin A deficiency is still widespread in many developing countries, especially among young children and pregnant women. It's a leading cause of preventable blindness and contributes to high child mortality rates. Governments and NGOs are working to address this issue through fortification programs, adding vitamin A to staple foods such as rice or sugar, and the provision of vitamin A supplements. Golden rice. One of the most innovative solutions is golden rice, which has been genetically modified to contain higher levels of beta-carotene, a precursor to vitamin A. This biofortified rice aims to combat vitamin A deficiency in regions where rice is a staple food. Folate deficiency and neural tube defects. Folate, vitamin B9, deficiency during pregnancy can lead to neural tube defects, including spina bifida. Many countries have implemented folic acid fortification programs to prevent these birth defects, and research continues to explore the benefits of biofortified crops and supplementation. Folate supplementation. Increasing folate intake before and during pregnancy has significantly reduced the incidence of neural tube defects. There is ongoing research into how better nutrient bioavailability can be achieved through new methods of fortification and supplementation. Vitamin D and immune support in low-income countries. Vitamin D deficiency remains a global health concern, particularly in regions with limited sun exposure or where traditional diets are low in vitamin D-rich foods like fatty fish or fortified dairy. It is associated with rickets in children and osteomalacia in adults. Public health initiatives. Countries are introducing vitamin D supplementation programs, particularly in schoolchildren or vulnerable populations, to combat deficiencies and boost immune function. There is also a push to include vitamin D fortification in widely consumed foods like milk, orange juice, and breakfast cereals. The future of vitamin research, integrating vitamins into holistic health approaches. As we look toward the future of vitamin science, it's clear that vitamins will play a central role in a holistic approach to human health, whether addressing chronic diseases, aging, or immune function. Vitamins are key to maintaining wellness across the lifespan. Preventative health. The focus will shift towards using vitamins not just to treat deficiencies but as preventative tools in promoting long-term health and wellness. By targeting specific health outcomes through tailored vitamin supplementation, we could potentially prevent a variety of age-related diseases and degenerative conditions. Collaboration across disciplines. The future of vitamin research will require collaboration between nutrition scientists, geneticists, microbiome researchers, and medical professionals. Together, they will explore new ways to enhance the efficacy and precision of vitamin-based health interventions. Conclusion. Vitamins for a healthier future. The future of vitamins in healthcare is incredibly exciting. With continuous advancements in technology, personalized medicine, and global health interventions. As we continue to unlock new ways to deliver, absorb, and optimize vitamins, their role in enhancing global health and well-being will only become more critical. With the right innovations, vitamins could become a cornerstone in preventing diseases, improving health outcomes, and ensuring a healthier future for individuals worldwide. Exploring the role of vitamins in disease prevention and treatment. As we learn more about how vitamins interact with biological pathways, we can unlock new ways to use them not just as preventive tools, but as therapeutic agents in managing various health conditions. These findings hold great promise for chronic disease management and longevity. Vitamins in cancer prevention and therapy. Antioxidant properties of vitamins. Certain vitamins, like vitamin C, vitamin E, and vitamin A, are known for their antioxidant properties, which help combat oxidative stress, an important factor in the development of cancer. Research continues to investigate how these vitamins may prevent cancer cell formation or slow cancer progression by supporting the body's natural defenses and repair mechanisms. Vitamin D and cancer risk. Some studies have linked adequate vitamin D levels with a reduced risk of colon, breast, and prostate cancers. Vitamin D helps regulate cell growth and differentiation, and new research is examining its role in cancer cell apoptosis, programmed cell death. Further studies may lead to vitamin D supplementation as an adjunct to cancer treatments. Targeted vitamin therapy. Researchers are also exploring vitamin-based therapies in combination with chemotherapy and radiotherapy to enhance treatment effectiveness. The idea is that certain vitamins can make cancer cells more sensitive to treatment while protecting normal cells from side effects. Vitamins and cardiovascular health. Vitamin K2 and heart disease. While vitamin K is primarily known for its role in blood clotting, vitamin K2, especially in its MK7 form, has garnered attention for its ability to prevent arterial calcification and improve vascular health. Recent studies suggest that vitamin K2 may help reduce the risk of Atherosclerosis, plaque buildup in the arteries, and heart disease by regulating calcium metabolism. B vitamins and homocysteine levels. High levels of homocysteine in the blood are associated with an increased risk of heart disease. Vitamins B6, B12, and folate help break down homocysteine into other substances, reducing its harmful effects. Supplementing these vitamins may help manage cholesterol levels, blood pressure, and overall heart health. Vitamins for cognitive health and neurodegenerative diseases. Vitamin B12 and cognitive decline. As we age, maintaining optimal levels of B12 is crucial for brain health. Vitamin B12 supports the production of myelin, a fatty substance that surrounds and protects nerve fibers. Deficiency in B12 is linked to memory loss, cognitive decline, and even conditions like Alzheimer's disease. Studies suggest that adequate B12 may help delay the onset or progression of neurodegenerative diseases. Vitamin E in Alzheimer's disease. Vitamin E has shown promise in protecting brain cells from oxidative damage, one of the key factors in Alzheimer's disease. High doses of vitamin E have been tested in clinical trials as a potential treatment to slow cognitive decline in Alzheimer's patients, though results are mixed and require more investigation. Nutrient-gene interactions, the future of personalized nutrition. A major frontier in vitamin research is the study of how genetic variations influence vitamin metabolism, absorption, and utilization. This can help tailor personalized nutrition plans, ensuring that individuals get the right type and dose of vitamins for their genetic profile, health status, and lifestyle factors. Vitamins and genetic variability. Folate and genetic mutations. One of the most well-studied interactions between vitamins and genetics involves folate. Certain genetic variations, such as those in the MTHFR gene, can impair the body's ability to metabolize folate. Individuals with these mutations may require higher doses of folate or its active form, L-methylfolate, to prevent health issues like birth defects and cardiovascular problems. Vitamin D and genetic variations. Some people have a genetic variant in the vitamin D receptor, VDR, which affects how their bodies use vitamin D. These individuals may need higher levels of vitamin D to achieve the same benefits as others. Genomic testing could help identify people who are at risk of vitamin D deficiency due to their genetics, leading to personalized supplementation strategies. Vitamin C and genetic expression. Emerging research shows that vitamin C may play a role in modulating gene expression and regulating the immune system. The genetic variation in SLC23A1, a gene responsible for vitamin C transport, may affect how well an individual absorbs and benefits from vitamin C. This opens up the possibility for personalized vitamin C recommendations to optimize immune function and collagen synthesis. The role of vitamins in skin health and dermatology. Skin health is a significant area of interest in vitamin research, with a growing focus on how vitamins impact everything from aging to skin conditions. Certain vitamins have demonstrated protective and therapeutic benefits for skin health. Vitamin C in collagen synthesis. Vitamin C is a crucial factor in the synthesis of collagen, a protein that provides structure and elasticity to the skin. Collagen helps maintain skin integrity and prevents wrinkles. Vitamin C is also a potent antioxidant, protecting the skin from UV-induced damage, pollution, and free radicals. Topical vitamin C has become a staple in skincare for its anti-aging properties, and studies continue to explore how vitamin C can be optimized for wrinkle reduction, hyperpigmentation, and skin tone. Vitamin A and acne treatment. Retinoids, derived from vitamin A, are among the most effective treatments for acne and blemishes. Retinoids work by promoting skin cell turnover, unclogging pores, and reducing inflammation. These benefits make vitamin A an essential part of both topical treatments and oral supplements for managing acne and other skin conditions, such as psoriasis. Retinoids and skin aging. Retinoids are also used in anti-aging treatments for their ability to stimulate collagen production and reduce fine lines and wrinkles. The future of retinoids lies in creating gentler formulations that can be used long-term without causing irritation. Vitamin D and skin protection. Vitamin D is essential for overall skin health, helping regulate skin cell growth and differentiation. Recent studies suggest that vitamin D receptors are involved in protecting the skin from UV radiation. Adequate levels of vitamin D can help reduce the risk of sunburns and premature aging caused by UV exposure. Psoriasis and vitamin D. Vitamin D is often used in topical treatments for psoriasis and other autoimmune skin disorders. Its anti-inflammatory effects help manage the symptoms of these chronic skin conditions. Sustainable approaches to vitamin production, biotechnology and agriculture. As global populations grow, the demand for vitamins will increase. The future of vitamin production will require innovative, sustainable approaches to meet the world's nutritional needs while minimizing environmental impact. Biofortification. Enhancing crops with essential vitamins. Biofortification is the process of genetically enhancing crops to increase their nutrient content. This technique has been applied to various crops to enhance their vitamin content, such as vitamin A in golden rice, vitamin D in mushrooms, and vitamin E in crops like sunflower seeds. The aim is to ensure that nutrient-rich crops are available to populations in regions where micronutrient deficiencies are prevalent. Biofortified crops could become a game-changer in improving the nutritional quality of diets globally, especially in developing countries. Sustainable vitamin production through microorganisms. Researchers are investigating ways to produce vitamins sustainably using microorganisms like bacteria, yeast, and algae. These microorganisms can be engineered to produce high quantities of essential vitamins like vitamin B12, vitamin D, and vitamin K2 without the need for animal-based products or large-scale farming. This biotechnological approach offers the potential for greener and more efficient vitamin production, reducing reliance on synthetic methods or non-sustainable agricultural practices. Conclusion: a healthier, more personalized future with vitamins. The future of vitamin science is bright, with advancements in technology, personalized medicine, and global health strategies. Through cutting-edge research, we are uncovering new ways to optimize vitamin intake, improve disease prevention, and enhance overall wellness. From gene-based nutrition to personalized supplementation, vitamins will play an increasingly important role in shaping healthier individuals and communities. As we move forward, the integration of vitamins with innovative medical treatments and sustainable production methods will help address ongoing global health challenges and ensure that essential vitamins are accessible and effective for all. Emerging vitamin therapies for chronic diseases and health conditions. Vitamins are no longer just thought of as essential nutrients for preventing deficiencies. Recent research is exploring how vitamins can serve as therapeutic agents for managing chronic diseases, inflammatory conditions, and improving overall health outcomes. Vitamin D in autoimmune diseases. Vitamin D plays a crucial role in regulating the immune system, and deficiencies have been linked to various autoimmune diseases, such as multiple sclerosis, MS, rheumatoid arthritis, RA, and type 1 diabetes. Adequate levels of vitamin D help maintain immune balance and may reduce the risk of developing autoimmune conditions or managing their symptoms. New clinical trials are investigating how vitamin D supplementation could be a cost-effective therapy to modulate immune responses, potentially slowing disease progression in conditions like MS and RA. This highlights how immune-modulating vitamins are becoming part of therapeutic regimens. Vitamins in metabolic syndrome and diabetes. Vitamins B1, B6, B12, and folic acid. Some research suggests that B vitamins could play a role in managing metabolic syndrome and type 2 diabetes, particularly by improving insulin sensitivity and reducing the risk of nerve damage, a common complication of diabetes. Vitamin B12 is essential for nerve health, and B6 helps with glucose metabolism. Vitamin D and insulin sensitivity. There is growing evidence that vitamin D can improve insulin sensitivity, which could aid in diabetes management. Studies have shown that vitamin D deficiency is associated with an increased risk of type 2 diabetes. Ongoing research is investigating whether correcting this deficiency could help prevent or Treat diabetes by restoring proper insulin function. Vitamin E and neurodegenerative diseases. Alzheimer's disease in. Vitamin E. Vitamin E is a potent antioxidant that helps protect the body from oxidative stress, a major factor in the development of Alzheimer's disease. Research suggests that vitamin E supplementation could help slow cognitive decline in individuals with mild to moderate Alzheimer's disease. Some studies are now exploring the potential of vitamin E as a neuroprotective treatment to preserve brain function. Parkinson's disease and vitamin E. In Parkinson's disease, the body experiences oxidative stress that damages neurons. Some studies have explored vitamin E as an adjunct to dopamine replacement therapies to protect against further neurological damage and potentially slow disease progression. Global efforts to address vitamin deficiencies in developing countries. Vitamin deficiencies continue to be a major global health challenge, particularly in developing countries where malnutrition is widespread. However, there are global efforts aimed at fortifying food and providing supplements to prevent and treat these deficiencies. Vitamin A deficiency and blindness. Vitamin A deficiency is a leading cause of childhood blindness and immune deficiency worldwide. It is particularly prevalent in sub-Saharan Africa and South Asia, where access to vitamin A-rich foods like liver and dairy is limited. Vitamin A fortification programs. One successful strategy has been the fortification of staple foods like rice, sugar, and cooking oils with vitamin A. Golden rice, a genetically modified strain of rice rich in beta-carotene, which the body converts into vitamin A, is being distributed in regions where vitamin A deficiency is most common. This initiative is supported by global organizations like the World Health Organization, WHO, and UNICEF. Vitamin A supplements for children. Large-scale vitamin A supplementation programs have been introduced to help prevent blindness and reduce child mortality. For example, in India, vitamin A supplementation has significantly reduced the incidence of vitamin A deficiency in young children. Folic acid and neural tube defects. Folate, vitamin B9, is critical for pregnancy, especially in the early stages, as it helps prevent neural tube defects like spina bifida and anencephaly. Despite the success of folic acid fortification in North America and some European countries, many developing nations are still lagging in these efforts. Folic acid supplementation programs. International efforts are ongoing to ensure adequate folic acid intake for women of reproductive age in low-resource settings. These efforts include distributing folic acid supplements and fortifying staple foods like wheat flour to help prevent birth defects and ensure a healthy pregnancy. Technological innovations in vitamin production. With the rise in global populations and nutritional challenges, sustainable and efficient vitamin production is becoming increasingly important. Several cutting-edge technologies are transforming how vitamins are produced and delivered to people in need. Bioengineering and sustainable vitamin production. Microbial fermentation. Microbial fermentation is a process in which microorganisms like bacteria, yeast, and fungi are used to produce vitamins in large quantities. This method is sustainable because it does not rely on traditional agricultural practices and can be done with minimal environmental impact. Vitamin B12, for example, is primarily produced through fermentation, as it's not found in plant foods, making it vital for vegans and people with B12 deficiencies. Plant-based vitamin production. Advances in genetic engineering are allowing scientists to develop plant-based systems for producing vitamins. For example, vitamin D2 can be produced from mushrooms, and vitamin A can be biofortified into crops like corn and sweet potatoes. These methods have the potential to reduce reliance on animal-based sources for vitamins and enhance the nutritional content of widely consumed crops. Personalized vitamin supplements. Using AI for tailored nutrition. Artificial intelligence, AI, and machine learning are playing a crucial role in personalizing vitamin supplementation. By analyzing an individual's genetic data, lifestyle factors, and nutritional needs, AI can recommend customized vitamin regimens that optimize health. For instance, AI-powered apps or platforms are emerging that can track vitamin intake, analyze blood tests, and provides suggestions on which vitamin supplements would benefit individuals the most based on their specific health needs and genetic makeup. The role of vitamins in aging and longevity. As the global population ages, there is increasing interest in how vitamins can help promote healthy aging, prevent age-related diseases, and enhance longevity. Certain vitamins have been studied for their potential to improve quality of life and delay the onset of age-related conditions. Vitamin D and bone health in older adults. Vitamin D is critical for maintaining bone health and preventing osteoporosis, weak bones, which becomes more prevalent with age. Older adults often have a reduced ability to produce vitamin D through sunlight exposure, leading to higher rates of vitamin D deficiency. Adequate vitamin D supplementation can help maintain bone density, reduce the risk of falls, and improve muscle function, which is especially important for aging individuals to maintain mobility and independence. Antioxidant vitamins and healthy aging. Vitamins such as vitamin C, vitamin E, and beta-carotene are antioxidants that help protect the body from oxidative stress, a contributor to cellular aging. Chronic oxidative damage can lead to age-related diseases like cardiovascular disease, Alzheimer's disease, and cancer. Vitamin E, in particular, has been shown to have protective effects against age-related eye diseases such as macular degeneration and cataracts. These antioxidants could become an integral part of anti-aging therapies, helping to preserve cellular health and promote longevity. B vitamins and cognitive function in older adults. B vitamins such as B6, B12, and folate are essential for brain health and cognitive function. Deficiencies in these vitamins have been linked to memory loss, cognitive decline, and dementia. Research into vitamin B12 supplementation has shown potential benefits in maintaining cognitive function in older adults, particularly in those with subclinical deficiencies. Ongoing studies aim to identify the role of B vitamins in protecting against cognitive decline and supporting healthy brain aging. Conclusion: the ever-evolving role of vitamins in health and medicine. The future of vitamins in medicine, nutrition, and global health is incredibly promising, with innovations in biotechnology, personalized nutrition, and global health initiatives paving the way for better disease prevention and treatment. As research continues to unlock new uses for vitamins, we may see them playing an even larger role in chronic disease management, personalized healthcare, and global health solutions. With ongoing advancements in technology, sustainable production, and an increased understanding of nutrient-genetic interactions, vitamins are poised to be at the forefront of healthcare innovations, helping individuals worldwide lead longer, healthier lives. The future of vitamins is bright, allowing for more effective and tailored health solutions, improving quality of life, and contributing to the ongoing fight against global health challenges. New frontiers in vitamin research and innovation. As vitamin research continues to evolve, we're seeing a paradigm shift in how vitamins are viewed, not just as essential nutrients but as powerful therapeutic tools for a variety of health conditions. Vitamins in cancer immunotherapy. Immunotherapy has been a groundbreaking development in cancer treatment, and now vitamins are playing an increasingly important role in enhancing its effectiveness. Vitamin D, for example, is known for its role in regulating the immune system and has shown potential in boosting the body's ability to fight off cancer cells. Vitamin C has also attracted attention in cancer research for its antioxidant properties. It's being explored in combination with conventional cancer treatments to reduce oxidative damage and support the immune system's ability to attack cancer cells. Some studies have shown that high-dose vitamin C can make chemotherapy more effective by reducing inflammation and improving tumor responses. Vitamin A derivatives, particularly retinoids, are being researched for their ability to slow the growth of cancer cells. These compounds influence gene expression and cell differentiation, and they may have a future role in cancer prevention or treatment. Role of vitamins in mental health. Research is expanding on the relationship between vitamin deficiencies and mental health disorders, such as depression, anxiety, and bipolar disorder. Some vitamins, such as B vitamins, particularly B6, B12, and folate, are vital for neurotransmitter production, which affects mood and cognitive function. Vitamin D deficiency has been linked to seasonal affective disorder, SAD, commonly known as winter depression, as well as other forms of depression. Supplementation with vitamin D is being studied to determine its potential to reduce depressive symptoms. Omega-3 fatty acids, sometimes considered a form of vitamin-like nutrients, have shown promise in supporting mental health, particularly in preventing cognitive decline and supporting individuals with schizophrenia and bipolar disorder. Vitamins in skin and hair health. The cosmetic industry has seen an explosion of products containing vitamins, particularly vitamin C and vitamin E, which are both known for their anti-aging and skin rejuvenating properties. Vitamin C is crucial for collagen synthesis, which helps maintain skin elasticity and reduce wrinkles. Additionally, it plays a key role in protecting skin from UV-induced damage and free radical formation. Biotin, a B vitamin, is essential for hair growth and strength. Deficiency can lead to brittle hair, and supplementation has become a common recommendation for those dealing with hair thinning or loss. Studies are increasingly focusing on how biotin and other B vitamins influence hair follicle health and scalp wellness. Vitamin fortification, a global health strategy. Fortification of food with essential vitamins is one of the most effective strategies to combat micronutrient deficiencies around the world. It has become a major part of public health policy in many countries. Vitamin A and blindness prevention. Vitamin A deficiency remains a leading cause of preventable childhood blindness, particularly in low-income countries. As a result, the World Health Organization, WHO, has implemented large-scale programs that fortify foods like sugar, oil, and rice with vitamin A. One innovative approach is the use of bio-fortified crops, such as golden rice, which has been genetically modified to contain higher levels of beta-carotene, the precursor to vitamin A. This is particularly impactful in countries like Bangladesh and the Philippines, where rice is a staple food. Vitamin D fortification for bone health. Vitamin D is often deficient in populations that live in regions with limited sunlight or who have lifestyles that restrict outdoor activity. Many countries have introduced fortified foods like milk, orange juice, and cereals to improve vitamin D levels in the general population. In regions with high deficiency rates, vitamin D fortification has become a public health measure to reduce the incidence of rickets and osteoporosis. In some countries, vitamin D supplementation is now provided through public health programs targeting children and the elderly to maintain bone health. Folate fortification to prevent neural tube defects. Folate, vitamin B9, is critical during pregnancy to prevent neural tube defects, NTDs, such as spina bifida and anencephaly. Many countries, including the United States, Canada, and Australia, have implemented mandatory folic acid fortification in flour to ensure that women of reproductive age have sufficient levels. This policy has had a profound effect on reducing the occurrence of NTDs. But there are ongoing discussions about whether the current levels of folic acid fortification might have broader health effects, such as increasing the risk of cancer or diabetes. Ongoing research aims to find an optimal level of fortification that maximizes benefit while minimizing risks. Innovations in sustainable vitamin production. Given the growing global demand for vitamins, the focus is shifting towards sustainable, environmentally friendly production methods that do not compromise quality or efficacy. Biotechnology and microbial production. Microbial fermentation has become a revolutionary technology for the sustainable production of vitamins. Unlike traditional methods that rely on agriculture or animal sources, microbial fermentation uses microorganisms, bacteria, yeast, fungi, to produce large quantities of vitamins in an environmentally sustainable way. Vitamin B12, vitamin D, and vitamin K2 are among the most commonly produced vitamins through fermentation, enabling the production of vegan-friendly supplements that don't rely on animal-derived sources. Plant-based and algae-based production. Algae and other plant-based sources are also emerging as sustainable and eco-friendly alternatives for vitamin production. Algae, for example, is being used to produce vitamin D3, a form traditionally sourced from lanolin, sheep's wool, making it more accessible for vegans and those seeking plant-based options. Plant-based vitamin C is often extracted from citrus fruits or acai berries, offering a more sustainable and environmentally friendly alternative to synthetic versions. This could become more prevalent as consumers seek out organic or green certified supplements. The role of vitamins in global health policies. Vitamin deficiencies continue to impact millions of people worldwide, especially in low-resource areas. The role of vitamins in public health policy is crucial to address these challenges. Global guidelines and policies. The World Health Organization, WHO, UNICEF, and other international organizations have long advocated for vitamin supplementation programs to combat deficiencies. This includes vitamin A supplementation for children, vitamin D fortification for the elderly, and folic acid for pregnant women. Global health initiatives are working to integrate vitamin-based nutrition into national dietary guidelines and policies. This could include mandatory fortification, supplementation programs, and public education on the importance of balanced nutrition and micronutrient intake. International organizations are also partnering with private sector companies to ensure that vitamins are made affordable and accessible in developing countries through initiatives like vitamin fortification of staple foods. The role of vitamins in preventive healthcare. Preventive healthcare is becoming a priority as healthcare systems face pressure from aging populations and rising chronic diseases. Vitamins are gaining recognition as part of preventive strategies for conditions such as cardiovascular disease, diabetes, and cognitive decline. Countries that invest in nutritional health policies, including the fortification of foods with essential vitamins or the provision of supplementation, often see improvements in public health outcomes, such as lower rates of birth defects or reduced hospitalizations for nutrient-related diseases. Conclusion: a bright future for vitamins in health. The future of vitamins in global health is expansive and full of possibilities. From therapeutic applications in chronic disease management to global initiatives aimed at combating micronutrient deficiencies, vitamins will continue to play a crucial role in shaping the future of personalized healthcare, public health policies, and sustainable production practices. As we advance in our understanding of nutrient-gene interactions, biotechnology, and innovative delivery methods, we will likely see even more customized vitamin therapies that address specific needs of populations, helping to optimize health outcomes across the globe. The future of vitamins in modern medicine. Vitamins as precision medicine tools. Precision medicine is a cutting-edge approach to healthcare that tailors treatments based on individual characteristics, such as genetics, environment, and lifestyle. Vitamins are increasingly being seen as crucial components of precision nutrition, personalized vitamin regimens that cater to the unique genetic makeup and health needs of individuals. For example, a person's genetic predisposition to deficiencies in certain vitamins, like vitamin D, B12, or folate, can be identified through genetic testing, which then informs a personalized supplementation plan. By addressing micronutrient imbalances, these targeted vitamin interventions can potentially prevent or manage diseases such as diabetes, cardiovascular issues, and neurological disorders. Nanotechnology and vitamin delivery. Nanotechnology is being explored as a method to enhance vitamin delivery systems. By using nanoparticles, vitamins can be encapsulated to protect them from degradation in the digestive system, ensuring that they are released in optimal amounts and at the right time within the body. For example, nanoencapsulation of vitamins like vitamin C or vitamin D could improve their absorption and bioavailability, leading to more effective supplementation, especially in cases where individuals have poor absorption due to conditions like Crohn's disease or celiac disease. In the future, nanotechnology-based vitamin supplements might become more common, offering targeted delivery to specific tissues or organs, such as bone tissue for vitamin D or the brain for B. Vitamins involved in cognitive function. Emerging trends in vitamin supplements and health trends. Plant-based and vegan vitamin supplements. The growing popularity of plant-based and vegan diets has led to an increased demand for plant-derived vitamins and supplements. For example, vitamin D3, traditionally sourced from lanolin, from sheep's wool, is now being synthesized from lichen, a plant-based source. This allows vegans and those avoiding animal products to access vitamin D3, which has superior bioavailability compared to vitamin D2. Similarly, B12 supplements are essential for vegans since vitamin B12 is primarily found in animal products. Plant-based or microbial fermentation B12 is gaining popularity as a vegan-friendly source that provides an effective, non-animal derived form of this essential nutrient. These dietary shifts are prompting the vitamin industry to explore more sustainable and ethical sources for vitamins and supplements, ensuring that products align with the values of eco-conscious and health-focused consumers. Adaptogenic vitamins and stress relief. The increasing awareness of stress and its detrimental effects on health has led to the rise of adaptogens, substances that help the body adapt to stress and maintain balance. Certain vitamins, such as vitamin C, are becoming associated with adaptogenic effects, helping the body cope with stress and fatigue. Adaptogenic blends that combine vitamins with herbs like ashwagandha, rhodiola, and holy basil are gaining popularity. These formulations aim to provide comprehensive support for mental wellness, promoting resilience against stress while supporting immune function and energy levels. Moreover, B vitamins, particularly B6 and B12, are also gaining recognition for their role in stress management. They are critical for neurotransmitter synthesis, such as serotonin and dopamine, which help regulate mood and cognitive function. Gut health and vitamins. Gut health has become a key focus of modern health trends, with a growing understanding of the gut-brain axis and its connection to overall well-being. Vitamins play a significant role in maintaining gut health by supporting microbiota diversity and the intestinal barrier. Vitamin D is crucial for regulating the immune system within the gut, and deficiencies have been linked to inflammatory bowel diseases like Crohn's disease and ulcerative colitis. Ensuring adequate levels of vitamin D may help maintain a healthy gut microbiome and prevent disease flare-ups. Additionally, vitamin A, through its active form retinoic acid, helps regulate the integrity of the intestinal lining, ensuring that the gut remains resilient to infections and inflammation. Vitamin B12 is also critical for gut health, as it is necessary for the production of red blood cells and DNA synthesis, both of which are vital for maintaining gut cell function. The role of vitamin supplementation in wellness tourism. As wellness tourism grows, vitamin-infused treatments and supplements are becoming popular. Spas, retreats, and resorts are integrating vitamin therapies like IV drips, vitamin facials, and nutrient-rich supplements into their services to attract health-conscious travelers. Some luxury wellness centers offer customized vitamin infusions designed to boost energy levels, skin health, or immune function. For instance, vitamin C infusions are promoted for their ability to detoxify and hydrate the body, while vitamin B12 shots are sought after for increased vitality and mental clarity. Global initiatives to tackle vitamin deficiencies. World Health Organization, WHO, initiatives. The WHO has long recognized the importance of vitamins in preventing malnutrition. Global initiatives continue to fight micronutrient deficiencies, with a focus on vitamin A, iron, vitamin D, and folic acid in vulnerable populations, in regions like Africa, Asia, and Latin America. The WHO supports fortification programs for staple foods and ensures that pregnant women receive essential supplements like iron and folic acid to prevent birth defects and other complications. Vitamin A supplementation, in particular, has been a major focus. The WHO has a Vitamin A global initiative that distributes high-dose vitamin A capsules to children in developing nations to prevent childhood blindness and reduce mortality rates. National policies on vitamin fortification. Many countries have introduced national fortification programs to address widespread vitamin deficiencies. In India, for example, the government is expanding its efforts to fortify wheat flour with vitamin A and iron to combat anemia and vitamin A deficiency among children and pregnant women. Similarly, Brazil has implemented fortification programs for vitamin D in milk and other dairy products to combat widespread deficiencies due to limited sun exposure, particularly in the southern regions of the country where winters are long and cold. The role of the private sector in vitamin accessibility. Private companies are increasingly working with governments and NGOs to help provide affordable vitamins to populations in need. Many large companies in the nutraceutical and food industry have committed to fortifying basic food items such as rice, flour, and salt with vitamins to improve nutrition on a global scale. Additionally, vitamin distribution networks are expanding to reach remote areas and underserved populations. Companies are focusing on sustainable packaging and direct-to-consumer delivery models to increase access to vitamin-rich foods and supplements, even in low-income regions. The intersection of vitamins and health technology. Wearable technology for nutrient monitoring. Wearable devices and smart health trackers are emerging as tools that can monitor a variety of health metrics, including vitamin levels. Some cutting-edge technologies may soon allow individuals to track their nutrient intake in real time and receive personalized recommendations for vitamin supplements or dietary adjustments. Future smart glasses or patches could even assess the skin or blood for nutrient deficiencies, providing instant feedback on the user's vitamin status. This could revolutionize the way individuals manage their health and prevent chronic diseases associated with nutrient deficiencies. AI-driven personalized nutrition. Artificial intelligence, AI, is making significant strides in creating personalized vitamin regimens. By analyzing genomic data, lifestyle habits, dietary patterns, and health conditions, AI can recommend specific vitamin supplements or dietary changes that will optimize a person's health. AI can also predict the risk of deficiency-related diseases based on a person's health history, genetic profile, and lifestyle, enabling preventive healthcare that includes vitamin-based therapies tailored to an individual's needs. Conclusion: a future of optimized health through vitamins. As the scientific community continues to explore the multifaceted roles of vitamins in human health, the future holds immense potential for innovative applications of vitamins in medicine, global health initiatives, and sustainable production methods. Vitamins will remain central in the fight against malnutrition, the prevention of chronic diseases, and the pursuit of personalized healthcare solutions that will improve global health outcomes and enhance individual well-being. From precision medicine to global fortification programs, vitamins are poised to play a vital role in shaping the future of healthcare, ensuring a healthier and more sustainable world. The integration of vitamins in emerging healthcare models. The role of vitamins in functional medicine. Functional medicine is an emerging model of healthcare that focuses on identifying and addressing the root causes of disease, rather than just treating symptoms. Vitamins play a pivotal role in this approach, as they are essential for optimizing cellular function and preventing chronic conditions. In functional medicine, vitamins are used not only to correct deficiencies but also to enhance metabolic processes, hormonal balance, and gut health. Vitamin C, for instance, is utilized in its antioxidant capacity to support immune function and protect against cellular aging. Similarly, B vitamins are crucial for detoxification and energy production. Personalized vitamin regimens are often part of a functional medicine practitioner's recommendations. These regimens are tailored to an individual's genetic makeup, medical history, dietary habits, and environmental factors, with the goal of achieving optimal wellness and preventing disease. Vitamins in the context of holistic health. Holistic health emphasizes the integration of mind, body, and spirit in achieving wellness. Vitamins play a significant role in this approach, particularly in supporting mental health and cognitive function. Vitamin D, for example, is not only crucial for bone health but has been linked to mental wellness, with deficiencies often being associated with depression and anxiety. Adequate vitamin D levels can help regulate mood and cognitive function, contributing to a more balanced and healthy mental state. Magnesium, often grouped with vitamins in health discussions, is another key nutrient in holistic health. It supports nerve function, sleep quality, and muscle relaxation. And deficiencies are associated with conditions like insomnia and muscle cramps. Additionally, holistic health practitioners might combine vitamins with herbal remedies and mind-body techniques, such as meditation or yoga, to create a comprehensive plan for improving physical and mental health. The impact of global lifestyle changes on vitamin needs. The role of vitamins in the age of digital health. As we transition into a more digitally connected world, screen time and sedentary lifestyles have become widespread. The modern digital age and technological advancements often mean fewer people spend time outdoors, leading to a rise in vitamin D deficiencies. This is especially true in regions where people experience long winters, or where urbanization has led to limited exposure to natural sunlight. Research shows that prolonged exposure to digital screens can also lead to eye strain, which is often mitigated with supplements like vitamin A and vitamin C, both of which play roles in maintaining eye health. Additionally, blue light exposure from screens has raised concerns over its impact on skin aging, prompting interest in antioxidant-rich vitamins like vitamin C and vitamin E for skin protection. The increased use of fitness trackers, wearable health devices, and mobile health apps has also contributed to greater awareness about the role of vitamins in maintaining optimal health. These tools allow individuals to monitor their health metrics, including dietary intake and vitamin levels, in real time, leading to more informed decisions about supplementation and lifestyle changes. Vitamins and the rise of plant-based diets. The surge in plant-based eating and veganism has led to a heightened focus on nutrient deficiencies, particularly in vitamins that are more commonly found in animal-based foods. Vitamin B12 is the most prominent nutrient that vegans need to supplement, as it's primarily found in animal products. To meet the demand for plant-based vitamins, there is a growing market for fortified plant-based products. These include plant milks, tofu, and nutritional yeast, which are often fortified with vitamin B12, vitamin D, and calcium. The ability to create plant-based supplements and fortified products ensures that people following plant-based diets can maintain their health without relying on animal sources of nutrients. The trend towards plant-based eating has also led to a surge in interest in phytonutrients, plant-derived compounds that offer antioxidant and anti-inflammatory benefits. These compounds often work synergistically with vitamins to promote overall health, particularly in terms of immune function and heart health. Future applications of vitamins in biotechnology. Genetically engineered crops for vitamin production. Biotechnology continues to make significant strides in developing genetically engineered crops that can produce higher levels of essential vitamins. Golden rice. A genetically modified rice variety is a prime example. It has been engineered to produce beta-carotene, a precursor to vitamin A, and is being used as a solution to combat vitamin A deficiency in developing countries. Another exciting innovation in this field is the development of vitamin-rich algae, which can be grown more sustainably than traditional crops. Algae can produce vitamins, particularly vitamin D and omega-3 fatty acids, in high concentrations, making it a promising candidate for biofortification. Genetically modified plants could provide an abundant and cost-effective means of supplying essential vitamins to areas of the world where micronutrient deficiencies are prevalent. As biotechnology improves, we may see the introduction of crops that provide a complete package of essential vitamins in a single food source. Artificial intelligence and vitamin development. Artificial intelligence, AI, is expected to play a crucial role in the future of vitamin research and development. By using machine learning algorithms to analyze vast amounts of data on nutrient profiles, genetic predispositions, and health outcomes, AI could help identify new vitamin combinations or optimized dosages for specific health conditions. AI could also be instrumental in predictive modeling for vitamin deficiencies, enabling healthcare professionals to provide proactive care before deficiencies lead to disease. By analyzing patterns in dietary habits, genetic markers, and environmental factors, AI systems could suggest personalized supplementation protocols for individuals at risk of deficiencies or nutrient imbalances. Vitamins and environmental sustainability. Sustainable vitamin production. As the global demand for vitamins rises, so does the need for sustainable production methods. The traditional production of vitamins, particularly those that require animal sources or synthetic processes, can have significant environmental impacts. There is a growing emphasis on developing more sustainable and eco-friendly production techniques. Fermentation is an increasingly popular method for producing vitamins in a sustainable way. Microbial fermentation can produce large quantities of vitamins, like B12 and D3, without relying on animal byproducts or significant land use. This method uses microorganisms, such as yeasts or bacteria, to produce the vitamins in a controlled, scalable environment with minimal environmental footprint. Algae-based vitamin production is another promising area of development. Algae can be cultivated with minimal resources, requiring only water, sunlight, and carbon dioxide, making it an environmentally sustainable option for large-scale vitamin production. Algal-derived omega-3s and vitamin D are already available on the market and are gaining popularity as plant-based alternatives. Waste reduction and vitamin recycling. In an effort to tackle food waste and improve resource efficiency, some researchers are exploring the possibility of recycling nutrients from food scraps and agricultural waste to create vitamin-rich supplements. For instance, waste streams from food processing or agricultural byproducts could be transformed into vitamin-rich compounds, providing a sustainable solution to meet global vitamin demands without depleting natural resources. Conclusion: a bright and balanced future for vitamins. The future of vitamins is full of promise, not just for improving individual health, but for transforming global health and addressing public health challenges across the world. With advances in biotechnology, sustainable agriculture, and personalized healthcare, vitamins are poised to play an even larger role in preventive medicine, chronic disease management, and health optimization. As new technologies like AI, nanotechnology, and precision medicine continue to advance, vitamins will increasingly become tailored to the individual, ensuring that everyone has access to the right nutrients at the right time. With these innovations, the world will move closer to solving global health issues, reducing nutrient deficiencies, and improving overall quality of life. Emerging areas of vitamin research. The role of vitamins in aging in longevity. As the global population ages, age-related diseases like Alzheimer's, osteoporosis, and cardiovascular conditions are becoming more common. Vitamins are being extensively studied for their potential to slow aging and extend healthy lifespan. Vitamin D has received a great deal of attention due to its role in bone health and its connection to reducing the risk of age-related diseases. Research has also suggested that vitamin D deficiency could accelerate age-related cognitive decline, especially in older adults. Antioxidant vitamins such as vitamin C and vitamin E are also being studied for their potential to combat oxidative stress, a key contributor to aging. These vitamins help neutralize free radicals, which are reactive molecules that can damage cells, proteins, and DNA, leading to the aging process. Furthermore, vitamin A, in its retinoid form, is being investigated for its potential to support skin regeneration and reduce the appearance of wrinkles, with some studies suggesting that it can influence genes involved in the maintenance of youthful skin. Vitamins and metabolic health. The role of vitamins in metabolic health has become a hot topic of research, particularly in relation to obesity, insulin resistance, and type 2 diabetes. Vitamin D and vitamin B12 are both being explored for their potential roles in insulin sensitivity. Some studies suggest that vitamin D supplementation may help individuals with insulin resistance, a condition where the body's cells do not respond well to insulin, leading to elevated blood sugar levels. It is hypothesized that vitamin D may improve insulin secretion or enhance glucose uptake by cells. Vitamin B1, thiamine, is also being researched for its potential to prevent diabetic complications. Thiamine deficiency has been associated with nerve damage, neuropathy, in people with diabetes. Supplementing with thiamine could, therefore, help prevent such complications. Vitamin K and bone and cardiovascular health. Vitamin K is often overlooked, but its role in bone and cardiovascular health is gaining more attention. Vitamin K2, in particular, has been shown to support bone mineralization by activating proteins that help bind calcium to the bone matrix, thereby strengthening bones and preventing osteoporosis. In addition to its role in bone health, vitamin K2 has been shown to prevent the deposition of calcium in arterial walls, reducing the risk of arterial calcification, which is a significant contributor to cardiovascular diseases. As research in this area continues, vitamin K supplementation may emerge as a preventive measure against cardiovascular disease. Innovations in vitamin delivery systems, smart vitamin supplements, precision and personalization. Advances in biotechnology and AI are paving the way for smart vitamin supplements that are personalized to meet an individual's specific health needs. These supplements would adjust their content and dosage based on factors like age, genetic predisposition, dietary habits, and lifestyle changes. Companies are already exploring digital tools and apps that allow users to track their vitamin intake and recommend real-time adjustments based on current blood levels or nutrient needs. For example, a person's vitamin D levels could be monitored using a wearable device, and their supplement regimen could be updated automatically if their levels drop below optimal thresholds. Furthermore, capsule designs are becoming more sophisticated, with new microsphere-based systems that can release vitamins in stages, ensuring longer-lasting effects throughout the day. This gradual release system could potentially increase the bioavailability of vitamins, improving their effectiveness and reducing the risk of side effects from high dosages. Vitamin-infused food and drink. The idea of functional foods and beverages that contain added vitamins and minerals has expanded beyond fortified cereals and juices. Now, companies are exploring new ways to infuse vitamins into a broader range of products such as plant-based snacks, ready-to-drink beverages, smoothies, and even gummies that target specific health concerns. For example, vitamin C-infused water or vitamin D-boosted coffee are part of a growing market designed to meet the needs of busy consumers who are looking for ways to improve their health while on the go. This form of delivery is particularly popular in the wellness community, where vitamins like B-complex and vitamin D are often added to drinks that promote energy, immunity, and overall wellness. 3D printed vitamins. 3D printing technology has the potential to revolutionize how vitamins are delivered to consumers. 3D printed vitamins could be customized in terms of shape, size, dosage, and vitamin combination based on individual needs. This could allow for more precise control over how vitamins are consumed. For instance, someone might receive a customized 3D- printed tablet that combines their daily dose of vitamin D, B12, and magnesium, all in a single, tailored dose. Global health challenges and vitamins. Vitamin A and public health. Vitamin A deficiency is a significant public health problem, particularly in developing countries, where it can lead to blindness, weakened immune systems, and increased mortality rates. Efforts to combat this issue include large-scale fortification programs, where staple foods like rice or sugar are fortified with vitamin A. One of the most impactful interventions has been the distribution of high-dose vitamin A supplements to children, which has dramatically reduced the rates of childhood blindness and death from preventable infections. Additionally, biofortified crops, like golden rice, genetically modified to contain more vitamin A, are showing promise in areas where traditional sources of vitamin A are scarce. Vitamin D deficiency and the global impact. Vitamin D deficiency has become a global epidemic, affecting people in both developed and developing countries, particularly those living in areas with limited sunlight. It's linked to bone diseases like rickets, osteomalacia, and osteoporosis, as well as muscle weakness and an increased risk of heart disease and cancer. In response, public health organizations are advocating for vitamin D fortification in milk, cereals, and other food products. Some countries, like the United Kingdom and Canada, have already implemented mandatory fortification of milk with Vitamin D to combat the widespread deficiency. The growing trend of indoor lifestyles, combined with fears of skin cancer from sun exposure, has contributed to the rising prevalence of vitamin D deficiency. As a result, more attention is being paid to sunlight exposure and supplementation to improve vitamin D levels, particularly in elderly populations, who are more susceptible to bone fractures and chronic diseases related to vitamin D deficiency. Vitamins and mental health. The role of vitamins in depression and anxiety. There is an increasing body of research suggesting that vitamin deficiencies, particularly in vitamins D, B12, folate, and C, are linked to mental health disorders, including depression, anxiety, and cognitive decline. Vitamin D, in particular, has been associated with mood regulation and the prevention of seasonal affective disorder, SAD, a type of depression that occurs during the winter months when exposure to sunlight is limited. Supplementation with vitamin D has shown promise in improving symptoms of depression and supporting overall mental health. B vitamins, especially B6, B12, and folate, play a role in the synthesis of neurotransmitters such as serotonin, dopamine, and norepinephrine, which help regulate mood and cognitive function. Deficiencies in these vitamins have been linked to depression and cognitive decline in older adults. As a result, mental health professionals are increasingly considering vitamin supplementation as part of a holistic approach to managing mental health conditions, alongside therapies such as cognitive behavioral therapy, CBT, and medication. Conclusion: a world of possibilities for vitamins. The future of vitamins is an exciting and dynamic one, driven by the continuous advancements in technology, nutrition science, and biotechnology. Vitamins will not only continue to be critical in disease prevention, but they will also play a vital role in personalized health strategies, sustainable agriculture, and addressing global public health challenges. As research continues, we may uncover new ways that vitamins influence biological systems, providing even greater insight into how these essential nutrients can be used to optimize health, prevent disease, and ultimately improve the well-being of individuals across the globe. The role of vitamins in environmental health and sustainability. Vitamins in sustainable agriculture. As global food systems face mounting challenges like climate change, soil degradation, and the need for greater food security, vitamins are playing a role in the sustainability of agriculture. The biofortification of staple crops like cassava, maize, and wheat to increase their vitamin content offers a promising solution to nutrient deficiencies in regions where access to diverse diets is limited. For example, biofortified crops can provide higher levels of vitamin A, iron, and zinc. This technology reduces the need for external supplementation while helping improve nutritional outcomes in areas that rely heavily on a few crops for sustenance. The application of biotechnology to improve nutrient density directly in crops helps build more resilient agricultural systems, which is essential for long-term food security. Vertical farming and aquaponics systems are also being explored as sustainable methods for producing vitamin-rich foods in urban areas. These systems not only reduce the carbon footprint of food production but also enhance access to fresh, nutritious foods with higher levels of essential vitamins. Vitamins and climate change. With the growing concern over climate change, the demand for climate-resilient foods with higher nutritional value is on the rise. While climate change threatens food security and increases the risk of nutrient deficiencies, vitamins can help counteract some of the negative impacts on human health. Research suggests that the nutrient content of crops, including vitamins, may be affected by changing climate conditions such as higher CO2 levels, temperature fluctuations, and altered precipitation patterns. These environmental shifts may reduce the nutrient density of certain crops, making vitamin deficiencies even more prevalent in affected areas. However, climate-smart agriculture, which incorporates sustainable farming techniques, can help address these challenges. Innovative farming technologies, such as drought-resistant crops and hydroponics, could play a vital role in ensuring that foods continue to provide the necessary vitamins and nutrients despite changing environmental conditions. The growing intersection of vitamins and technology. AI and big data. revolutionizing vitamin research. Artificial intelligence, AI, and big data are changing the landscape of vitamin research. By analyzing massive data sets from clinical trials, health records, dietary surveys, and genetic profiles, AI can uncover hidden patterns and correlations between vitamin intake and health outcomes.